It's going to be a long day. Are you guys ready to learn Bash? Section 1.1. What is Bash? Bash is the shell, or command language interpreter, for the GNU operating system. The name is an acronym for the Born-Again Shell, a pun on Stephen Bourne, the author of the direct ancestor of the current Unix shell, SH, which appeared in the 7th edition Bell Labs research version of Unix. Bash is largely compatible with SH and incorporates useful features from the Korn shell, KSH, and the C shell, CSH. It is intended to be a conformant implementation of the IEEE Posix shell and tools portion of the IEEE Posix specification, IEEE standard 1003.1. It offers functional improvements over SH for both interactive and programming use. While the GNU operating system provides other shells, including a version of CSH, Bash is the default shell. Like other GNU software, Bash is quite portable. It currently runs on nearly every version of Unix and a few other operating systems. Independently supported ports exist for MS-DOS, OS/2, and Windows platforms. 1.2. What is a shell? At its base, a shell is simply a macro processor that executes commands. The term macro processor means functionality where text and symbols are expanded to create larger expressions. A Unix shell is both a command interpreter and a programming language. As a command interpreter, the shell provides the user interface to the rich set of GNU utilities. The programming language features allow these utilities to be combined. Files containing commands can be created and become commands themselves. These new commands have the same status as system commands in directories such as bin, allowing users or groups to establish custom environments to automate their common tasks. Shells may be used interactively or non-interactively. In interactive mode, they accept input typed from the keyboard. When executing non-interactively, shells execute commands read from a file. A shell allows execution of GNU commands, both synchronously and asynchronously. The shell waits for synchronous commands to complete before accepting more input. Asynchronous commands continue to execute in parallel with the shell while it reads and executes additional commands. The redirection constructs permit fine-grained control of the input and output of these commands. Moreover, the shell allows control over the contents of commands environments. Shells also provide a small set of built-in commands, see built-ins, implementing functionality impossible or inconvenient to obtain via separate utilities. For example, cd, break, continue, and exec cannot be implemented outside of the shell because they directly manipulate the shell itself. The history, getOpts, kill, or pwd built-ins, among others, could be implemented in separate utilities, but they're more convenient to be used as built-in commands. All of the shell built-ins are described in subsequent sections. While executing commands is essential, most of the power and complexity of shells is due to their embedded programming languages. Like any high-level language, the shell provides variables, flow control constructs, quoting, and functions. Shells offer features geared specifically for interactive use rather than to augment the programming language. These interactive features include job control, command line editing, command history, and aliases. Each of these features is described in this manual. Chapter 2, Definitions. These definitions are used throughout the remainder of this manual. POSIX, a family of open system standards based on Unix. Bash is primarily concerned with the shell and utilities portion of the POSIX 1003.1 standard. Blank, a space or tab character. Built-in, a command that's implemented internally by the shell itself rather than by an executable program somewhere in the file system. Control operator, a token that performs a control function. It is a new line or one of the following: double pipe, double ampersand, single ampersand, semicolon, double semicolon, semicolon ampersand, double semicolon ampersand, pipe, pipe ampersand, open parenthesis or close parenthesis. Exit status, the value returned by a command to its caller. The value is restricted to 8 bits, so the maximum value is 255. Field, a unit of text that is the result of one of the shell expansions. After expansion, when executing a command, the resulting fields are used as the command name and arguments. File name, a string of characters used to identify a file. Job, a set of processes comprising a pipeline and any processes descended from it that are all in the same process group. Job control, a mechanism by which users can selectively stop, suspend, and resume execution of processes. Meta character, a character that, when unquoted, separates words. A meta character is a space, tab, new line, or one of the following characters. Pipe, ampersand, semicolon, open parenthesis, close parenthesis, open, what do you call these? Less than or greater than. Name, a word consisting solely of letters, numbers, and underscores, and beginning with a letter or underscore. Names are used as shell variables and function names, also referred to as an identifier. Operator, a control operator or a redirection operator. See redirections for a list of redirection operators. Operators contain at least one unquoted meta character. Process group, a collection of related processes, each having the same process group ID. Process group ID, a unique identifier that represents a process group during its lifetime. Reserved word, a word that has a special meaning to the shell. Most reserved words introduce shell flow control constructs, such as for and while. Return status, a synonym for exit status. Signal, a mechanism by which a process may be notified by the kernel of an event occurring in the system. Special built-in, a shell built-in command that has been classified as special by the Posix standard. Token, a sequence of characters considered a single unit by the shell. It's either a word or an operator. Word, a sequence of characters treated as a unit by the shell. Words may not include unquoted meta characters. All right. That's a good definition list. Chapter 3, Basic Shell Features. Bash is an acronym for Born Again Shell. The Bourne shell is the traditional Unix shell originally written by Stephen Bourne. All of the Bourne shell built-in commands are available in Bash. The rules for evaluation and quoting are taken from the Posix specification for the standard Unix shell. This chapter briefly summarizes the shell's building blocks: commands, control structures, shell functions, shell parameters, shell expansions, redirections, which are a way to direct input and output from and to named files, and how the shell executes commands. 3.1 Shell syntax. When the shell reads input, it proceeds through a sequence of operations. If the input indicates the beginning of a comment, the shell ignores the comment symbol, hashtag, and the rest of that line. Otherwise, roughly speaking, the shell reads its input and divides the input into words and operators, employing the quoting rules to select which meanings to assign various words and characters. The shell then parses these tokens into commands and other constructs, removes the special meaning of certain words or characters, expands others, redirects input and output as needed, executes the specified command, waits for the command's exit status, and makes that exit status available for further inspection or processing. 3.1.1 Shell operation. The following is a brief description of the shell's operation when it reads and executes a command. Basically, the shell does the following. Reads its input from a file, see shell scripts, from a string supplied as an argument to the -c invocation option, see invoking bash, or from the user's terminal. 2. breaks the input into words and operators, obeying the quoting rules described in quoting. These tokens are separated by meta characters. Alias expansion is performed by this step. See aliases. 3. Parses the tokens into simple and compound commands. See shell commands. 4. Performs the various shell expansions. See shell expansions, breaking the expanded tokens into lists of file names. See Filename Expansion, and commands and arguments. 5. Performs any necessary redirections. See Redirections, and removes the redirection operator and their operands from the argument list. 6. Executes the command. See Executing Commands. 7. Optionally waits for the command to complete and collects its exit status. See Exit Status. 3.1.2 Quoting. Quoting is used to remove the special meaning of certain characters or words to the shell. Quoting can be used to disable special treatment for special characters, to prevent reserved words from being recognized as such, and to prevent parameter expansion. Each of the shell meta characters, see definitions, has special meaning to the shell and must be quoted if it is to represent itself. When the command history expansion facilities are being used, see history expansion, the history expansion character, usually exclamation mark, must be quoted to prevent history expansion. See bash history facilities for more details concerning history expansion. There are 3 quoting mechanisms: the escape character, single quotes, and double quotes. 3.1.2.1 Escape character. A non-quoted backslash is the bash escape character. It preserves the literal value of the next character that follows it, with the exception of new line. If a slash new line pair appears and the backslash itself is not quoted, the slash new line is treated as a line continuation. That is, it is removed from the input stream and effectively ignored. Uh-oh. Uh-oh. I don't want to search. How do I not search? Uh-oh. Uh-oh. I hit the wrong button. 3.1.2.2 Single quotes. Enclosing characters in single quotes preserves the literal value of each character within the quotes. A single quote may not occur between single quotes, even when preceded by a backslash. 3.1.2.3 Double quotes. Enclosing characters in double quotes preserves the literal value of all characters within the quotes, with the exception of $, backtick, backslash, and, when history expansion is enabled, exclamation mark. When the shell is in Posix mode, see bash Posix mode, the exclamation mark has no special meaning within double quotes, even when the history expansion is enabled. The characters $ and backtick retain their special meaning within double quotes. See shell expansions. The backslash retains its special meaning only when followed by one of the following characters: $, backtick, double quote, backslash, or new line. Within double quotes, backslashes that are followed by one of the characters are removed. Backslashes preceding characters without a special meaning are left unmodified. A double quote may be quoted within double quotes by preceding it with the backslash. If enabled, history expansion will be performed unless an exclamation mark appearing in double quotes is removed using a backslash. The backslash preceding the exclamation mark is not removed. The special parameters star and @ symbol have special meaning when in double quotes. See shell parameter expansion. 3.1.2.4 ANSI C quoting. Character sequences of the form $single quotes string are treated as a special kind of single quotes. The sequence expands to string, with backslash escaped characters in string replaced as specified by the ANSI C standard. Escape sequences, if present, are decoded as follows. \A, alert bell. \B, backspace. \E or uppercase E, an escape character, not ANSI C. \F, form feed. \N, new line. \R, carriage return. \T, horizontal tab. \V, vertical tab. Double backslash, single quote is a single quote. Double quote is a double quote. Question mark is a question mark. \NNN, the 8-bit character whose value is the octal value NNN, 1 to 3 octal digits. \XHH, the 8-bit character whose value is the hexadecimal value HH, 1 or 2 hex digits. \UHHHH, the Unicode ISO IEC 10646 character whose value is the hexadecimal value HHHH, 1 to 4 hex digits. /U HHHHHHH, the Unicode ISO IEC 10646 character whose value is the hexadecimal value HHHHHHH, 1 to 8 hex digits. \CX, a control X character. The expanded result is single quoted as if the $ had not been present. I need some water. What did you say in chat? I remember you're working on a project to build a web server. It's good. You can check out the website. 3.1.2.5 locale specific translation. Prefixing a double quoted string with a $, such as $, double quotes, hello world, will cause the string to be translated according to the current locale. The getText infrastructure performs the lookup and translation using the LC messages, text domain dir, and text domain shell variables, as explained below. See the getText documentation for additional details not covered here. If the current locale is C or POSIX, if there are no translations available, or if the string is not translated, the $ is ignored. Since this is a form of double quoting, the string remains double quoted by default, whether or not it is translated and replaced. If the no expand translation option is enabled using the shopped built-in, translated strings are single quoted instead of double quoted. The result of this section is a brief overview of how you use the getText to create translations for strings in a shell script named script name. There are more details in the getText documentation. Creating internationalized scripts. Once you've marked the strings in your script that you want to translate using double quotes, you create a getText template file using the command bash --dump -po -strings script name greater than domain.pot. The domain is your message domain. It's just an arbitrary string that's used to identify the file's getText needs, like a package or script name. It needs to be unique among all the message domains on systems where you install the translations, so getText knows which translations correspond to your script. You'll use the template file to create translations for each target language. The template file conventionally has the suffix .pot. You copy this template file to a separate file for each target language you want to support, called PO files, which use the suffix .po. PO files use various naming conventions, But when you're working to translate a template file into a particular language, you first copy the template file to a file whose name is the language you want to target with the .po suffix. For instance, the Spanish translations of your strings would be in a file named es.po, and to get started using a message domain named example, you would run cp example.pot es.po. Ultimately, PO files are often named domain.po and installed in directories that contain multiple translation files for a particular language. Whichever naming convention you use, you will need to translate the strings in the PO files into the appropriate languages. This has to be done manually. When you have the translations and PO files complete, you'll use the getText tool to produce what are called MO files, which are compiled versions of the PO files the getText tools use to look up translations efficiently. MO files are also called message catalog files. You use the message format program to do this. For instance, if you had a file with Spanish translations, you could run message format space -o space es.mo space es.po to produce the corresponding MO file. Once you have the MO files, you decide where to install them and use the text domain dir shell variable to tell the getText tools where they are. Make sure to use the same message domain to name the MO files as you did for the PO files when you install them. Your users will use the lang or lc messages shell variables to select the desired language. You set the text domain variable to the script's message domain. As above, you use the message domain to name your translation files. You, or possibly your users, set the text domain dir variable to the name of a directory where the message catalog files are stored. If you install the message files into the system's standard message catalog directory, you don't need to worry about this variable. The directory where the message catalog files are stored varies between systems. Some use the message catalog selected by the lc messages shell variable. Others create the name of the message catalog from the value of the text domain shell variable, possibly adding the .mo suffix. If you use the text domain variable, you may need to set the text domain dir variable to the location of the message catalog files as above. It's common to use both variables in this fashion. Text domain dir /lc underscore messages /lc underscore messages /text domain.mo. If you used that last convention and you wanted to store the message catalog files with Spanish ES and Esperanto EO translations into a local directory you use for custom translation files, you could run text domain equals example, text domain dir equals /user/local/share/locale, cp space es.mo space $ curly braces text domain dir /es/lc messages $ curly braces text domain.mo, and then cp space eo.mo space $ curly braces text domain dir /eo/lc underscore messages $$ curly braces text domain.mo. When all of this is done and the message catalog files containing the compiled translations are installed in the correct location, your users will be able to see translated strings in any supported languages by setting the lang and or lc messages environment variables before running your script. Chapter 3.1.3 Comments. In a non-interactive shell, or an interactive shell in which the interactive underscore comments option to the shopped built-in is enabled, see the shopped built-in, a word beginning with # causes that word and all remaining characters on that line to be ignored. An interactive shell without the interactive underscore comments option enabled does not allow comments. The interactive underscore comments option is on by default in interactive shells. See interactive shells for a description of what makes a shell interactive. 3.2 Shell commands. A simple shell command such as echo A space B space C consists of the command itself followed by arguments separated by spaces. More complex shell commands are composed of simple commands arranged together in a variety of ways. In a pipeline in which the output of one command becomes the input of a second, in a loop or conditional construct, or in some other grouping. 3.2.1 Reserved words. Reserved words are words that have special meaning to the shell. They are used to begin and end the shell's compound commands. The following words are recognized as reserved when unquoted and the first word of a command. See below for exceptions. If, then, elif, else, phi, time, for, in, until, while, do, done, case, esac, co-proc, select, function, open curly brace, close curly brace, double square brace, close double square brace, and exclamation mark. In is recognized as a reserved word if it is the third word of a case or select command. In and do are recognized as reserved words if they are the third word in a for command. 3.2.2 Simple commands. A simple command is the kind of command encountered most often. It's just a sequence of words separated by blanks, terminated by one of the shell's control operators. The first word generally specifies a command to be executed, with the rest of the words being that command's arguments. The return status of a simple command is its exit status as provided by the Posix 1003.1 waitPid function, or 128 plus n if the command was terminated by signal n. 3.2.3 Pipelines. A pipeline is a sequence of one or more commands separated by one of the control operators, pipe or pipe ampersand. The format for a pipeline is optionally time, optionally -p, optionally exclamation mark, command 1, optionally pipe or pipe ampersand, command 2, and then you can repeat that. The output of each command in the pipeline is connected via a pipe to the input of the next command. That is, each command reads the previous command's output. This connection is performed before any redirection specified by command 1. If pipe ampersand is used, command 1's standard error, in addition to its standard output, is connected to command 2's standard input through the pipe. It is shorthand for 2 greater than ampersand 1 pipe. This implicit redirection of the standard error to the standard output is performed after any redirections specified by command 1. The reserved word time causes timing statistics to be printed for the pipeline once it finishes. The statistics currently consist of elapsed wall clock time and user and system time consumed by the command's execution. The -p option changes the output format to that specified by Posix. When the shell is in Posix mode, it does not recognize time as a reserved word if the next token begins with a dash. The time format variable may be set to a format string that specifies how the timing information should be displayed. See bash variables for a description of the available formats. The use of time as a reserved word permits the timing of shell built-ins, shell functions, and pipelines. An external time command cannot time these easily. When the shell is in Posix mode, time may be followed by a new line. In this case, the shell displays the total user and system time consumed by the shell and its children. The time format variable may be used to specify the format of the time information. If the pipeline is not executed asynchronously, the shell waits for all commands in the pipeline to complete. Each command in a multi-command pipeline, where pipes are created, is executed in its own subshell, which is a separate process. If the last pipe option is enabled using the shopped built-in, the last element of a pipeline may be run by the shell process when the job control is not active. The exit status of a pipeline is the exit status of the last command in the pipeline, unless the pipe fail option is enabled. If the pipe fail is enabled, the pipeline's return status is the value of the last rightmost command to exit with a non-zero status, or 0 if all commands exit successfully. If the reserved word exclamation mark precedes the pipeline, the exit status is the logical negation of the exit status as described above. The shell waits for all commands in the pipeline to terminate before returning a value. 3.2.4 Lists of commands. A list is a sequence of one or more pipelines separated by one of the operators semicolon, ampersand, double ampersand, or double pipe, and optionally terminated by one of ampersand, semicolon, or a new line. Of these list operators, double ampersand and double pipe have equal precedence, followed by semicolon and ampersand, which have equal precedence. A sequence of one or more new lines may appear in a list to delimit commands, equivalent to a semicolon. If a command is terminated by the control operator ampersand, the shell executes the command asynchronously in a subshell. This is known as executing the command in the background, and these are referred to as asynchronous commands. The shell does not wait for the command to finish, and the return status is 0, true. When job control is not active, the standard input for asynchronous commands, in the absence of any explicit redirections, is redirected from dev null. Commands separated by a semicolon are executed sequentially. The shell waits for each command to terminate in turn. The return status is the exit status of the last command executed. And or lists are sequences of one or more pipelines separated by the control operators double ampersand and double pipe, respectively. And or lists are executed with left associativity. An AND list has the form command 1 double ampersand command 2. Command 2 is executed if and only if command 1 returns an exit status of 0, success. An OR list has the form command 1 double pipe command 2. Command 2 is executed if and only if command 1 returns a non-zero exit status. The return status of and or lists is the exit status of the last command executed in the list. 3.2.5 Compound commands. Compound commands are the shell programming language constructs. Each construct begins with a reserved word or control operator and is terminated by a corresponding reserved word or operator. Any redirections associated with a compound command apply to all commands within that compound command, unless explicitly overridden. In most cases, a list of commands in a compound command's description may be separated from the rest of the command by one or more new lines, and may be followed by a new line in place of a semicolon. Bash provides looping constructs, conditional commands, and mechanisms to group commands and execute them as a unit. 3.2.5.1 Looping constructs. Bash supports the following looping constructs. Note that wherever a semicolon appears in the description of a command's syntax, it may be replaced with one or more new lines. Until. The syntax of the until command is until test commands do consequent commands done. Execute consequent commands as long as test commands has an exit status which is not 0. The return status is the exit status of the last command executed in consequent commands, or 0 if none was executed. While. The syntax of the while command is while test commands, semicolon, do consequent commands, semicolon, done. Execute consequent commands as long as test commands has an exit status of 0. The return status is the exit status of the last command executed in consequent commands, or 0 if none was executed. 4. Syntax of the for command is for optionally in optionally words repeated, semicolon, do commands, semicolon, done. Expand words and execute commands once for each member in the resultant list with name bound to the current member. If in words is not present, the for command executes the commands once for each positional parameter that is set, as if in double quotes $@ symbol had been specified. The return status is the exit status of the last command that executes. If there are no items in the expansion of words, no commands are executed, and the return status is 0. An alternative form of the for command is also supported. For double parentheses, expression 1, semicolon, expression 2, semicolon, expression 3, semicolon, do commands, semicolon, done. First, the arithmetic expression 1 is evaluated according to the rules described below. The arithmetic expression 2 is then evaluated repeatedly until it evaluates to 0. Each time expression 2 evaluates to a non-zero value, commands are executed and the arithmetic expression 3 is evaluated. If any expression is omitted, it behaves as if it evaluates to 1. The return value is the exit status of the last command in commands that is executed, or false if any of the expressions is invalid. The break and continue built-ins may be used to control loop execution. 3.2.5.2 Conditional constructs. If. The syntax of the if command is if test commands, semicolon, then consequent commands, optionally elif more test commands, semicolon, then more consequence, optionally else alternate consequence, and finally phi. The test commands list is executed, and if its return status is 0, the consequent commands list is executed. If test commands returns a non-zero status, each elif list is executed in turn, and if its exit status is 0, the corresponding more consequence is executed and the command completes. If else alternate consequence is present, and the final command in the final if or elif clause has a non-zero exit status, then alternate consequence is executed. The return status is the exit status of the last command executed, or 0 if no condition tested true. Case. The syntax of the case command is case word in, optionally, optional parenthesis, pattern, optional pipe, second pattern, repeated, close parenthesis, command list, double semicolon, optionally repeated, followed by ESAC. Case will selectively execute the command list corresponding to the first pattern that matches word. The match is performed according to the rules described below in pattern matching. If the no case match shell option is enabled, the match is performed without regard to the case of alphabetic characters. The pipe is used to separate multiple patterns, and the closing parenthesis operator terminates a pattern list. A list of patterns and an associated command list is known as a clause. Each clause must be terminated with double semicolon, semicolon ampersand, or double semicolon ampersand. The word undergoes tilde expansion, parameter expansion, command substitution, arithmetic expansion, and quote removal before matching is attempted. Each pattern undergoes tilde expansion, parameter expansion, command substitution, arithmetic expansion, process substitution, and quote removal. There may be an arbitrary number of case clauses, each terminated by double semicolon, semicolon ampersand, or double semicolon ampersand. The first pattern that matches determines the command list that is executed. It's a common idiom to use star as the final pattern to define the default case, since that pattern will always match. Here is an example using case in a script that could be used to determine one interesting feature of an animal. echo -n, double quotes, enter the name of an animal, colon, space, double quote. Read animal, echo -n, double quote. The $animal has space, double quote. Case $animal in horse, pipe, dog, pipe, cat, close parenthesis, echo -n, double quote, 4, double quote, double semicolon. New line, man or kangaroo, close parenthesis, echo -n, double quote, 2, double quote, double semicolon. New line, star, close parenthesis, echo -n, double quote, an unknown number of, double quote, double semicolon. New line, Isak, echo, space legs. If the double semicolon operator is used, no subsequent matches are attempted after the first pattern match. Using semicolon ampersand in place of double semicolon causes execution to continue with the command list associated with the next clause, if any. Using double semicolon ampersand in place of double semicolon causes the shell to test the patterns in the next clause, if any, and execute any associated command list on a successful match, continuing the case statement execution as if the pattern list had not matched. The return status is 0 if no pattern is matched. Otherwise, the return status is the exit status of the command list executed. Select. The select construct allows the easy generation of menus. It has almost the same syntax as the for command. Select name, optionally in words, repeated, semicolon, do commands, semicolon, done. The list of words following in is expanded, generating a list of items, and the set of expanded words is printed on the standard error output stream, each preceded by a number. If the in words is omitted, the positional parameters are printed as if in double quotes $@ symbol had been specified. Select then displays the PS3 prompt and reads a line from the standard input. If the line consists of a number corresponding to one of the displayed words, then the value of name is set to that word. If the line is empty, the words and prompt are displayed again. If EOF is read, the select command completes and returns 1. Any other value read causes name to be set to null. The line read is saved in the variable reply. The commands are executed after each selection until a break command is executed, at which point the select command completes. Here is an example that allows the user to pick a file name from the current directory and displays the name and index of the file selected. Select fname in star, semicolon. New line, do. New line, echo you picked $fname, / open paren, $reply, / close paren. New line, break semicolon. New line, done. Double parentheses. Double parentheses expression. The arithmetic expression is evaluated according to the rules described below. The expression undergoes the same expansions as if it were within double quotes, but double quote characters in expression are not treated specially, are removed. If the value of the expression is non-zero, the return status is 0, otherwise the return status is 1. Double square brackets. Return a status of 0 or 1 depending on the evaluation of the conditional expression. Expressions are composed of the primaries described below in bash conditional expressions. The words between the double square bracket do not undergo word splitting and file name expansion. The shell performs tilde expansion, parameter and variable expansion, arithmetic expansion, command substitution, process substitution, and quote removal on those words. The expansions that would occur if the words were enclosed in double quotes. Conditional operators such as -f must be unquoted to be recognized as primaries. When used with double square brackets, the less than and greater than operators sort lexicographically using the current locale. When the double equal and not equal operators are used, the string to the right of the operator is considered a pattern and matched according to the rules described below in pattern matching, as if the ext glob shell option were enabled. The equals operator is identical to the double equals. If the no case match shell option, see the description of shopped in the shopped built-in, is enabled, the match is performed without regard to the case of alphabetic characters. The return value is 0 if the string matches equals or does not match equals the pattern and 1 otherwise. If you quote any part of the pattern using any of the shell's quoting mechanisms, the quoted portion is matched literally. This means every character in the quoted portion matches itself instead of having any special pattern matching meaning. An additional binary operator, equals tilde, is available with the same precedence as double equals and exclamation mark equals. When you use equals tilde, the string to the right of the operator is considered a Posix extended regular expression pattern and matched accordingly, using the Posix regcomp and regexec interfaces usually described in Regex. The return value is 0 and the string matches the pattern. The return value is 0 if the string matches the pattern and 1 if it does not. If the regular expression is syntactically incorrect, the conditional expression returns 2. If the no case match shell option is enabled, the match is performed without regard to the case of alphabetic characters. You can quote any part of the pattern to force the quoted portion to be matched literally instead of as a regular expression. If the pattern is stored in a shell variable, quoting the variable expansion forces the entire pattern to be matched literally. The pattern will match if it matches any part of the string. If you want to force the pattern to match the entire string, anchor the pattern using the caret and $ regular expression operators. For example, the following will match a line stored in the shell variable line if there is a sequence of characters anywhere in the value consisting of any number, including 0, of characters in the space character class, immediately followed by 0 or 1 instances of A, then a B. Double square brackets, $line equals tilde, double square brackets, colon, space, colon, close double square brackets, star, open parenthesis, A, close parenthesis, question mark, B, space, close double square bracket. That means values for line like AAB, space AAAAAAB, XABY, and space AB will all match, as will a line containing a B anywhere in its value. If you want to match a character that's special to the regular expression grammar, caret, $, pipe, open square bracket, close square bracket, open parenthesis, close parenthesis, backslash, period, star, plus question mark, it has to be quoted to remove its special meaning. This means that in the pattern xxx.txt, the dot matches any character in the string, its usual regular expression meaning, but in the pattern double quotes xxx.txt, it can only match a literal dot. Likewise, if you want to include a character in your pattern that has a special meaning to the regular expression grammar, you must make sure it's not quoted. If you want to anchor a pattern at the beginning or end of the string, for instance, you cannot quote the caret or $ characters using any form of shell quoting. If you want to match initial string at the start of a line, the following will work. Double square brackets, $line equals tilde, caret, double quotes, initial string, close square brackets. But this will not. Open square bracket, $line equals tilde, double quote, caret initial string, double quote, close square bracket. Because in the second example, the caret is quoted and doesn't have its usual special meaning. It is sometimes difficult to specify a regular expression properly without using quotes, or to keep track of the quoting used by regular expressions while paying attention to shell quoting and the shell's quote removal. Storing the regular expression in a shell variable is often a useful way to avoid problems with quoting characters that are special to the shell. For example, the following is equivalent to the pattern used above. Pattern equals single quote, double square bracket, colon, space, colon, close double square bracket, star, open paren, A, close paren, question mark, B, single quote, new line, double square bracket, $line equals tilde, $pattern, close double square bracket. Shell programmers should take special care with backslashes, since backslashes are used by both the shell and regular expressions to remove the special meaning from the following character. This means that after the shell's word expansion is complete, any backslashes remaining in parts of the pattern that were originally not quoted can remove the special meaning of pattern characters. If any part of the pattern is quoted, the shell does its best to ensure that the regular expression treats those remaining backslashes as literal, if they appeared in a quoted portion. The following two sets of commands are not equivalent. Pattern equals single quote backslash period single quote. Open square bracket, open double square bracket, dot equals tilde, $pattern, close double square bracket. Open double square bracket, dot equals tilde, backslash dot, close double square bracket. Versus open square bracket, dot equals tilde, double quote, $pattern, double quote, close double square bracket, and open double square bracket, dot equals tilde, single quote, backslash dot, single quote, close double square bracket. The first two matches will succeed, but the second two will not, because in the second two, the backslash will be part of the pattern to be matched. In the first two examples, the pattern passed to the regular expression parser is backslash dot. The backslash removes the special meaning from dot, so the literal dot matches. In the second two examples, the pattern passed to the regular expression parser has the backslashes quoted, which will not match the string since it does not contain a backslash. If the string in the first examples were anything other than dot, say A, for example, the pattern would not match because the quoted dot in the pattern loses its special meaning of matching any single character. Bracket expressions and regular expressions can be sources of errors as well, since characters that are normally special in regular expressions lose their special meanings between brackets. However, you can use bracket expressions to match special characters without quoting them, so they are sometimes useful for this purpose. Though it might seem like a strange way to write it, the following pattern will match a dot in the string. Double square bracket, dot equals tilde, single square bracket, dot, close single square bracket, close double square bracket. The shell performs any word expansions before passing the pattern to the regular expression functions, so you can assume that the shell's quoting takes precedence. As noted above, the regular expression parser will interpret any unquoted backslashes remaining in the pattern after shell expansion according to its own rules. The intention is to avoid making shell programmers quote things twice as much as possible, so shell quoting should be sufficient to quote special pattern characters where that's necessary. The array variable bash_rematch records which parts of the string match the pattern. The element of bash_rematch with index 0 contains the portion of the string matching the entire regular expression. Substrings matched by parenthesized sub-expressions within the regular expression are saved in the remaining bash rematch indices. The element of bash rematch with index n is the portion of the string matching the nth parenthesized sub-expression. Bash sets bash rematch in the global scope. Declaring it as a local variable will lead to unexpected results. Expressions may be combined using the following operators, listed in decreasing order of precedence. Parentheses expression returns the value of the expression. This may be used to override the normal precedence of operators. Exclamation mark expression. True if expression is false. Expression 1 double ampersand expression 2. True if both expression 1 and expression 2 are true. Expression 1 double pipe expression 2. True if either expression 1 or expression 2 is true. The double ampersand and double pipe operators do not evaluate expression 2 if the value of expression 1 is sufficient to determine the return value of the entire conditional expression. 3.2.5.3 Grouping Commands. Bash provides two ways to group a list of commands to be executed as a unit. When commands are grouped, redirections may be applied to the entire command list. For example, the output of all commands in the list may be redirected to a single stream. Parentheses. Placing a list of commands between parentheses forces the shell to create a subshell, and each of the commands in list is executed in that subshell environment. Since the list is executed in a subshell, variable assignments do not remain in effect after the subshell completes. Curly braces list semicolon close curly braces. Placing a list of commands between curly braces causes the list to be executed in the current shell context. No subshell is created. The semicolon or new line following list is required. In addition to the creation of a subshell, there's a subtle difference between these two constructs due to historical reasons. The braces are reserved words, so they must be separated from the list by blanks or other shell metacharacters. The parentheses are operators and are recognized as separate tokens by the shell, even if they are not separated from the list by whitespace. The exit status of both of these constructs is the exit status of the list. 3.2.6 Co-processes. A co-process is a shell command preceded by the co-proc reserved word. A co-process is executed asynchronously in a subshell, as if the command had been terminated with the ampersand control character, with a two-way pipe established between the executing shell and the co-process. The syntax for a co-process is co-proc, name, command, optionally redirections. This creates a co-process named name. Command may be either a simple command or a compound command. Name is a shell variable name. If name is not supplied, the default name is co-proc. The recommended form to use for a co-process is co-proc name, open curly brace, command semicolon, close curly brace. This form is recommended because simple commands result in the co-process always being named co-proc, and it is simpler to use and more complete than the other compound commands. There are other forms of co-processes: co-proc name compound command, co-proc compound command, and co-proc simple command. If command is a compound command, name is optional. The word following co-proc determines whether that word is interpreted as a variable name. It is interpreted as name if it is not a reserved word that introduces a compound command. If command is a simple command, name is not allowed. This is to avoid confusion between name and the first word of the simple command. When the coprocess is executed, the shell creates an array variable named name in the context of the executing shell. The standard output of command is connected via a pipe to a file descriptor in the executing shell, and that file descriptor is assigned to name0. The standard input of command is connected via a pipe to a file descriptor in the executing shell, and that file descriptor is assigned to name1. This pipe is established before any redirection specified by the command. The file descriptors can be utilized as arguments to shell commands and redirections using standard word expansions. Other than those created to execute command and process substitutions, the file descriptors are not available in subshells. The process ID of the shell spawned to execute the coprocess is available as the value of the variable name_pid. The wait built-in command may be used to wait for the coprocess to terminate. Since the coprocess is created as an asynchronous command, the Co-proc command always returns success. The return status of a coprocess is the exit status of command. 3.2.7 GNU Parallel. There are ways to run commands in parallel that are not built into Bash. GNU Parallel is a tool to do just that. GNU Parallel, as its name suggests, can be used to build and run commands in parallel. You may run the same command with different arguments, whether they are file names, usernames, host names, or lines read from files. GNU Parallel provides shorthand references to many of the most common operations. Input lines, various portions of the input line, different ways to specify input source, and so on. Parallel can replace xargs or feed commands from its input sources to several different instances of Bash. For a complete description, refer to the GNU Parallel documentation, which is available at gnu.org. 3.3 Shell functions. Shell functions are a way to group commands for later execution using a single name for the group. They are executed just like a regular command. When the name of a shell function is used as a single command name, the list of commands associated with that function name is executed. Shell functions are executed in the current shell context. No new process is created to interpret them. Functions are declared using this syntax: fname, parentheses, compound command, optionally redirections, or function fname, optionally parentheses, compound command, optionally redirections. This defines a shell function named fname. The reserved word function is optional. If the function reserved word is supplied, the parentheses are optional. The body of the function is the compound command. That command is usually a list enclosed between curly braces, but may be any compound command listed above. If the function reserved word is used, but the parentheses are not supplied, the braces are recommended. Compound command is executed whenever fname is specified as the name of a simple command. When the shell is in Posix mode, fname must be a valid shell name and may not be the same as the one of the special built-ins. In default mode, a function name can be any unquoted shell word that does not contain $. Any redirections associated with the shell function are performed when the function is executed. A function definition may be deleted using the -f option to the unset built-in. The exit status of a function definition is 0 unless a syntax error occurs or a read-only function with the same name already exists. When executed, The exit status of a function is the exit status of the last command executed in the body. Note that for historical reasons, in the most common usage, the curly braces that surround the body of the function must be separated from the body by blanks or new lines. This is because the braces are reserved words and are only recognized as such when they are separated from the command list by whitespace or another shell meta character. Also, when using the braces, the list must be terminated by a semicolon, an ampersand, or a new line. When a function is executed, the arguments to the function become positional parameters during its execution. The special parameter # that expands to the number of positional parameters is updated to reflect the change. Special parameter 0 is unchanged. The first element of the funcName variable is set to the name of the function while the function is executing. All other aspects of the shell execution environment are identical between a function and its caller with these exceptions. The debug and return traps are not inherited unless the function has been given the trace attribute using the declare built-in or the -o functrace option has been enabled with the set built-in, in which case all functions inherit the debug and return traps. And the error trap is not inherited unless the -o error trace shell option has been enabled. See Born shell built-ins for the description of the trap built-in. The funcNest variable, if set to a numeric value greater than 0, defines a maximum function nesting level. Function invocations that exceed the limit cause the entire command to abort. If the built-in command is executed in a function, the function completes and execution resumes with the next command after the function call. Any command associated with the return trap is executed before execution resumes. When a function completes, the values of the positional parameters and the special parameter # are restored to the values they had prior to the function's execution. If a numeric argument is given to return, that is the function's return status. Otherwise, the function's return status is the exit status of the last command executed before the return. Variables local to the function may be declared with the local built-in. Ordinarily, variables and their values are shared between a function and its caller. These variables are visible only to the function and the command it invokes. This is particularly important when a shell function calls other functions. In the following description, the current scope is a currently executing function. Previous scopes consist of the function's caller and so on, back to the global scope, where the shell is not executing any shell function. Consequently, a local variable at the current local scope is a variable declared using the local or declare built-ins in the function that is currently executing. Local variables shadow variables with the same name declared at previous scopes. For instance, a local variable declared in a function hides a global variable of the same name. References and assignments refer to the local variable, leaving the global variable unmodified. When the function returns, the global variable is once again visible. The shell uses dynamic scoping to control a variable's visibility within functions. With dynamic scoping, visible variables and their values are a result of the sequence of function calls that caused execution to reach the current function. The value of a variable that a function sees depends on its value within its caller, if any, whether that caller is the global scope or another shell function. This is also the value that a local variable declaration shadows, and the value that is restored when the function returns. For example, if a variable var is declared as local in function func1, and func1 calls another function, func2, references to var made within func2 will resolve to the local variable var from func1, shadowing any global variable named var. The following script demonstrates this behavior. When executed, the script displays in func 2 var equals func1 local. The script is func1 open parentheses close parentheses new line open curly brace new line local var equals single quotes func1 local new line func2 new line close curly brace. Then we have func2 open parentheses close parentheses new line open curly brace new line echo double quotes in func2 comma var equals $var new line close curly brace var equals global and then invoke func1. The unset built-in also acts using the same dynamic scope. If a variable is local to the current scope, unset will unset it. Otherwise, the unset will refer to the variable found in any calling scope as described above. If a variable at the current local scope is unset, it will remain so, appearing as unset until it is reset in that scope or until the function returns. Once the function returns, any instance of the variable at a previous scope will become visible. If the unset acts on a variable at a previous scope, any instance of a variable with that name that had been shadowed will become visible. See below how local var underscore unset shell option changes this behavior. Function names and definitions may be listed with the -f option to the declare typeset built-in command. The -F option to declare or typeset will list the function names only, and optionally the source file and line number if the ext debug shell option is enabled. Functions may be exported so that child shell processes, those created when executing a separate shell invocation, automatically have them defined with the -f option to the export built in. Functions may be recursive. The funcNest variable may be used to limit the depth of the function call stack and restrict the number of function invocations. By default, no limit is placed on the number of recursive calls. 3.4 Shell Parameters. A parameter is an entity that stores values. It can be a name, a number, or one of the special characters listed below. A variable is a parameter denoted by a name. A variable has a value and 0 or more attributes. Attributes are assigned using the declare built-in command. A parameter is set if it has been assigned a value. The null string is a valid value. Once a variable is set, it may be unset only by using the unset built-in command. A variable may be assigned to by a statement of the form name equals and then optionally value. If value is not given, the value is assigned the null string. All values undergo tilde expansion, parameter and variable expansion, command substitution, arithmetic expansion, and quote removal. If the variable has its integer attribute set, then value is evaluated as an arithmetic expression even if the $sign double parentheses expansion is not used. Word splitting and filename expansion are not performed. Assignment statements may also appear as arguments to the alias, declare, typeset, export, read-only, and local built-in commands. When in Posix mode, these built-ins may appear in a command after one or more instances of the command built-in and retain these assignment statement properties. In the context where an assignment statement is assigning a value to a shell variable or array index, the += operator can be used to append to or add to the variable's previous value. This includes arguments to built-in commands such as declare that accept assignment statements. When += is applied to a variable for which the integer attribute has been set, value is evaluated as an arithmetic expression and added to the variable's current value, which is also evaluated. When plus equals is applied to an array variable using compound assignment, the variable's value is not unset, as it is when using equals, and new values are appended to the array beginning at 1 greater than the array's maximum index for indexed arrays, or added as additional key value pairs in an associative array. When applied to a string valued variable, value is expanded and appended to the variable's value. A variable can be assigned the nameref attribute using the -n option to the declare or local built-in commands to create a nameref, or a reference to another variable. This allows variables to be manipulated indirectly. Whenever the nameref variable is referenced, assigned to, unset, or has its attributes modified, other than using or changing the nameref attribute itself, the operation is actually performed on the variable specified by the nameref variable's value. A nameref is commonly used within shell functions to refer to a variable whose name is passed as an argument to the function. For instance, if a variable name is passed to the shell function as its first argument, running declare-n ref equals $1 inside the function creates a nameref variable, ref, whose value is the variable name passed as the first argument. References and assignments to ref and changes to its attributes are treated as references, assignments, and attribute modifications to the variable whose name was passed as $1. If the control variable in a for loop has the nameref attribute, the list of words can be a list of shell variables, and a name reference will be established for each word in the list, in turn, when the loop is executed. Array variables cannot be given the nameref attribute. However, nameref variables can reference array variables and subscripted array variables. Namerefs can be unset using the -n option to the unset built-in. Otherwise, if unset is executed with the name of a nameref variable as an argument, the variable referenced by the nameref variable will be unset. 3.4.1 Positional Parameters. A positional parameter is a parameter denoted by one or more digits, other than the single digit 0. Positional parameters are assigned from the shell's arguments when it is invoked, and may be reassigned using the set built-in command. Positional parameter n may be referenced as $ curly braces n, or as $n when n consists of a single digit. Positional parameters may not be assigned to with assignment statements. The set and shift built-ins are used to set and unset them. The positional parameters are temporarily replaced when a shell function is executed. When a positional parameter consisting of more than a single digit is expanded, it must be enclosed in braces. 3.4.2 Special Parameters. The shell treats several parameters specially. These parameters may only be referenced. Assignment to them is not allowed. $* expands to the positional parameter starting from 1. When the expansion is not within double quotes, each positional parameter expands to a separate word. In contexts where it is performed, those words are subject to further word splitting in Filename Expansion. When the expansion occurs within double quotes, it expands to a single word with the value of each parameter separated by the first character of the IFS special variable. That is, double quotes $* is equivalent to double quotes $1C, $2C, etc., where C is the first character of the value of the IFS variable. If IFS is unset, the parameters are separated by spaces. If IFS is null, the parameters are joined without intervening separators. $@ symbol expands to the positional parameter starting from 1. In contexts where word splitting is performed, this expands each positional parameter to a separate word. If not within double quotes, these words are subject to word splitting. In contexts where word splitting is not performed, this expands to a single word with each positional parameter separated by a space. When the expansion occurs within double quotes, the word splitting is performed. Each parameter expands to a separate word. That is, double quotes $@ is equivalent to double quotes $1 and double quotes $2, etc. If the double quoted expansion occurs within a word, the expansion of the first parameter is joined with the beginning part of the original word, and the expansion of the last parameter is joined with the last part of the original word. When there are no positional parameters, double quote $@ and $@ expand to nothing, i.e. they are removed. $&sign expands to the number of positional parameters in decimal. $$ expands to the exit status of the most recently executed foreground pipeline. $- expands to the current option flags as specified upon invocation by the set built-in command, or those set by the shell itself, such as the -I option. $$ expands to the process ID of the shell. In a subshell, it expands to the process ID of the invoking shell, not the subshell. $! expands to the process ID of the job most recently placed into the background, whether executed as an asynchronous command or using the BG built-in. $0 expands to the name of the shell or shell script. This is set at shell initialization. If bash is invoked with a file of commands, $0 is set to the name of that file. If bash is started with the -C option, then $0 is set to the first argument after the string to be executed, if one is present. Otherwise, it is set to the file name used to invoke bash, as given by argument 0. 3.5 Shell expansions. Expansion is performed on a command line after it has been split into tokens. There are 7 kinds of expansion performed: brace expansion, tilde expansion, parameter and variable expansion, command substitution, arithmetic expansion, word splitting, and file name expansion. The order of expansions is brace expansion, tilde expansion, parameter and variable expansion, arithmetic expansion, and command substitution, done in a left to right fashion, word splitting, and file name expansion. On systems that can support it, there is an additional expansion available, process substitution. This is performed at the same time as tilde, parameter, variable, and arithmetic expansion and command substitution. After these expansions are performed, quote characters present in the original word are removed unless they have been quoted themselves. Only brace expansion, word splitting, and file name expansion can increase the number of words of the expansion. Other expansions expand a single word to a single word. The only exception to this are the expansions of double quotes $@ and $*, and double quotes $, curly braces, name, single square brackets, @ and $, curly braces, name, square brackets, *. After all expansions, quote removal is performed. 3.5.1 Brace expansion. Brace expansion is a mechanism by which arbitrary strings may be generated. This mechanism is similar to file name expansion, but the file names generated need not exist. Patterns to be brace expanded take the form of an optional preamble, followed by either a series of comma-separated strings or a sequence expression between a pair of braces, followed by an optional postscript. The preamble is prefixed to each string contained within the braces, and the postscript is then appended to each resulting string, expanding left to right. Brace expansions may be nested. The results of each expanded string are not sorted. Left to right order is preserved. For example, echo A, curly brace, D, C, B, close curly brace, E would print out ADE space ACE space ABE. A sequence expression takes the form curly brace x.y, optionally ... increment. where x and y are either integers or letters, an optional increment is an integer. When integers are supplied, the expression expands to each number between x and y inclusive. Supplied integers may be prefixed with 0 to force each term to have the same width. When either x or y begins with a 0, the shell attempts to force all generated terms to contain the same number of digits, 0 padding where necessary. When letters are supplied, the expression expands to each character lexicographically between x and y inclusive using the default C locale. Note that both x and y must be one of the same type, integer or letter. When the increment is supplied, it is used as the difference between each term. The default increment is 1 or -1 as appropriate. Brace expansion is performed before any other expansions, and any characters special to other expansions are preserved in the result. It is strictly textual. Bash does not apply any syntactic interpretation to the context of the expansion or the text between the braces. A correctly formed brace expansion must contain unquoted opening and closing braces, and at least one unquoted comma or a valid sequence expression. Any incorrectly formed brace expansion is left unchanged. An open curly brace or comma may be quoted with a backslash to prevent its being considered part of a brace expansion. To avoid conflicts with parameter expansion, the string $ open curly brace is not considered eligible for brace expansion and inhibits brace expansion until the closing curly brace. This construct is typically used as shorthand when the common prefix of the strings to be generated is longer than in the above example. Make dir /user/local/source/bash/ open curly brace old comma new comma dist comma bugs close curly brace, or chown root /user/ open curly brace ucv/ open curly brace ex comma edit close curly brace comma lib / open curly brace ex $?* comma how _ex close curly brace close curly brace. 3.5.2 tilde expansion. If a word begins with an unquoted tilde character, all of the characters up to the first unquoted slash, or all characters if there's no unquoted slash, are considered a tilde prefix. If none of the characters in the tilde prefix are quoted, the characters in the tilde prefix following the tilde are treated as a possible login name. If this login name is the null string, the tilde is replaced with the value of the home shell variable. If home is unset, the home directory of the user executing the shell is substituted instead. Otherwise, the tilde prefix is replaced with the home directory associated with the specified login name. If the tilde prefix is tilde plus sign, the value of the shell variable pwd replaces the tilde prefix. If the tilde prefix is tilde hyphen, the value of the shell variable old pwd, if it is set, is substituted. If the characters following the tilde and the tilde prefix consist of a number n, optionally prefixed by a plus or a minus, the tilde prefix is replaced with the corresponding element from the directory stack, as it would be displayed by the dirs built-in, invoked with the characters following tilde in the tilde prefix as an argument. See the directory stack. If the tilde prefix sans the tilde consists of a number without a leading plus or minus, plus is assumed. If the login name is invalid or the tilde expansion fails, the word is left unchanged. Each variable assignment is checked for unquoted tilde prefixes immediately following a colon or the first equals. In these cases, tilde expansion is also performed. Consequently, one may use file names with tildes in assignments to path, mail path, and cd path, and the shell assigns the expanded value. The following table shows how bash treats unquoted tilde prefixes. tilde, the value of $home. Tilde/foo, $home/foo. Tilde Fred/foo, the subdirectory of foo of the home directory of the user Fred. Tilde plus/foo, $PWD/foo. Tilde minus/foo, $ open curly brace old PWD hyphen single quote tilde hyphen single quote close curly brace /foo. Tilde uppercase N, the string that would be displayed by ders plus N. Tilde plus N, the string that would be displayed by ders plus N. Tilde minus N, the string that would be displayed by ders-N. Bash also performs tilde expansion on words satisfying the conditions of variable assignments when they appear as arguments to simple commands. Bash does not do this except for the declaration commands listed above when in Posix mode. 3.5.3 Shell Parameter Expansion. The $sign character introduces parameter expansion, command substitution, or arithmetic expansion. The parameter name or symbol to be expanded may be enclosed in braces, which are optional, but serve to protect the variable to be expanded from characters immediately following it, which could be interpreted as part of the name. When braces are used, the matching ending brace is the first close curly brace, not escaped by a backslash, or within a quoted string, and not within an embedded arithmetic expansion, command substitution, or parameter expansion. The basic form of parameter expansion is $ open curly brace parameter close curly brace. The value of parameter is substituted. The parameter is a shell parameter as described above, or an array reference. The braces are required when parameter is a positional parameter with more than one digit, or when parameter is followed by a character that is not to be interpreted as part of its name. If the first character of parameter is an exclamation point, and parameter is not a name ref, it introduces a level of indirection. Bash uses the value formed by expanding the rest of the parameter as the new parameter. This is then expanded, and that value is used in the rest of the expansion, rather than in the expansion of the original parameter. This is known as indirect expansion. The value is subject to tilde expansion, parameter expansion, command substitution, and arithmetic expansion. If parameter is a name ref, this expands to the name of the variable referenced by parameter instead of performing the complete indirect expansion. The exceptions to this are the expansions of $ open curly exclamation point prefix star close curly and open curly exclamation point name open square bracket @ symbol close square bracket close curly described below. The exclamation point must immediately follow the left brace in order to introduce indirection. In each of the cases below, word is subject to tilde expansion, parameter expansion, command substitution, and arithmetic expansion. When not performing substring expansion, using the form described below, Bash tests for a parameter that is unset or null. Omitting the colon results in a test only for a parameter that is unset. Put another way, if the colon is included, the operator tests for both parameters' existence and that its value is not null. If the colon is omitted, the value tests only for existence. So a parameter expansion that says parameter :hyphen word means if the parameter is unset or null, the expansion of word is substituted. Otherwise, the value of parameter is substituted. For example, if v equals 1, 2, 3, and we echo a parameter expansion v hyphen unset, it will print 1, 2, 3. A parameter expansion of the form parameter :equals word means if parameter is unset or null, the expansion of word is assigned to parameter. The value of parameter is then substituted. Positional parameters and special parameters may not be assigned to in this way. For example, if var equals null string and we do the parameter expansion var colon equals default and then echo the value of var, we get default. A parameter expansion of the form parameter colon question mark word means if parameter is null or unset, the expansion of word or a message to that effect if word is not present is written to the standard error of the shell and the shell if it is not interactive exits. Otherwise, the value of parameter is substituted. So if var is null string and we do var colon question mark var is unset or null, we get a message to standard error that var is unset or null and the shell exits. A parameter expansion of the form parameter colon plus word means if parameter is null or unset, nothing is substituted. Otherwise, the expansion of word is substituted. An expansion of the form parameter colon offset or parameter colon offset colon length means a substring expansion. It expands to up to length characters of the value of parameter starting at the character specified by offset. If parameter is at or star, an indexed array subscripted by at or star, or an associative array name, the results differ as described below. If length is omitted, it expands to the substring of the value of parameter starting at the character specified by offset and extending to the end of the value. Length and offset are arithmetic expressions. If offset evaluates to a number less than 0, the value is used as an offset in characters from the end of the value of parameter. If length evaluates to a number less than 0, it is interpreted as an offset in characters from the end of the value of parameter rather than a number of characters, and the expansion is the characters between offset and that result. Note that a negative offset must be separated from the colon by at least one space to avoid being confused with the colon hyphen expansion. Here are some examples illustrating substring expansions on parameters and subscripted arrays. String equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A, B, C, D, E, F, G, H. If we echo dollar open curly string colon 7 close curly, we get 7, 8, 9, 0, A, B, C, D, E, F, G, H. If we echo dollar curly string colon 7 colon 0 close curly, we get nothing. If we echo dollar open curly string colon 7 colon 2 close curly, we get 7, 8. If we echo dollar curly string colon 7 colon -2 close curly, we get 7, 8, 9, 0, A, B, C, D, E, F. A, B, C, D, E, F. If we echo dollar open curly string colon space -7 close curly, we get B, C, D, E, F, G, H. If we echo dollar curly string colon space -7 colon 0 close curly, we get nothing. If we echo dollar curly string colon space -7 colon 2 close curly, we get BC. If we echo dollar curly string colon space -7 colon -2 close curly, we get BCDEF. If parameter is at or star, the result is length positional parameters beginning at offset. A negative offset is taken relative to one greater than the greatest positional parameter. So an offset of -1 evaluates to the last positional parameter. It is an expansion error if length evaluates to a number less than 0. The following examples illustrate substring expansion using positional parameters. Set --1 space 2 space 3 space 4 space 5 space 6 space 7 space 8 space 9 space 0 space A space B space C space D space E space F space G space H. with this example, we can echo $curly @7 close curly to get 7 space 8 space 9 space 0 space A space B space C space D space E space F space G space H as an example. If parameter is an indexed array named subscripted by @ or star, the result is the length members of the array beginning with $curly parameter square bracket offset close square bracket close curly. A negative offset is taken relative to 1 greater than the maximum index of the specified array. It is an expansion error if length evaluates to a number less than 0. More examples. Substring expansion applied to an associative array produces undefined results. Substring indexing is 0-based unless the positional parameters are used, in which case the indexing starts at 1 by default. If offset is 0 and the positional parameters are used, $0 is prefixed to the list. $curly prefix star close curly and $curly prefix @ close curly expands to the names of variables whose names begin with prefix separated by the first character of the IFS special variable. When @ is used and the expansion appears within double quotes, each variable name expands to a separate word. $curly name square bracket @ close square bracket close curly, as well as $open curly name open square bracket star close square bracket close curly, if name is an array variable, expands to the list of array indices or keys assigned in name. If name is not an array, expands to 0 if name is set and null otherwise. When @ is used and the expansion appears within double quotes, each key expands to a separate word. $curly parameter close curly. The lengthened characters of the expanded value of parameter is substituted. If parameter is star or @, the value substituted is the number of positional parameters. If parameter is an array name subscripted by star or @, the value substituted is the number of elements in the array. If parameter is an indexed array name subscripted by a negative number, that number is interpreted as relative to 1 greater than the maximum index of parameter, so negative indices count back from the end of the array, and an index of -1 references the last element. $curly parameter word close curly and open curly parameter word close curly. The word is expanded to produce a pattern and matched according to the rules described below. See pattern matching. If the pattern matches the beginning of the expanded value of parameter, then the rest of the expansion is the expanded value of parameter with the shortest matching pattern in the single # case, or the longest matching pattern in the double # case, and it is deleted. If parameter is @ or star, the pattern removal operation is applied to each positional parameter in turn, and the expansion is the resultant list. If parameter is an array variable subscripted with @ or star, the pattern removal operation is applied to each member of the array in turn, and the expansion is the resultant list. Parameter expansions of the form parameter %word or parameter $word mean the word is expanded to produce a pattern and matched according to the rules described below. See pattern matching. If the pattern matches a trailing portion of the expanded value parameter, then the result of the expansion is the value of parameter with the shortest matching pattern in the single % case, or the longest matching pattern in the double % case, deleted. If parameter is @ or star, the pattern removal operation is applied to each positional parameter in turn, and the expansion is the resultant list. If parameter is an array of variables subscripted with @ or star, the pattern removal operation is applied to each member of the array in turn, and the expansion is the resultant list. Parameter expansions of the form parameter/pattern/string, or parameter//pattern/string, or parameter/pound pattern/string, or parameter/%pattern/string mean the pattern is expanded to produce a pattern just as in Filename Expansion. Parameter is expanded and the longest match of pattern is against its value is replaced with string. String undergoes tilde expansion, parameter and variable expansion, arithmetic expansion, command and process substitution, and quote removal. The match is performed according to the rules described below. In the first form above, only the first match is replaced. If there are two slashes separating parameter and pattern, the second form above, all matches of pattern are replaced with string. If pattern is preceded with $, the third form above, it must match at the beginning of the expanded value of parameter. If pattern is preceded by $, the fourth form above, it must match at the end of the expanded value of parameter. If the expansion of string is null, matches of pattern are deleted. If string is null, matches of pattern are deleted and the slash following pattern may be omitted. If the pat_sub_replacement shell option is enabled using shopt, any unquoted instances of ampersand in this string are replaced with the matching portion of pattern. This is intended to duplicate a common sed idiom. Quoting any part of the string inhibits replacement in the expansion of the quoted portion, including replacement strings stored in shell variables. Backslash will escape ampersand in string. The backslash is removed in order to permit a literal ampersand in the replacement string. Users should take care if string is double quoted to avoid unwanted interactions between the backslash and double quoting, since backslash has special meaning within double quotes. Pattern substitution performs the checks for unquoted ampersand after expanding the string, so users should ensure to properly quote any occurrences of ampersand they want to be taken literally in the replacement, and ensure any instances of ampersand they want to be replaced are unquoted. For instance, var equals ABCDEF, rep equals single quote ampersand space single quote, echo $, curly brace var /abc /ampersand space close curly brace, new line echo double quotes, same thing, new line echo $, curly brace var /abc $rep close curly brace, new line echo double quotes, same thing. Will display 4 lines of ABCDEF, while var equals ABCDEF, rep equals single quote ampersand space single quote, echo $, curly brace var /abc / ampersand space close curly brace, and all of the following variations using backslash ampersand will display 4 lines of ampersand space DEF. Like the pattern removal operators, double quotes surrounding the replacement string quote the expanded characters, while double quotes enclosing the entire parameter substitution do not, since the expansion is performed in a context that doesn't take any enclosing double quotes into account. Since backslash can escape ampersand, it can also escape a backslash in the replacement string. This means that double backslash will insert a literal backslash into the replacement. So these two echo commands will both echo \abc xyz def. It should rarely be necessary to enclose only string in double quotes. If the no case match shell option is enabled, the match is performed without regard to the case of alphabetic characters. If parameter is @ or star, the substitution operation is applied to each positional parameter in turn, and the expansion is the resultant list. If parameter is an array variable subscripted with @ or star, then substitution operation is applied to each member of the array in turn, and the expansion is the resultant list. Parameter expansions of the form parameter caret pattern, or parameter double caret pattern, or parameter comma pattern, or parameter double comma pattern mean an expansion that modifies the case of alphabetic characters in parameter. The pattern is expanded to produce a pattern just as in Filename Expansion. Each character in the expanded value of parameter is tested against pattern, and if it matches the pattern, its case is converted. The pattern should not attempt to match more than one character. The caret operator converts lowercase letters matching pattern to uppercase. The comma operator converts matching uppercase letters to lowercase. The double caret and double comma expansions convert each match character in the expanded value. The caret and comma expansions match and convert only the first character in the expanded value. If the pattern is omitted, it is treated like a question mark, which matches every character. If parameter is @ or star, the case modification operation is applied to each positional parameter in turn, and the expansion is the resultant list. If parameter is an array variable subscripted with @ or star, the case modification operation is applied to each member of the array in turn, and the expansion is the resultant list. Parameter expansions of the form parameter @ operator mean the expansion is either a transformation of the value of parameter or information about parameter itself, depending on the value of operator. Each operator is a single letter. Uppercase U. The expansion is a string that is the value of parameter with lowercase alphabetic characters converted to uppercase. Lowercase u. The expansion is a string that is the value of parameter with the first character converted to uppercase if it is alphabetic. Uppercase L. The expansion is a string that is the value of parameter with uppercase alphabetic characters converted to lowercase. Uppercase Q. The expansion is a string that is a value of parameter quoted in a format that can be reused as input. Uppercase E. The expansion is a string that is the value of parameter with / escape sequences expanded as with the $single quote quoting mechanism. Uppercase P. The expansion is a string that is the result of expanding the value of parameter as if it were a prompt string. See controlling the prompt. Uppercase A. The expansion is a string in the form of an assignment statement or a declare command that, if evaluated, will recreate parameter with its attributes and value. Uppercase K produces a possibly quoted version of the value of parameter, except that it prints the values of indexed and associative arrays as a sequence of quoted key value pairs. Lowercase a. The expansion is a string consisting of flag values representing parameters' attributes. Lowercase k. Like the uppercase K transformation, but expands the keys and values of indexed and associative arrays to separate words after word splitting. If parameter is @ or star, the operation is applied to each positional parameter in turn, and the expansion is the resultant list. If parameter is an array variable subscripted with @ or star, the operation is applied to each member of the array in turn, and the expansion is the resultant list. The value of the expansion is subject to word splitting and filename expansion as described below. Chapter 3.5.4 Command Substitution. Command substitution allows the output of a command to replace the command itself. Command substitution occurs when a command is enclosed as follows: $ parentheses command or backtick command backtick. Bash performs the expansion by executing command in a subshell environment and replacing the command substitution with the standard output of the command, with any trailing new lines deleted. Embedded new lines are not deleted, but they may be removed during word splitting. The command substitution, $ cat file, can be replaced by the equivalent but faster $ less than file. When the old style backquote form of substitution is used, / retains its literal meaning except when followed by $backtick or \. The first backquote not preceded by a / terminates the command substitution. When using the $parentheses command form, all characters between the parentheses make up the command. None are treated specially. Command substitutions may be nested. To nest when using the backquoted form, escape the inner backquotes with \. If the substitution appears within double quotes, word splitting and file name expansions are not performed on the results. 3.5.5 Arithmetic Expansion. Arithmetic expansion allows the evaluation of an arithmetic expression and the substitution of the result. The format for arithmetic expansion is $double parentheses space expression space close double parentheses. The expression undergoes the same expansions as if it were within double quotes, but double quote characters in expression are not treated specially and are removed. All tokens in the expression undergo parameter and variable expansion, command substitution, and quote removal. The result is treated as the arithmetic expression to be evaluated. Arithmetic expansions may be nested. The evaluation is performed according to the rules listed below. See shell arithmetic. If the expression is invalid, bash prints a message indicating failure to the standard error and no substitution occurs. 3.5.6 Process Substitution. Process substitution allows a process's input or output to be referred to using a file name. It takes the form of (list) or (list). The process list is run asynchronously, and its input or output appears as a file name. This file name is passed as an argument to the current command as the result of the expansion. If the (list) form is used, writing to the file will provide input for the list. If the (list) form is used, the file passed as an argument should be read to obtain the output of list. Note that no space may appear between the <= and the left parenthesis. Otherwise, the construct would be interpreted as a redirection. Process substitution is supported on systems that support named pipes, FIFOs, or the /dev/fd method of naming open files. When available, process substitution is performed simultaneously with parameter and variable expansion, command substitution, and arithmetic expansion. 3.5.7 Word Splitting. This shell scans the results of parameter expansion, command substitution, and arithmetic expansion that did not occur within double quotes for word splitting. The shell treats each character of $ifs as a delimiter and splits the results of the other expansions into words using these characters as field terminators. If IFS is unset or its value is exactly space tab new line, the default, then sequences of space tab and new line at the beginning and end of the results of the previous expansions are ignored, and any sequence of IFS characters not at the beginning or end serves to delimit words. If IFS has a value other than the default, then sequences of whitespace characters, space, tab, and new line are ignored at the beginning and end of the word, as long as the whitespace character is in the value of IFS. Any character in IFS that is not IFS whitespace, along with any adjacent IFS whitespace characters, delimits a field. A sequence of IFS whitespace characters is also treated as a delimiter. If the value of IFS is null, no word splitting occurs. Explicit null arguments, double quotes or single quotes, are retained and passed to commands as empty strings. Unquoted implicit null arguments resulting from the expansion of parameters that have no values are removed. If a parameter with no value is expanded within double quotes, a null argument results and is retained and passed to a command as an empty string. When a quoted null argument appears as part of a word whose expansion is non-null, the null argument is removed. That is, the word -d single quote becomes -d after word splitting and null argument removal. Note that if no expansion occurs, no splitting is performed. 3.5.8 Filename Expansion. After word splitting, unless the -f option has been set, Bash scans each word for the character star, question mark, and open square bracket. If one of these characters appears and is not quoted, then the word is regarded as a pattern and replaced with an alphabetically sorted list of file names matching the pattern. If no matching file names are found and the shell option null glob is disabled, the word is left unchanged. If the null glob option is set and no matches are found, the word is removed. If the fail glob shell option is set and no matches are found, an error message is printed and the command is not executed. If the shell option no case glob is enabled, the match is performed without regard to the case of alphabetic characters. When a pattern is used for filename expansion, the character dot at the start of a filename or immediately following a slash must be matched explicitly, unless the shell option dot glob is set. In order to match the file names dot and dot dot, the pattern must begin with dot. For example, dot question mark, even if dot glob is set. If the glob skip dots shell option is enabled, the file names dot and dot dot are never matched, even if the pattern begins with a dot. When not matching file names, the dot character is not treated specially. When matching a file name, the slash character must always be matched explicitly by a slash in the pattern, but in other matching contexts, it can be matched by a special pattern character as described below. See the description of shopped in the shopped built-in for a description of the no case glob, null glob, glob skip dots, fail glob, and dot glob options. The glob ignore shell variable may be used to restrict the set of file names matching a pattern. If glob ignore is set, each matching file name that also matches one of the patterns in glob ignore is removed from the list of matches. If the no case glob option is set, the matching against the patterns in glob ignore is performed without regard to case. The file names dot and dot dot are always ignored when glob ignore is set and not null. However, setting glob ignore to a non-null value has the effect of enabling the dot glob shell option, so all other file names beginning with a dot will match. To get the old behavior of ignoring file names beginning with a dot, make dot star one of the patterns in glob ignore. The dot glob option is disabled when glob ignore is unset. 3.5.8.1 Pattern Matching. Any character that appears in a pattern other than the special pattern characters described below matches itself. The null character may not occur in a pattern. A backslash escapes the following character. The escaping backslash is discarded when matching. The special pattern characters must be quoted if they are to be matched literally. The special pattern characters have the following meanings. Star matches any string including the null string. When the glob star shell option is enabled and star is used in a filename expansion context, Two adjacent stars used as a single pattern will match all files and 0 or more directories and subdirectories. If followed by a slash, two adjacent stars will match only directories and subdirectories. Question mark matches any single character. Square brackets, something. Matches any one of the enclosed characters. A pair of characters separated by a hyphen denotes a range expression. Any character that falls between those two characters, inclusive, using the current locale's collating sequence and character set is matched. If the first character matched following the open square bracket is an exclamation mark or a caret, then any character not enclosed is matched. A hyphen may be matched by including it as the first or last character in the set. A closed square bracket may be matched by including it as the first character in the set. The sorting order of characters in range expressions and the characters included in the range are determined by the current locale and the values of the LC collate and LC all shell variables if set. For example, in the default C locale, square bracket a hyphen dx hyphen z is equivalent to square bracket abc dxyz, close square bracket. Many locales sort characters in dictionary order, and in these locales, open square bracket a dash d x dash z, close square bracket, is typically not equivalent to open square bracket abcd xyz, close square bracket. It might be equivalent to open square bracket a uppercase b, lowercase b, uppercase c, lowercase c, uppercase d, x, uppercase y, lowercase y, uppercase z, lowercase z, close square bracket. For example, to obtain the traditional interpretation of ranges in bracket expressions, you can force the use of C locale by setting the LC collate or LC all environment variable to the value C, or enable glob ASCII ranges shell option. Within square brackets, character classes can be specified using the syntax :class:, where class is one of the following classes defined in the POSIX standard: alnum, alpha, ASCII, blank, control, digit, graph, lower, print, punct, space, upper, word, xdigit. A character class matches any character belonging to that class. The word character class matches letters, digits, and the character underscore. Within square brackets, an equivalence class can be specified using the syntax =C equals, which matches all characters with the same collation weight as defined by the current locale as the character C. Within square brackets, the syntax dot matches the collating symbol. If the ext glob shell option is enabled using the shopt built-in, the shell recognizes several extended pattern matching operators. In the following description, a pattern list is a list of one or more patterns separated by a pipe. When matching file names, the .glob shell option determines the set of file names that are tested, as described above. Composite patterns may be formed using one or more of the following subpatterns: question mark parentheses pattern list matches 0 or 1 occurrences of the given patterns. Star parentheses pattern list matches 0 or more occurrences of the given patterns. Plus parentheses pattern list matches 1 or more occurrences of the given patterns. At parentheses pattern list matches 1 of the given patterns. Exclamation mark parentheses pattern list matches anything except one of the given patterns. The ext glob option changes the behavior of the parser, since the parentheses are normally treated as operators with syntactic meaning. To ensure that extended matching patterns are parsed correctly, make sure that extglob is enabled before parsing constructs containing the patterns, including shell functions and command substitutions. When matching file names, the .glob shell option determines the set of file names that are tested. When .glob is enabled, the set of file names includes all files that begin with dot, but the file names dot and dot dot must be matched by a pattern or subpattern that begins with a dot. When it is disabled, the set does not include any file names beginning with dot unless the pattern or subpattern begins with a dot. As above, dot only has special meaning when matching file names. Complicated extended pattern matching against long strings is slow, especially when the patterns contain alternations and strings contain multiple matches. Using separate matches against shorter strings, or using arrays of strings instead of a single long string may be faster. 3.5.9 Quote removal. After the preceding expansions, all unquoted occurrences of the character \, single quote, and double quote that did not result from one of the above expansions are removed. 3.6 Redirections. Before a command is executed, its input and output may be directed using a special notation interpreted by the shell. Redirection allows commands file handles to be duplicated, opened, closed, made to refer to different files, and can change the files the command reads from and writes to. Redirection may also be used to modify file handles in the current shell execution environment. The following redirection operators may precede or appear anywhere within a simple command or may follow a command. Redirections are processed in the order they appear from left to right. Each redirection that may be preceded by a file descriptor number may instead be preceded by a number. Each redirection that may be preceded by a file descriptor number may instead be preceded by a word of the form varname. In this case, for each redirection operator except greater than ampersand dash and less than ampersand dash, the shell will allocate a file descriptor greater than 10 and assign it to varname. If greater than ampersand dash or less than ampersand dash is preceded by varname, the value of varname defines the file descriptor to close. If varname is supplied, the redirection persists beyond the scope of the command, allowing the shell programmer to manage the file descriptor's lifetime manually. The var reader _ close shell option manages this behavior. In the following descriptions, if the file descriptor number is omitted and the first character of the redirection operator is less than, the redirection refers to the standard input file descriptor 0. If the first character of the redirection operator is greater than, the redirection refers to the standard output file descriptor 1. The word following the redirection operator in the following descriptions, unless otherwise noted, is subjected to brace expansion, tilde expansion, parameter expansion, command substitution, arithmetic expansion, quote removal, file name expansion, and word splitting. If it expands to more than one word, bash reports an error. Note that the order of redirections is significant. For example, the command ls greater than dirlist 2 greater than ampersand 1 directs both standard output file descriptor 1 and standard error file descriptor 2 to the file dirlist, while the command ls 2 greater than ampersand 1 greater than dirlist directs only the standard output to the file dirlist. Because the standard error was made a copy of the standard output before the standard output was redirected to dirlist. Bash handles several file names specifically when they are used in redirections, as described in the following table. If the operating system on which Bash is running provides these special files, Bash will use them. Otherwise, it will emulate them internally with the behavior described below. Dev fd fd. If fd is a valid integer, file descriptor fd is duplicated. Dev standard in, file descriptor 0 is duplicated. Dev standard out, file descriptor 1 is duplicated. Dev standard error, file descriptor 2 is duplicated. Dev TCP host port. If host is a valid host name or internet address, and port is an integer port number or service name, bash attempts to open the corresponding TCP socket. Dev UDP host port. If host is a valid host name or internet address, and port is an integer port number or service name, bash attempts to open the corresponding UDP socket. A failure to open or create a file causes the redirection to fail. Redirections using file descriptors greater than 9 should be used with care, as they may conflict with file descriptors the shell uses internally. 3.6.1 Redirecting input. Redirection of input causes the file whose name results from the expansion of Word to be opened for reading on file descriptor n, or the standard input file descriptor 0 if n is not specified. The general format for redirecting input is optionally n less than Word. 3.6.2 Redirecting output. Redirection of output causes the file whose name results from the expansion of Word to be opened for writing on file descriptor n, or the standard output file descriptor 1 if n is not specified. If the file does not exist, it is created. If it does exist, it is truncated to 0 size. The general format for redirecting output is optionally n greater than optionally pipe Word. If the redirection operator is greater than and the no clobber option to the set built-in has been enabled, the redirection will fail if the file whose name results from the expansion of Word exists and is a regular file. If the redirection operator is greater than pipe, or the redirection operator is greater than and the no clobber option is not enabled, the redirection is attempted even if the file named by Word exists. 3.6.3 Appending redirected output. Redirection of output in this fashion causes the file whose name results from the expansion of Word to be opened for appending on file descriptor n, or standard output file descriptor 1 if n is not specified. If the file does not exist, it is created. The general format for appending output is optionally n double greater than Word. 3.6.4 Redirecting standard output and standard error. This construct allows both the standard output file descriptor 1 and the standard error output file descriptor 2 to be redirected to the file whose name is the expansion of Word. There are two formats for redirecting standard output and standard error: ampersand greater than Word and greater than ampersand Word. Of the two forms, the first is preferred. This is semantically equivalent to greater than Word space 2 greater than ampersand 1. When using the second form, Word may not expand to a number or hyphen. If it does, other redirection operators apply. See duplicating file descriptors below for compatibility reasons. 3.6.5 Appending standard output and standard error. This construct allows both the standard output file descriptor 1 and the standard error output file descriptor 2 to be appended to the file whose name is the expansion of Word. The format for appending standard output and standard error is ampersand double greater than Word. This is semantically equivalent to double greater than Word space 2 greater than ampersand 1. See duplicating file descriptors below. 3.6.6 Here documents. This type of redirection instructs the shell to read input from the current source until a line containing only Word with no trailing blanks is seen. All of the lines read up to that point are then used as standard input or file descriptor n if n is specified for a command. The format of here documents is optionally n double less than optionally hyphen word, new line, here document, new line delimiter. No parameter and variable expansion, command substitution, arithmetic expansion, or filename expansion is performed on Word. If any part of Word is quoted, the delimiter is the result of quote removal on Word, and the lines in the here document are not expanded. If Word is unquoted, all lines of the here document are subject to parameter expansion, command substitution, and arithmetic expansion. The character sequence \new line is ignored, and \ must be used to quote the characters $, and backtick. If the redirection operator is less than hyphen, then all leading tab characters are stripped from input lines and the line containing delimiter. This allows here documents within shell scripts to be indented in a natural fashion. 3.6.7 Here strings. A variant of here documents, the format is optionally n triple less than word. The word undergoes tilde expansion, parameter and variable expansion, command substitution, arithmetic expansion, and quote removal. Filename expansion and word splitting are not performed. The result is supplied as a single string with a new line appended to the command on its standard input, or file descriptor n if n is specified. 3.6.8 Duplicating file descriptors. The redirection operator. Optionally n less than ampersand word is used to duplicate input file descriptors. If word expands to one or more digits, the file descriptor denoted by n is made to be a copy of that file descriptor. If the digits in Word do not specify a file descriptor open for input, a redirection error occurs. If Word evaluates to dash, file descriptor n is closed. If n is not specified, the standard input, file descriptor 0, is used. The operator optionally n greater than ampersand word is used to similarly duplicate output file descriptors. If n is not specified, the standard output, file descriptor 1, is used. If the digits in Word do not specify a file descriptor open for output, a redirection error occurs. If Word evaluates to hyphen, file descriptor n is closed. As a special case, if n is omitted and the word does not expand to one or more digits or hyphen, the standard output and standard error are redirected as described previously. 3.6.9 Moving file descriptors. The redirection operator, optionally n less than ampersand digit dash, moves the file descriptor digit to file descriptor n, or the standard input file descriptor 0 if n is not specified. Digit is closed after being duplicated to n. Similarly, the redirection operator, optionally n greater than ampersand digit hyphen, moves the file descriptor digit to file descriptor n or the standard output file descriptor 1 if n is not specified. 3.6.10 Opening file descriptors for reading and writing. The redirection operator, optionally n less than greater than word, causes the file whose name is the expansion of Word to be opened for both reading and writing on file descriptor n or on file descriptor 0 if n is not specified. If the file does not exist, it is created. 3.7 Executing commands. 3.7.1 Simple command expansion. When a simple command is executed, the shell performs the following expansions, assignments, and redirections from left to right in the following order. Number 1. The words that the parser has marked as variable assignments, those preceding the command name, and redirections are saved for later processing. 2. The words that are not variable assignments or redirections are expanded. If any words remain after expansion, the first word is taken to be the name of the command and the remaining words are the arguments. 3. Redirections are performed as described above. 4. The text after the equals sign in each variable assignment undergoes tilde expansion, parameter expansion, command substitution, arithmetic expansion, and quote removal before being assigned to the variable. If no command name results, the variable assignments affect the current shell environment. In the case of such a command, one that consists only of assignment statements and redirections, assignment statements are performed before redirections. Otherwise, the variables are added to the environment of the executed command and do not affect the current shell environment. If any of the assignments attempt to assign a value to a read-only variable, an error occurs, and the command exits with a non-zero status. If no command name results, redirections are performed, but do not affect the current shell environment. A redirection error causes the command to exit with a non-zero status. If there is a command name left after expansion, execution proceeds as described below. Otherwise, the command exits. If one of the expansions contained a command substitution, the exit status of the command is the exit status of the last substitution performed. If there were no command substitutions, the command exits with a status of 0. 3.7.2 Command Search and Execution. After a command has been split into words, if it results in a simple command and an optional list of arguments, the following actions are taken. 1. If the command name contains no slashes, the shell attempts to locate it. If there exists a shell function by that name, that function is invoked as described in shell functions. 2. If the name does not match a function, the shell searches for it in the list of shell built-ins. If a match is found, that built-in is invoked. 3. If the name is neither a shell function nor a built-in and contains no slashes, bash searches each element of $path for a directory containing an executable file by that name. Bash uses a hash table to remember the full path names of executable files to avoid multiple path searches. A full path search of the directories in path is performed only if the command is not found in the hash table. If the search is unsuccessful, the shell searches for a defined shell function named command_not_found_handle. If that function exists, it is invoked in a separate execution environment with the original command and the original command's arguments as its arguments, and the function's exit status becomes the exit status of that subshell. If that function is not defined, the shell prints an error message and returns an exit status of 127. 4. If the search is successful, or if the command name contains one or more slashes, the shell executes the named program in a separate execution environment. Argument 0 is set to the name given, and the remaining arguments to the command are set to the arguments supplied, if any. 5. If this execution fails because the file is not in executable format and the file is not a directory, it is assumed to be a shell script, and the shell executes it as described in shell scripts. 6. If the command was not begun asynchronously, the shell waits for the command to complete and collects its exit status. 3.7.3 Command Execution Environment. The shell has an execution environment which consists of the following. Open files inherited by the shell at invocation as modified by redirections supplied to the exec built-in. The current working directory as set by cd, pushd, or popd, or inherited by the shell at invocation. The file creation mode mask as set by umask or inherited from the shell's parent. Current traps set by trap. Shell parameters that are set by variable assignment or with set or inherited from the shell's parent in the environment. Shell functions defined during execution or inherited from the shell's parent in the environment. Options enabled at invocation, either by default or with command line arguments or by set. Options enabled by shopt. Shell aliases defined with alias. Various process IDs, including those of background jobs, the value of $, and the value of $PPID. When a simple command other than a built-in or shell function is to be executed, it is invoked in a separate execution environment that consists of the following. Unless otherwise noted, the values are inherited from the shell. The shell's open files, plus any modifications and additions specified by redirections to the command, the current working directory, the file creation mode mask, shell variables and functions marked for export, along with variables exported for the command passed in the environment, and traps caught by the shell are reset to the values inherited from the shell's parent, and traps ignored by the shell are ignored. A command invoked in this separate environment cannot affect the shell's execution environment. A subshell is a copy of the shell process. Command substitution, commands grouped with parentheses, and asynchronous commands are invoked in a subshell environment that is a duplicate of the shell environment, except that traps caught by the shell are reset to the values that the shell inherited from its parent at invocation. Built-in commands that are invoked as part of a pipeline are also executed in a subshell environment. Changes made to the subshell environment cannot affect the shell's execution environment. Subshells spawned to execute command substitutions inherit the value of the -e option from the parent shell. When not in Posix mode, bash clears the -e option in such subshells. If a command is followed by a ampersand and job control is not active, the default standard input for the command is the empty file dev null. Otherwise, the invoked command inherits the file descriptors of the calling shell as modified by redirections. 3.7.4 Environment. When a program is invoked, it is given an array of strings called the environment. This is a list of name-value pairs of the form name equals value. Bash provides several ways to manipulate the environment. On invocation, the shell scans its own environment and creates a parameter for each name found, automatically marking it for export to child processes. Executed commands inherit the environment. The export and declare-x command allow parameters and functions to be added to and deleted from the environment. If the value of a parameter in the environment is modified, the new value becomes part of the environment, replacing the old. The environment inherited by any executed command consists of the shell's initial environment, whose values may be modified in the shell, less any pairs removed by the unset and export-n commands, plus any additions via the export and declare-x commands. The environment for any simple command or function may be augmented temporarily by prefixing it with parameter assignments, as described in shell parameters. These assignment statements affect only the environment seen by that command. If the -k option is set, then all parameter assignments are placed in the environment for a command, not just those that precede the command name. When bash invokes an external command, the variable $_ is set to the full path name of the command and passed to that command in its environment. 3.7.5 Exit Status. The exit status of an executed command is the value returned by the waitpid system call or equivalent function. Exit statuses fall between 0 and 255, though as explained below, this shell may use values above 125 specially. Exit statuses from shell built-ins and compound commands are also limited to this range. Under certain circumstances, this shell will use special values to indicate specific failure modes. For the shell's purposes, a command which exits with a 0 exit status has succeeded. A non-zero exit status indicates failure. This seemingly counterintuitive scheme is used so that there is one well-defined way to indicate success and a variety of ways to indicate various failure modes. When a command terminates on a fatal signal whose number is n, bash uses the value 128 plus n as the exit status. If a command is not found, the child process created to execute it returns a status of 127. If a command is found but not executable, the return status is 126. If a command fails because of an error during expansion or redirection, the exit status is greater than 0. The exit status is used by bash conditional commands and some of the list constructs. All of the bash built-ins return an exit status of 0 if they succeed and a non-zero status on failure, so they may be used by the conditional and list constructs. All built-ins return an exit status of 2 to indicate incorrect usage, generally invalid options or missing arguments. The exit status of the last command is available in the special parameter $?? 3.7.6 Signals. When bash is interactive, in the absence of any traps, it ignores sigterm, so that kill 0 does not kill an interactive shell, and sigint is caught and handled, so that the wait built-in is interruptible. When bash receives a sigint, it breaks out of any executing loops. In all cases, bash ignores sigquit. If job control is in effect, bash ignores sigtton, sigttau, and sigtstop. Non-built-in commands started by bash have signal handlers set to the values inherited by the shell from its parent. When job control is not in effect, asynchronous commands ignore sigint and sigquit in addition to these inherited handlers. Commands run as a result of command substitution ignore the keyboard-generated job control signals sigtton, sigttau, and sigtstop. The shell exits by default upon receipt of a sighup. Before exiting, an interactive shell resends the sighup to all jobs, running or stopped. Stopped jobs are sent sigcont to ensure that they receive the sighup. To prevent the shells from sending the sighup signal to a particular job, it should be removed from the jobs table with the disown built-in, or marked to not receive sighup using disown-h. If the hup on exit shell option has been set with shopped, bash sends a sighup to all jobs when an interactive login shell exits. If bash is waiting for a command to complete and receives a signal for which a trap has been set, the trap will not be executed until the command completes. When bash is waiting for an asynchronous command via the wait built-in, the reception of a signal for which a trap has been set will cause the wait built-in to return immediately with an exit status greater than 128, immediately after which the trap is executed. When job control is not enabled, and bash is waiting for a foreground command to complete, the shell receives keyboard-generated signals such as sigint, usually generated by Control-C, that users commonly intend to send to the command. This happens because the shell and the command are in the same process group as the terminal, and Control-C sends sigint to all processes in the process group. See job control for a more in-depth discussion of process groups. When bash is running without job control enabled and receives sigint while waiting for a foreground command, it waits until that foreground command terminates and then decides what to do about the sigint. If the command terminates due to sigint, bash concludes that the user meant to end the entire script and acts on the sigint, e.g. by running a sigint trap or exiting itself. If the pipeline does not terminate due to sigint, the program handled the sigint itself and did not treat it as a fatal signal. In that case, bash does not treat sigint as a fatal signal either, instead assuming that sigint was used as part of the program's normal operation, e.g. Emacs uses it to abort editing commands, or deliberately discarded. However, bash will run any trap set on sigint, as it does with any other trapped signal it receives while it is waiting for the foreground command to complete, for compatibility. 3.8 Shell Scripts. A shell script is a text file containing shell commands. When such a file is used as the first non-option argument when invoking bash, and neither the -c nor -s option is supplied, bash reads and executes commands from the file, then exits. This mode of operation creates a non-interactive shell. The shell first searches for the file in the current directory and looks in the directories in path if not found there. When bash runs a shell script, it sets the special parameter 0 to the name of the file rather than the name of the shell, and the positional parameters are set to the remaining arguments, if any are given. If no additional arguments are supplied, the positional parameters are unset. A shell script may be made executable by using the chmod command to turn on the execute bit. When bash finds such a file while searching the path for a command, it creates a new instance of itself to execute it. In other words, executing filename arguments is equivalent to executing bash filename arguments if filename is an executable shell script. This subshell reinitializes itself so that the effect is as if a new shell had been invoked to interpret the script, with the exception that the locations of commands remembered by the parent are retained by the child. Most versions of Unix make this a part of the operating system's command execution mechanism. If the first line of a script begins with the two characters $! Exclamation mark, the remainder of the line specifies an interpreter for the program and, depending on the operating system, one or more optional arguments for that interpreter. Thus, you can specify bash, awk, perl, or some other interpreter and write the rest of your script file in that language. The arguments to the interpreter consist of one or more optional arguments following the interpreter name on the first line of the script file, followed by the name of the script file, followed by the rest of the arguments supplied to the script. The details of how the interpreter line is split into an interpreter name and a set of arguments vary across systems. Bash will perform this action on operating systems that do not handle it themselves. Note that some older versions of Unix limit the interpreter name and a single argument to a maximum of 32 characters, so it's not portable to assume using more than one argument will work. Bash scripts often begin with #! /bin/bash, assuming that bash has been installed in /bin, since this ensures that bash will be used to interpret the script, even if it is executed under another shell. It's a common idiom to use env to find bash, even if it's been installed in another directory. #!/user/bin/env bash will find the first occurrence of bash in path. Chapter 4. Shell built-in commands. Built-in commands are contained within the shell itself. When the name of a built-in command is used as the first word of a simple command, the shell executes the command directly, without invoking another program. Built-in commands are necessary to implement functionality impossible or inconvenient to obtain with separate utilities. This section briefly describes the built-ins which bash inherits from the Bourne shell, as well as the built-in commands which are unique to or have been extended in bash. Several built-in commands are described in other chapters. Built-in commands which provide the bash interface to the job control facilities, the directory stack, the command history, and the programmable completion facilities. Many of these built-ins have been extended by Posix or bash. Unless otherwise noted, each built-in command documented as accepting options preceding by dash accepts -- to signify the end of the options. The : true, false, and test / open square bracket built-ins do not accept options and do not treat the -- specially. The exit, logout, return, break, continue, let, and shift built-ins accept and process arguments beginning with the dash without requiring -- Other built-ins that are accept arguments but are not specified as accepting options interpret arguments beginning with dash as individual options and require -- to prevent this interpretation. 4.1 Bourne shell built-ins. The following shell built-in commands are inherited from the Bourne shell. These commands are implemented as specified by the Posix standard. : Do nothing beyond expanding arguments and performing redirections. The return status is 0. Filename optional arguments. Read and execute commands from the file name argument in the current shell context. If file name does not contain a slash, the path variable is used to find file name, but file name does not need to be executable. When bash is not in Posix mode, it searches the current directory if file name is not found in path. If any arguments are supplied, they become positional parameters when file name is executed. Otherwise, the positional parameters are unchanged. If the -t option is enabled, dot inherits any trap on debug. If it is not, any debug trap string is saved and restored around the call to dot, and dot unsets the debug trap while it executes. If -t is not set, and the source file changes the debug trap, the new value is retained when dot completes. The return status is the exit status of the last command executed, or 0 if no commands are executed. If file name is not found or cannot be read, the return status is non-zero. This built-in is equivalent to source. Break, optionally n. Exit from a for, while, until, or select loop. If n is supplied, the nth enclosing loop is exited. N must be greater than or equal to 1. The return status is 0 unless n is not greater than or equal to 1. CD, optionally -uppercase L or -uppercase P with an optional -lowercase e, and then optionally @ optionally directory. Change the current working directory to directory. If directory is not supplied, the value of the home shell variable is used. If the shell variable cd path exists, it is used as a search path. Each directory name in cd path is searched for directory, with alternative directory names in cd path separated by a colon. If directory begins with a slash, cd path is not used. The -p option means to not allow. The -p option means to not follow symbolic links. Symbolic links are resolved while cd is traversing directory and before processing an instance of ... in directory. By default, or when the -l option is supplied, symbolic links in directory are resolved after cd processes an instance of ... in directory. If ... appears in directory, it is processed by removing the immediately preceding path name component back to a slash or the beginning of directory. If the -e option is supplied with -p and the current working directory cannot be successfully determined after a successful directory change, cd will return an unsuccessful status. On systems that support it, the @ option presents the extended attributes associated with a file as a directory. If the directory is dash, it is converted to old pwd before the directory change is attempted. If a non-empty directory name from cd path is used, or if dash is the first argument, the directory change is successful. The absolute path name of the new working directory is written to the standard output. If the directory change is successful, cd sets the value of the pwd variable to the new directory name and sets the old pwd variable to the value of the current working directory before the change. The return status is 0 if the directory is successfully changed and non-zero otherwise. Continue with an optional n. Resume the next iteration of an enclosing for, while, until, or select loop. If n is supplied, the execution of the nth enclosing loop is resumed. N must be greater than or equal to 1. The return status is 0 unless n is not greater than or equal to 1. Eval with optional arguments. The arguments are concatenated together into a single command, which is then read and executed, and its exit status returned as the exit status of eval. If there are no arguments or only empty arguments, the return status is 0. Exec with an optional -cl, with an optional -a name, with an optional command that has optional arguments. If command is supplied, it replaces the shell without creating a new process. If the -L option is supplied, the shell places a dash at the beginning of the 0th argument passed to command. This is what the login program does. The -C option causes command to be executed with an empty environment. If -A is supplied, the shell passes name as the 0th argument to command. If command cannot be executed for some reason, a non-interactive shell exits, unless the exec_fail shell option is enabled. In that case, it returns failure. An interactive shell returns failure if this file cannot be executed. A subshell exits unconditionally if exec fails. If no command is specified, redirections may be used to affect the current shell environment. If there are no redirection errors, the return status is 0. Otherwise, the return status is non-zero. Exit with an optional n. Exit the shell, returning a status of n to the shell's parent. If n is omitted, the exit status is that of the last command executed. Any trap on exit is executed before the shell terminates. Export with an optional -fn, an optional -p, and an optional name equals value. Mark each name to be passed to child processes in the environment. If the -f option is supplied, the names refer to shell functions. Otherwise, the names refer to shell variables. The -n option means to no longer mark each name for export. If no names are supplied, or if the -p option is given, a list of names of all exported variables is displayed. The -p option displays output in a form that may be reused as input. If a variable name is followed by equals value, the value of the variable is set to the value. The return status is 0 unless an invalid option is supplied. One of the names is not a valid shell variable name, or -f is supplied with a name that is not a shell function. GetOpts. GetOpts, optstring, name, optional list of args. GetOpts is used by a shell script to parse positional parameters. Optstring contains the option characters to be recognized. If a character is followed by a colon, the option is expected to have an argument, which should be separated from it by whitespace. The colon and question mark may not be used as option characters. Each time it is invoked, getOpts places the next option in the shell variable name, initializing name if it does not exist, and the index of the next argument to be processed into the variable opt_ind. Opt_ind is initialized to 1 each time the shell or a shell script is invoked. When an option requires an argument, getOpts places that argument into the variable optarg. The shell does not reset opt_ind automatically. It must be manually reset between multiple calls to getOpts within the same shell invocation if a new set of parameters is to be used. When the end of options is encountered, getOpts exits with a return value greater than 0. Opt_ind is set to the index of the first non-option argument, and name is set to question mark. getOpts normally parses the positional parameters, but if more arguments are supplied as arg values, getOpts parses those instead. getOpts can report errors in 2 ways. If the first character of optstring is a colon, silent error reporting is used. In normal operation, diagnostic messages are printed when invalid options or missing option arguments are encountered. If the variable opt_error is set to 0, no error messages will be displayed, even if the first character of optstring is not a colon. If an invalid option is seen, getOpts places question mark into name and, if not silent, prints an error message and unsets optarg. If getOpts is silent, the option character found is placed in optarg and no diagnostic message is printed. If a required argument is not found and getOpts is not silent, a question mark is placed in names. Optarg is unset and a diagnostic message is printed. If getOpts is silent, then a colon is placed in name, and opt_arg is set to the option character found. Hash, with an optional -r, an optional -p file name, an optional -dt, and an optional name. Each time hash is invoked, it remembers the full path names of the command specified as name arguments, so they need not be searched for on certain invocations. The commands are found by searching through the directories listed in path. Any previously remembered path name is discarded. The -p option inhibits the path search, and the file name is used as the location of name. The -r option causes the shell to forget all remembered locations. The -d option causes the shell to forget the remembered location of each name. If the -t option is supplied, the full path name to which each name corresponds is printed. If multiple name arguments are supplied with -t, the name is printed before the hashed full path name. The -l option causes output to be displayed in a format that may be reused as input. If no arguments are given, or if only -l is supplied, information about remembered commands is printed. The return status is 0 unless a name is not found or an invalid option is supplied. PWD with an optional -lp. Print the absolute path name of the current working directory. If the -p option is supplied, the path name printed will not contain symbolic links. If the -l option is supplied, the path name printed may contain symbolic links. The return status is 0 unless an error is encountered while determining the name of the current directory or an invalid option is supplied. Read only with the flags A, capital A, F, P, and optionally name equals value. Mark each name as read only. The values of these names may not be changed by subsequent assignment. If the -f option is supplied, each name refers to a shell function. The -a option means each name refers to an indexed array variable. The -A option means each name refers to an associative array variable. If both options are supplied, -A takes precedence. If no name arguments are given, or if the -p option is supplied, a list of all read-only names is printed. The other options may be used to restrict the output to a subset of the set of read-only names. The -p option causes output to be displayed in a format that may be reused as input. If a variable name is followed by equals value, the value of the variable is set to the value. The return status is 0 unless an invalid option is supplied, one of the name arguments is not a valid shell variable or function name, or the -f option is supplied with a name that is not a shell function. Return with an optional n causes a shell function to stop executing and return the value n to its caller. If n is not supplied, the return value is the exit status of the last command executed in the function. If return is executed by a trap handler, the last command used to determine the status is the last command executed before the trap handler. If return is executed during a debug trap, the last command used to determine the status is the last command executed by the trap handler before return was invoked. Return may also be used to terminate execution of a script being executed with the dot or source built in, returning either n or the exit status of the last command executed within the script as the exit status of the script. If n is supplied, the return value is its least significant 8 bits. Any command associated with the return trap is executed before execution resumes after the function or script. The return status is non-zero if return is supplied a non-numeric argument or is used outside a function and not during the execution of a script by dot or source. Shift with an optional n. Shift the positional parameters to the left by n. The positional parameters from n+1 to $, $, are renamed to $1, $n. Parameters represented by the numbers $, down to $, n+1 are unset. N must be a non-negative number less than or equal to $. If n is 0 or greater than $pound, the positional parameters are not changed. If n is not supplied, it is assumed to be 1. The return status is 0 unless n is greater than $pound or less than 0, non-zero otherwise. Test, also known as open square bracket, expression. Evaluate a conditional expression, and return status of 0, true, or 1, false. Each operator and operand must be a separate argument. Expressions are composed of the primaries described below in bash conditional expressions. Test does not accept any options, nor does it accept and ignore an argument of dash dash as signifying the end of options. When the open square bracket form is used, the last argument to the command must be a closed square bracket. Expressions may be combined using the following operators, listed in decreasing order of precedence. The evaluation depends on the number of arguments, see below. Operator precedence is used when there are 5 or more expressions. Exclamation mark expression, true if expression is false. Parentheses expression, return the value of expression. This may be used to override the normal precedence of operators. Expression 1 -a expression 2. True if both expression 1 and expression 2 are true. Expression 1-o expression 2. True if either expression 1 or expression 2 is true. The test and open square bracket built-ins evaluate conditional expressions using a set of rules based on the number of arguments. 0 arguments. The expression is false. 1 argument. The expression is true if and only if the argument is not null. 2 arguments. If the first argument is exclamation mark, the expression is true if and only if the second argument is null. If the first argument is one of the unary conditional operators, the expression is true if the unary test is true. If the first argument is not a valid unary operator, the expression is false. 3 arguments. The following conditions are applied in the order listed. 1. If the second argument is one of the binary conditional operators, the result of the expression is the result of the binary test using the first and third arguments as operands. The -a and -o operators are considered binary operators when there are 3 arguments. 2. If the first argument is exclamation mark, the value is the negation of the 2-argument test using the second and third arguments. 3. If the first argument is exactly open parenthesis and the third argument is exactly close parenthesis, the result is the 1-argument test of the second argument. 4. Otherwise, the expression is false. 4 arguments. The following conditions are applied in the order listed. 1. If the first argument is exclamation mark, the result is the negation of the 3-argument expression composed of the remaining arguments. If the first argument is exactly open parenthesis and the fourth argument is exactly close parenthesis, the result is the 2-argument test of the second and third arguments. 3. Otherwise, the expression is parsed and evaluated according to precedence using the rules listed above. 5 or more arguments. The expression is parsed and evaluated according to precedence using the rules listed above. When used with test or open square bracket, the less than and greater than operators sort lexicographically using ASCII ordering. Times. Print out the user and system times used by the shell and its children. The return status is 0. Trap, with flags L and P, taking an optional arg and an optional list of sig specs. The commands in arg are to be read and executed when the shell receives signal sigspec. If arg is absent and there is a single sigspec, or equal to dash, each specified signal's disposition is reset to the value it had when the shell was started. If arg is the null string, then the signal specified by each sigspec is ignored by the shell and commands it invokes. If arg is not present and -p has been supplied, the shell displays the trap commands associated with each sigspec. If no arguments are supplied or only -p is given, trap prints the list of commands associated with each signal number in a form that it may be reused as shell input. The -l option causes the shell to print a list of signal names and their corresponding numbers. Each sigspec is either a signal name or a signal number. Signal names are case insensitive and the sig prefix is optional. If a sigspec is 0 or exit, arg is executed when the shell exits. If a sigspec is debug, the command arg is executed for every simple command, for command, case command, select command, every arithmetic for command, and before the first command executes in a shell function. Refer to the description of the ext-debug option to the shopped built-in for details of its effect on the debug trap. If a sigspec is return, the command arg is executed each time a shell function or script executed with the dot or source built-ins finishes executing. If a sigspec is error, the command arg is executed whenever a pipeline, which may consist of a single simple command, a list, or a compound command returns a non-zero exit status, subject to the following conditions. The error trap is not executed if the failed command is part of the command list immediately following an until or while keyword, part of the test following the if or elif reserved words, part of a command executed in a double ampersand or double pipe list, except the command following the final double ampersand or double pipe, any command in a pipeline but the last, or if the command's return status is being inverted using exclamation mark. These are the same conditions obeyed by the error exit -e option. Signals ignored upon entry to the shell cannot be trapped or reset. Trapped signals that are not being ignored are reset to their original values in a subshell or subshell environment when one is created. The return status is 0 unless a sigspec does not specify a valid signal. umask with an optional -p, an optional -s, and an optional mode. Set the shell process's file creation mask to mode. If mode begins with a digit, it is interpreted as an octal number. If not, it is interpreted as a symbolic mode mask, similar to that accepted by the chmod command. If mode is omitted, the current value of the mask is printed. If the -s option is supplied without a mode argument, the mask is printed in a symbolic format. If the -p option is supplied, the mode is omitted. The output is in a form that may be reused as input. The return status is 0 if the mode is successfully changed or if no mode argument is supplied, and non-zero otherwise. Note that when the mode is interpreted as an octal number, each number of the umask is subtracted from 7. Thus, a umask of 022 results in permissions of 755. Unset with optional flags fnv and an optional name. Remove each variable or function name. If the -v option is given, each name refers to a shell variable and that variable is removed. If the -f option is given, the names refer to shell functions, and the function definition is removed. If the -n option is supplied, and the name is a variable with the namerefs attribute, name will be unset rather than the variable it references. -n has no effect if the -f option is supplied. If no options are supplied, each name refers to a variable. If there is no variable by that name, a function with that name, if any, is unset. Read-only variables and functions may not be unset. Some shell variables lose their special behavior if they are unset. Such behavior is noted in the description of the individual variables. The return status is 0 unless a name is read-only or may not be unset. This section describes built-in commands which are unique to or have been extended in Bash. Some of these commands are specified in the Posix standard. Alias with an optional flag p and an optional name equal value list. Without arguments or with the -p option, Alias prints the list of aliases on the standard output in a form that allows them to be reused as input. If arguments are supplied, an alias is defined for each name whose value is given. If no value is given, the name and value of the alias is printed. Aliases are described in aliases. Bind. Bind takes an optional -m key map, a bunch of flags. There's a lot of forms of bind. Let's just keep reading. Display current readline key and function bindings. Bind a key sequence to a readline function or macro, or set a readline variable. Each non-option argument is a command as it would appear in a readline initialization file. But each binding or command must be passed as a separate argument. For example, /C -x /C-r :read-init -file. Options, if supplied, have the following meanings. -m keymap. Use keymap as the keymap to be affected by the subsequent bindings. Acceptable keymap names are Emacs, Emacs-standard, Emacs-meta, Emacs-ctlx, VI, VI-move, VI-command, and VI-insert. VI is equivalent to VI-command. VI-move is also a synonym. Emacs is equivalent to Emacs-standard. -L. List the names of all readline functions. -P. Display readline function names and bindings in such a way that they can be used as input or in a readline initialization file. -P. List current readline function names and bindings. -V. Display readline variable names and values in such a way that they can be used as input or in a readline initialization file. -V. List current readline variable names and values. -S. Display a readline key sequence bound to macros and the strings they output in such a way that they can be used as input or in a readline initialization file. -S. Display readline key sequences bound to macros and the strings they output. -F file name. Read key bindings from file name. -Q function. Query about which keys invoke the named function. -U function. Unbind all keys bound to the named function. -R key sequence. Remove any current bindings for key sequence. -X key sequence : shell command. Cause shell command to be executed whenever key sequence is entered. When shell command is executed, the shell sets the readline line variable to the contents of the readline line buffer, and the readline point and readline mark variables to the current location of the insertion point and the saved insertion point, the mark, respectively. The shell assigns any numeric argument the user supplied to the readline argument variable. If there was no argument, the variable is not set. If the executed command changes the value of any of the readline line, readline point, or readline mark, those new values will be reflected in the editing state. -X. List all key sequences bound to shell commands and the associated commands in a format that can be reused as input. The return status is 0 unless an invalid option is supplied or an error occurs. Built-in. Run a shell built-in, passing it args, and return its exit status. This is useful when defining a shell function with the same name as a shell built-in, retaining the functionality of the built-in within the function. The return status is non-zero if shell built-in is not a shell built-in command. Caller expression returns the context of any active subroutine call, a shell function or a script executed with the dot or source built-ins. Without expression, caller displays the line number and source file name of the current subroutine call. If a non-negative integer is supplied as expression, caller displays the line number, subroutine name, and source file corresponding to that position in the current execution call stack. This extra information may be used, for example, to print a stack trace. The current frame is frame 0. The return value is 0 unless the shell is not executing a subroutine call or expression does not correspond to a valid position in the call stack. Command with flags P, uppercase V, lowercase v, and then a required command, and then an optional list of arguments. Runs a command with arguments ignoring any shell function named command. Only shell built-in commands or commands found by searching the path are executed. If there is a shell function named ls, running command ls within the function will execute the external command ls instead of calling the function recursively. The -p option means to use a default value for path that is guaranteed to find all of the standard utilities. The return status in this case is 127 if command cannot be found or an error occurred, and the exit status of command otherwise. If either the -uppercase V or lowercase v option is supplied, a description of command is printed. The -lowercase v option causes a single word indicating the command or file name used to invoke command to be displayed. The -v uppercase option produces a more verbose description. In this case, the return status is 0 if command is found and non-zero if not. Declare with the flags A, uppercase A, F, uppercase F, G, I, uppercase I, L, N, R, T, U, X, optionally -p, and optionally a list of name equal value pairs. Declare variables and give them attributes. If no names are given, then display the values of variables instead. The -p option will display the attributes and values of each name. When -p is used with name arguments, additional options other than -f and -f are ignored. When -p is supplied without name arguments, declare will display the attributes and values of all variables having the attributes specified by the additional options. If no other options are supplied with -p, declare will display the attributes and values of all shell variables. The -f option will restrict the display to shell functions. The -f uppercase option inhibits the display of function definitions. Only the function name and attributes are printed. If the ext debug shell option is enabled using shopt, the source file name and line number where each name is defined are displayed as well. -uppercase F implies lowercase -f. The -g option forces variables to be created or modified at the global scope, even when declare is executed in a shell function. It is ignored in all other cases. The -uppercase I option causes local variables to inherit the attributes, except the nameref attribute, and value of any existing variable with the same name at the surrounding scope. If there is no existing variable, the local variable is initially unset. The following options can be used to restrict output to variables with the specified attributes or to give variables attributes. -lowercase a. Each name is an indexed array variable. -uppercase A. Each name is an associative array variable. -f. Use function names only. -i. The variable is to be treated as an integer. Arithmetic evaluation is performed when the variable is assigned a value. -lowercase l. When the variable is assigned a value, all uppercase characters are converted to lowercase. The uppercase attribute is disabled. -n. Give each name the nameref attribute, making it a name reference to another variable. That other variable is defined by the value of name. All references, assignments, and attribute modifications to name, except for those using or changing the -n attribute itself, are performed on the variable referenced by name's value. The nameref attribute cannot be applied to array variables. -R, make names read-only. These names cannot be assigned values by subsequent assignment statements or unset. -T, give each name the trace attribute. Traced functions inherit the debug and return traps from the calling shell. The trace attribute has no special meaning for variables. -U, when the variable is assigned a value, all lowercase characters are converted to uppercase. The lowercase attribute is disabled. -X, mark each name for export to subsequent commands via the environment. Using plus instead of minus turns off the attributes instead, with the exceptions that +A and +A may not be used to destroy array variables, and +R will not remove the read-only attribute. When used in a function, declare makes each name local, as with the local command, unless the -G option is used. If a variable name is followed by equals value, the value of that variable is set to a value. When -A or $A is used and the compound assignment syntax to create array variables, additional attributes do not take effect until subsequent assignments. The return status is 0 unless an invalid option is encountered, an attempt is made to define a function using -F foo equals bar, an attempt is made to assign a value to a read-only variable, an attempt is made to assign a value to an array variable without using the compound assignment syntax. One of the names is not a valid shell variable name. An attempt is made to turn off read-only status for a read-only variable. An attempt is made to turn off array status for an array variable, or an attempt is made to display a non-existent function with -F. Echo, with optional flags N, E, uppercase E, and an optional list of args. Output the args separated by spaces terminated with a new line. The return status is 0 unless a write error occurs. If -N is specified, the trailing new line is suppressed. If the -E option is given, interpretation of the following \escaped characters is enabled. The -E option disables the interpretation of these escaped characters, even on systems where they are interpreted by default. The XPG_echo shell option may be used to dynamically determine whether or not echo expands these escape characters by default. Echo does not interpret -- to mean the end of options. Echo interprets the following escape sequences: \A, alert, bell; \B, backspace; \C, suppress further output; \E or uppercase E, escape; \F, form feed; \N, new line; \R, carriage return; \T, horizontal tab; \V, vertical tab; double backslash is a literal backslash; \0NNN, the 8-bit character whose value is the octal value NNN, 0 to 3 octal digits; \XHH, the 8-bit character whose value is the hexadecimal value HH, 1 or 2 hex digits; \UHHHH, the Unicode ISO IEC 10646 character whose value is the hexadecimal value HHHH, 1 to 4 hex digits; and \uppercase U HHHH, the Unicode ISO IEC 10646 character whose value is the hexadecimal value HHHHHHH, 1 to 8 hex digits. Enable with an optional -A, an optional DNPS flag, an optional -F file name flag, and an optional list of names. Enable and disable built-in shell commands. Disabling a built-in allows a disk command which has the same name as a shell built-in to be executed without specifying a full path name, even though the shell normally searches for built-ins before disk commands. If -N is used, the names become disabled. Otherwise, names are enabled. For example, to use the test binary found via path instead of the shell built-in version, type enable-n test. If the -p option is supplied or no other argument appears, a list of shell built-ins is printed. With no other arguments, the list consists of all enabled shell built-ins. The -a option means to list each built-in with an indication of whether or not it is enabled. The -f option means to load the new built-in command from shared object file name on systems that support dynamic loading. Bash will use the value of the bash_loadables_path variable as a colon-separated list of directories in which to search for file name. The default is system dependent. The -d option will delete a built-in loaded with -f. If there are no options, a list of the shell built-ins is displayed. The -s option restricts enable to the Posix special built-ins. If -s is used with -f, the new built-in becomes a special built-in. If no options are supplied and a name is not a shell built-in, enable will attempt to load name from a shared object named name, as if the command were enable-f name. The return status is 0 unless a name is not a shell built-in or there is an error loading a new built-in from a shared object. Help with the DMS optional flags and an optional pattern. Display helpful information about built-in commands. If pattern is specified, help gives detailed help on all commands matching pattern. Otherwise, a list of built-ins is printed. Options, if supplied, have the following meanings. -d, display a short description of each pattern. -m, display the description of each pattern in a man page-like format. -s, display only a short usage synopsis for each pattern. The return status is 0 unless no command matches pattern. Let expression, and then a list of optional extra expressions. The let built-in allows arithmetic to be performed on shell variables. Each expression is evaluated according to the rules given below in shell arithmetic. If the last expression evaluates to 0, let returns 1. Otherwise, 0 is returned. Local with an optional option and a required name with an optional value and a list of other names and optional values. For each argument, a local variable named name is created and assigned value. The option can be any of the options accepted by declare. Local can only be used within a function. It makes the variable name have a visible scope restricted to that function and its children. If name is dash, the set of shell options is made local to the function in which local is invoked. Shell options changed using the set built-in inside the function are restored to their original values when the function returns. The restore is affected as if a series of set commands were executed to restore the values that were in place before the function. The return status is 0 unless local is used outside a function, an invalid name is supplied, or name is a read-only variable. Logout with an optional n. Exit a login shell, returning a status of n to the shell's parent. Map file. Read lines from the standard input into the indexed array variable array, or from file descriptor fd if the -u option is supplied. The variable map file is the default array. Options, if supplied, have the following meanings. -d. The first character of delim is used to terminate each input line, rather than new line. If delim is the empty string, mapfile will terminate a line when it reads a null character. -n. Copy at most count lines. If count is 0, all lines are copied. -o. Begin assigning to array at index origin. The default index is 0. -s. Discard the first count lines read. -t. Remove a trailing delim, default new line, from each line read. -u. Read lines from file descriptor fd instead of the standard input. -C. Evaluate callback each time quantum lines are read. The -C option specifies quantum. -C. Specify the number of lines read between each call to callback. If -C is specified without lowercase -c, the default quantum is 5,000. When callback is evaluated, it is supplied the index of the next array element to be assigned and the line to be assigned to that element as additional arguments. Callback is evaluated after the line is read, but before the array element is assigned. If not supplied with an explicit origin, mapfile will clear array before assigning to it. Mapfile returns successfully unless an invalid option or option argument is supplied, array is invalid or unassignable, or array is not an indexed array. Printf with an optional -v var, a required format, and optional arguments. Write the formatted argument to the standard output under the control of the format. The -v option causes the output to be assigned to the variable var rather than being printed to the standard output. The format is a character string which contains 3 types of objects: plain characters, which are simply copied to standard output, character escape sequences, which are converted and copied to the standard output, and format specifications, each of which causes printing of the next successive argument. In addition to the standard printf formats, printf interprets the following extensions. %b causes printf to expand \escape sequences in the corresponding argument in the same way as echo-e. %q causes printf to output the corresponding argument in a format that can be reused as shell input. %q, like %q, but applies any supplied precision to the argument before quoting it. %date format T causes printf to output the date time string resulting from using date format as a format string for stir ftime. The corresponding argument is an integer representing the number of seconds since the epoch. 2 special argument values may be used. -1 represents the current time, and -2 represents the time the shell was invoked. If no argument is specified, conversion behaves as if -1 had been given. This is an exception to the usual printf behavior. The %b, %q, and %t directives all use the field width and precision arguments from the format specification and write that many bytes or use that wide a field for the expanded argument, which usually contains more characters than the original. Arguments to non-string format specifiers are treated as C language constants, except that a leading plus or minus sign is allowed, and if the leading character is a single or double quote, the value is the ASCII value of the following character. The format is reused as necessary to consume all of the arguments. If the format requires more arguments than are supplied, the extra format specifications behave as if a 0 value or null string, as appropriate, had been supplied. The return value is 0 on success, non-zero on failure. Read. One line is read from the standard input or from the file descriptor fd supplied as an argument to the -u option, split into words as described above in word splitting, and the first word is assigned to the first name and the second word to the second name, and so on. If there are more words than names, the remaining words and their intervening delimiters are assigned to the last name. If there are fewer words read from the input stream than names, the remaining names are assigned empty values. The characters in the value of the IFS variable are used to split the line into words using the same rules the shell uses for expansion. The / character may be used to remove any special meaning for the next character read and for line continuation. Options, if supplied, have the following meanings. -a. The words are assigned to sequential indices of the array variable a_name, starting at 0. All elements are removed from a_name before the assignment. Other name arguments are ignored. -d delim. The first character of delim is used to terminate the input line rather than the new line. If delim is the empty string, read will terminate a line when it reads a null character. -E, read line is used to obtain the line. Read line uses the current line or default if line editing was not previously active, editing settings, but uses readline's default file name completion. -I text. If readline is being used to read the line, text is placed into the editing buffer before editing begins. -N chars. Read returns after reading n chars characters rather than waiting for a complete line of input, but honors a delimiter if fewer than n chars characters are read before the delimiter. -N chars. Read returns after reading exactly n chars characters rather than waiting for a complete line of input, unless EOF is encountered or read times out. Delimiter characters encountered in the input are not treated specially and do not cause read to return until n chars characters are read. The result is not split on the characters in IFS. The intent is that the variable is assigned exactly the characters read, with the exception of \. See the -R option below. -P prompt. Display prompt without a trailing new line before attempting to read any input. The prompt is displayed only if input is coming from a terminal. -R. If this option is given, \/ does not act as an escape character. The \ is considered to be part of the line. In particular, a \ new line pair may not then be used as a line continuation. -S. Silent mode. If input is coming from a terminal, characters are not echoed. -T. Timeout. Cause read to timeout and return a failure if a complete line of input or a specified number of characters is not read within timeout seconds. Timeout may be a decimal number with a fractional portion following the decimal point. This option is only effective if read is reading input from a terminal, pipe, or other special file. It has no effect when reading from regular files. If read times out, read saves any partial input into the specified variable name. If timeout is 0, read returns immediately without trying to read any data. The exit status is 0 if input is available on the specified file descriptor, or the read will return EOF, non-zero otherwise. The exit status is greater than 128 if the timeout is exceeded. -U FD. Read input from the file descriptor FD. If no names are supplied, the line read without the ending delimiter but otherwise unmodified is assigned to the variable reply. The exit status is 0 unless end of file is encountered, read times out, in which case the status is greater than 128. A variable assignment error, such as assigning to a read-only variable, occurs, or an invalid file descriptor is supplied as the argument to -U. Read array. Read lines from the standard input into the indexed array variable array, or from file descriptor FD if the -U option is supplied. A synonym for map file. Source file name. A synonym for dot. Type. For each name, indicate how it would be interpreted if used as a command name. If the -T option is used, type prints a single word, which is one of alias, function, built-in, file, or keyword. If name is an alias, shell function, shell built-in, disk file, or shell reserved word, respectively. If the name is not found, then nothing is printed, and type returns a failure status. If the -P option is used, type either returns the name of the disk file that would be executed, or nothing if -T would not return file. The $P option forces a path search for each name, even if -T would not return file. If a command is hashed, -P and $P print the hashed value, which is not necessarily the file that appears first in path. If the -A option is used, type returns all of the places that contain an executable named file. This includes aliases and functions if and only if the -P option is not also used. If the -F option is used, type does not attempt to find shell functions, as with the command built in. The return status is 0 if all of the names are found, non-zero if any are not found. Typeset. The typeset command is supplied for compatibility with the corn shell. It is a synonym for the declare built-in command. ulimit. ulimit provides control over the resources available to processes started by the shell on systems that allow such control. If an option is given, it is interpreted as follows. $S. Change and report the soft limit associated with the resource. $H. Change and report the hard limit associated with the resource. -A. All current limits are reported. No limits are set. -B. The maximum socket buffer size. -C. The maximum size of core files created. -D. The maximum size of a process's data segment. -E. The maximum scheduling priority. -F. The maximum size of files written by the shell and its children. -I. The maximum number of pending signals. -K. The maximum number of K queues that may be allocated. -L. The maximum size that may be locked into memory. -M. The maximum resident set size. Many systems do not honor this limit. -N. The maximum number of open file descriptors. Most systems do not allow this value to be set. -P. The pipe buffer size. -Q. The maximum number of bytes in POSIX message queues. -R. The maximum real-time scheduling priority. -S. The maximum stack size. -T. The maximum amount of CPU time in seconds. -U. The maximum number of processes available to a single user. -V. The maximum amount of virtual memory available to the shell and, on some systems, to its children. -X. The maximum number of file locks. -P. The maximum number of pseudo terminals. -R. Uppercase. The maximum time a real-time process can run before blocking in microseconds. -T. The maximum number of threads. If limit is given and the -A option is not used, limit is the new value of the specified resource. The special limit values hard, soft, and unlimited stand for the current hard limit, the current soft limit, and no limit, respectively. A hard limit cannot be increased by a non-root user once it is set. A soft limit may be increased up to the value of the hard limit. Otherwise, the current value of the soft limit for the specified resource is printed, unless the uppercase H option is supplied. When more than one resource is specified, the limit, name, and unit, if appropriate, are printed before the value. When setting new limits, if neither $H nor $S is supplied, both the hard and soft limits are set. If no options are given, then -F is assumed. Values are in 1024 byte increments, except for -T, which is in seconds, $R, which is in microseconds, -P, which is in units of 512 byte blocks, $P, $T, $B, $K, $N, and $U, which are unscaled values, and, when in Posix mode, $C and $F, which are in 512 byte increments. The return status is 0 unless an invalid option or argument is supplied or an error occurs while setting a new limit. And finally, unalias, with an optional -A flag and an optional list of names. Remove each name from the list of aliases. If -A is supplied, all aliases are removed. 4.3.1, the set built-in. This built-in is so complicated that it deserves its own section. Set allows you to change the values of shell options and set the positional parameters, or to display the names and values of shell variables. You can call it with the A, B, E, F, H, K, M, N, P, T, U, V, X, uppercase B, uppercase C, uppercase E, uppercase H, uppercase P, uppercase T flags, and then an optional option name, either plus or minus, and then a dash dash, and another dash for some reason, and then a list of arguments. If no options or arguments are supplied, set displays the name and values of all shell variables and functions, sorted according to the current locale in a format that may be reused as input for setting or resetting the currently set variables. Read-only variables cannot be reset. In Posix mode, only shell variables are listed. When options are supplied, they set or unset shell attributes. Options, if specified, have the following meanings. -A. Each variable or function that is created or modified is given the export attribute and marked for export to the environment of subsequent commands. I can't speak anymore. -B. Cause the status of terminated background jobs to be reported immediately rather than before printing the next primary prompt. -E. Exit immediately if a pipeline, which may consist of a single simple command, a list, or a compound command, returns a non-zero exit status. The shell does not exit if the command that fails is part of the command list immediately following a while or until keyword, part of the test in an if statement, part of any command executed in a double ampersand or double pipe list except the command following the final double ampersand or double pipe, any command in a pipeline but the last, or if the command's return status is being inverted with exclamation mark. If a compound command other than a subshell returns a non-zero status because a command failed while -E was being ignored, the shell does not exit. A trap on error, if set, is executed before the shell exits. This option applies to the shell environment and each subshell environment separately and may cause subshells to exit before executing all of the commands in the subshell. If a compound command or shell function executes in a context where -E is being ignored, none of the commands executed within the compound command or function body will be affected by the -E setting, even if the -E set and a command returns a failure status. If a compound command or shell function sets -E while executing in a context where -E is ignored, that setting will not have any effect until the compound command or the command containing the function call completes. -F, disable Filename Expansion, globbing. -H, locate and remember hash commands as they are looked up for execution. This option is enabled by default. -K, all arguments in the form of assignment statements are placed in the environment for a command, not just those that precede the command name. -M, job control is enabled. All processes run in a separate process group. When a background job completes, the shell prints a line containing its exit status. -N, read commands but do not execute them. This may be used to check a script for syntax errors. This option is ignored by interactive shells. -O, option name. Set the option corresponding to option name. All export, same as -A. Brace expand, same as -B. Emacs. Use an Emacs style line editing interface. This also affects the editing interface used for read-E. Error exit, same as -E. Error trace, same as -E. Func trace, same as -T. Hash all, same as -H. Hist expand, same as -H. History enables command history as described in bash history facilities. This option is on by default in interactive shells. Ignore EOF. An interactive shell will not exit upon reading EOF. Keyword, same as -K. Monitor, same as -M. No clobber, same as -C. No exec, same as -n. No glob, same as -f. No log, currently ignored. Notify, same as -b. No unset, same as -u. One command, same as -t. Physical, same as -p. Pipe fail. If set, the return value of a pipeline is the value of the last rightmost command to exit with a non-zero status, or 0 if all commands in the pipeline exit successfully. This option is disabled by default. Posix. Change the behavior of bash where the default operation differs from the Posix standard to match the standard. See bash Posix mode. This is intended to make bash behave as a strict superset of the standard. Privileged, same as -p. Verbose, same as -v. VI, use a VI style line editing interface. This also affects the editing interface used for read-e. Xtrace, same as -x. -p, turn on privileged mode. In this mode, the bash env and env files are not processed, shell functions are not inherited from the environment, and the shell opts, bash opts, cd path, and glob ignore variables, if they appear in this environment, are ignored. If the shell is started with the effective user group ID not equal to the real user group ID, and the -p option is not supplied, these actions are taken and the effective user ID is set to the real user ID. If the -p option is supplied at startup, the effective user ID is not reset. Turning this option off causes the effective user and group IDs to be set to the real user and group IDs. -r, enable restricted shell mode. This option cannot be unset once it has been set. -t, exit after reading and executing one command. -u, treat unset variables and parameters other than the special parameters @ or star, or array variables subscripted with @ or star, as an error when performing parameter expansion. An error message will be written to the standard error, and a non-interactive shell will exit. -v, print shell input lines as they are read. -x, print a trace of simple commands, for commands, case commands, select commands, and arithmetic for commands, and their arguments or associated word lists after they are expanded and before they are executed. The value of the PS4 variable is expanded and the resultant value is printed before the command and its expected arguments. -B, the shell will perform brace expansion. This option is on by default. -C, prevent output redirection using greater than, ampersand, and less than greater than from overwriting existing files. -E, if set, any trap on error is inherited by shell functions, command substitutions, and commands executed in a subshell environment. The error trap is not normally inherited in such cases. -H, enable !style history substitution. This option is on by default for interactive shells. -P, if set, do not resolve symbolic links when performing commands such as cd, which change the current directory. The physical directory is used instead. By default, bash follows the logical chain of directories when performing commands which change the current directory. For example, if user sys is a symbolic link to user local sys, then cd user sys echo pwd will print user sys, whereas cd.pwd prints /user. And if set-p were on, then cd/user/sys echo pwd prints user local sys, and cd.pwd prints user local. -T, if set, any trap on debug and return are inherited by shell functions, command substitutions, and commands executed in a subshell environment. The debug and return traps are normally not inherited in such cases. --, If no arguments follow this option, then the positional parameters are unset. Otherwise, the positional parameters are set to the arguments, even if some of them begin with a dash. Dash. Signal the end of options, causing all remaining arguments to be assigned to the positional parameters. The -x and -v options are turned off. If there are no arguments, the positional parameters remain unchanged. Using plus rather than minus causes these options to be turned off. The options can also be used upon invocation of the shell. The current set of options may be found in $-. The remaining n arguments are positional parameters and are assigned in order to $1, $2, etc. The special parameter pound is set to n. The return status is always 0 unless an invalid option is supplied. 4.3.2, the shopped built-in. This built-in allows you to change additional shell optional behavior. Toggle the values of settings controlling optional shell behavior. The settings can be either those listed below, or if the -o option is used, those available with the -o option to the set built-in command. With no options, or with the -p option, a list of all set table options is displayed, with an indication of whether or not each is set. If opt names are supplied, the output is restricted to those options. The -p option causes output to be displayed in a form that may be reused as input. Other options have the following meanings. -s, enable, set each opt name. -u, disable, unset each opt name. -q, suppresses normal output. The return status indicates whether the opt name is set or unset. If multiple opt name arguments are given with -q, the return status is 0 if all opt names are enabled, non-zero otherwise. -o restricts the values of opt name to be those defined for the -o option to the set built-in. If either -s or -u is used with no opt name arguments, shopped shows only those options which are set or unset respectively. Unless otherwise noted, the shopped options are disabled off by default. The return status when listing options is 0 if all opt names are enabled, non-zero otherwise. When setting or unsetting options, the return status is 0 unless an opt name is not a valid shell option. The list of shopped options is asoc_expand_once. If set, the shell suppresses multiple evaluation of associative array subscripts during arithmetic expression evaluation, while executing built-ins that can perform variable assignments, and while executing built-ins that perform array dereferencing. Auto-CD. If set, a command name that is the name of a directory is executed as if it were the argument to the CD command. This option is only used by interactive shells. cdable_vars. If this is set, an argument to the cd built-in command that is not a directory is assumed to be the name of a variable whose value is the directory to change to. cdspell. If set, minor errors in the spelling of a directory component in a cd command will be auto-corrected. The errors checked for are transposed characters, a missing character, and a character too many. If a correction is found, the corrected path is printed, and the command proceeds. This option is only used by interactive shells. Check hash. If this is set, bash checks that a command found in the hash table exists before trying to execute it. If a hashed command no longer exists, a normal path search is performed. Check jobs. If set, bash lists the status of any stopped and running jobs before exiting an interactive shell. If any jobs are running, this causes the exit to be deferred until a second exit is attempted without an intervening command. The shell always postpones exiting if any jobs are stopped. Check win size. If set, bash checks the window size after each external non-built-in command. And, if necessary, updates the values of lines and columns. This option is enabled by default. Command hist. If set, bash attempts to save all lines of a multi-line command in the same history entry. This allows easy re-editing of multi-line commands. This option is enabled by default, but only has an effect if command history is enabled. Compat 31, Compat 32, Compat 40, Compat 41, Compat 42, Compat 43, Compat 44. These control aspects of the shell's compatibility mode. See Shell Compatibility Mode. Complete full quote. If set, bash quotes all shell meta characters in file names and directory names when performing completion. If not set, bash removes meta characters such as the $sign from the set of characters that will be quoted in complete file names when these meta characters appear in the shell variable references in words to be completed. This means that $signs in variable names that expand to directories will not be quoted. However, any $signs appearing in file names will not be quoted either. This is active only when bash is using backslashes to quote completed file names. This variable is set by default, which is the default bash behavior in versions through 4.2. Direxpand. If set, bash replaces directory names with the results of word expansion when performing file name completion. This changes the contents of the Readline editing buffer. If not set, bash attempts to preserve what the user typed. Dirspell. If set, bash attempts spelling correction on directory names during word completion if the directory name initially supplied does not exist. .glob. If set, bash includes file names beginning with a dot in the results of Filename Expansion. The file names dot and dot dot must always be matched explicitly, even if a .glob is set. Exec fail. If this is set, a non-interactive shell will not exit if it cannot execute the file specified as an argument to the exec built-in command. An interactive shell does not exit if exec fails. Expand_aliases. If set, aliases are expanded as described below under aliases. This option is enabled by default for interactive shells. EXTDebug. If set at shell invocation, or in a shell startup file, arrange to execute the debugger profile before the shell starts, identical to the --debugger option. If set after invocation, behavior intended for use by debuggers is enabled. 1. The -F option to the declare built-in displays the source file name and the line number corresponding to each function name supplied as an argument. 2. If the command run by the debug trap returns a non-zero value, the next command is skipped and not executed. 3. If the command run by the debug trap returns a value of 2, and the shell is executing in a subroutine, a shell function or a shell script executed by the dot or source built-ins, the shell simulates a call to return. 4. Bash argc and bash argv are updated as described in their descriptions. 5. Function tracing is enabled. Command substitution, shell functions, and subshells invoked with parentheses inherit the debug and return traps. 6. Error tracing is enabled. Command substitution, shell functions, and subshells invoked with parentheses inherit the error trap. EXTglob. If set, the extended pattern matching features described above are enabled. EXTquote. If set, $single quote string and $double quote string quoting is performed within $curly brace parameter expansions enclosed in double quotes. This option is enabled by default. Failglob. If set, patterns which fail to match file names during Filename Expansion result in an expansion error. Force_fignore. If set, the suffixes specified by the fignore shell variable cause words to be ignored when performing word completion, even if the ignored words are the only possible completions. See bash variables for a description of fignore. This option is enabled by default. Glob ASCII ranges. If set, range expressions used in pattern matching bracket expressions behave as if in the traditional C locale when performing comparisons. That is, the current locale's collating sequence is not taken into account, so B will not collate between capital A and capital B, and uppercase and lowercase ASCII characters will collate together. Glob skip dots. If set, Filename Expansion will never match the file names dot and dot dot, even if the pattern begins with a dot. This option is enabled by default. Glob star. If set, the pattern star star used in a Filename Expansion context will match all files and 0 or more directories and subdirectories. If the pattern is followed by a slash, only directories and subdirectories match. GNU_error format. If set, shell error messages are written in the standard GNU error message format. Hist append. If set, the history list is appended to the file named by the value of the hist file variable when the shell exits, rather than overwriting the file. Hist re-edit. If set and readline is being used, a user is given the opportunity to re-edit a failed history substitution. Hist verify. If set and readline is being used, the results of history substitution are not immediately passed to the shell parser. Instead, the resulting line is loaded into the Readline Editing buffer, allowing further modification. Host complete. If set and the readline is being used, Bash will attempt to perform hostname completion when a word containing an @ symbol is being completed. See letting readline type for you. This option is enabled by default. Hup on exit. If set, Bash will send sig hup to all jobs when an interactive login shell exits. Inherit_error exit. If set, command substitution inherits the value of the error exit option instead of unsetting it in the subshell environment. This option is enabled when Posix Mode is enabled. Interactive_comments. Allow a word beginning with pound to cause that word and all remaining characters on that line to be ignored in an interactive shell. This option is enabled by default. Last pipe. If set and job control is not active, the shell runs the last command of a pipeline not executed in the background in the current shell environment. Lit hist. If enabled and the command hist option is enabled, multi-line commands are saved to the history with embedded new lines rather than using semicolon separators where possible. Local var_inherit. If set, local variables inherit the value and attributes of a variable of the same name that exists at a previous scope before any new value is assigned. The nameref attribute is not inherited. Local var_unset. If set, calling unset on local variables in previous function scopes marks them so subsequent lookups find them unset until that function returns. This is identical to the behavior of unsetting local variables at the current function scope. Login_shell. The shell sets this option if it is started as a login shell. The value may not be changed. Mail warn. If set and a file that Bash is checking for mail has been accessed since the last time it was checked, the message, "The mail in mail file has been read," is displayed. No_empty_command_completion. If set and readline is being used, Bash will not attempt to search the path for possible completions when completion is attempted on an empty line. No case glob. If set, Bash matches file names in a case-insensitive fashion when performing Filename Expansion. No case match. If set, Bash matches patterns in a case-insensitive fashion when performing matches while executing a case or double open square bracket conditional commands when performing pattern substitution word expansions, or when filtering possible completions as part of programmable completion. No expand_translation. If set, Bash encloses the translated results of $ double quotes quoting into in single quotes instead of double quotes. If the string is not translated, this has no effect. Null glob. If set, bash allows file name patterns which match no files to expand to a null string rather than themselves. Patsub underscore replacement. If set, bash expands occurrences of ampersand in the replacement string of pattern substitution to the text matched by the pattern, as described above. This option is enabled by default. Progcomp. If set, the programmable completion facilities are enabled. This option is enabled by default. Progcomp underscore alias. If set and programmable completion is enabled, bash treats a command name that doesn't have any completions as a possible alias and attempts alias expansion. If it has an alias, bash attempts programmable completion using the command word resulting from the expanded alias. Prompt vars. If set, prompt strings undergo parameter expansion, command substitution, arithmetic expansion, and quote removal after being expanded as described below. This option is enabled by default. Restricted underscore shell. The shell sets this option if it is started in a restricted mode. This value may not be changed. This is not reset when the startup files are executed, allowing the startup files to discover whether or not a shell is restricted. Shift underscore verbose. If this is set, the shift built-in prints an error message when the shift count exceeds the number of positional parameters. Source path. If set, the dot source built-in uses the value of path to find the directory containing the file supplied as an argument. This option is enabled by default. Var reader underscore close. If set, the shell automatically closes file descriptors assigned using the var name redirection syntax instead of leaving them open when the command completes. XPG underscore echo. If set, the echo built-in expands / escape sequences by default. 4.4 Special built-ins. For historical reasons, the Posix standard has classified several built-in commands as special. When bash is executing in Posix mode, the special built-ins differ from the other built-in commands in 3 respects. 1. Special built-ins are found before shell functions during command lookup. 2. If a special built-in returns an error status, a non-interactive shell exits. 3. Assignment statements preceding the command stay in effect in the shell environment after the command completes. When bash is not executing in Posix mode, these built-in commands behave no differently than the rest of the bash built-in commands. The bash Posix mode is described in bash Posix mode. These are the Posix special built-ins: break, dot, continue, eval, exec, exit, export, read only, return, set, shift, trap, and unset. Chapter 5, Shell Variables. This chapter describes the shell variables that bash uses. Bash automatically assigns default values to a number of variables. 5.1 Bourne shell variables. Bash uses certain shell variables in the same way as the Bourne shell. In some cases, bash assigns a default value to the variable. CD path. A colon-separated list of directories used as a search path for the CD built-in command. Home. The current user's home directory, the default for the CD built-in command. The value of this variable is also used by tilde expansion. IFS. A list of characters that separate fields, used when the shell splits words as part of expansion. Mail. If this parameter is set to a file name or directory name, and the mail path variable is not set, bash informs the user of the arrival of mail in the specified file or maildir format directory. Mail path. A colon-separated list of file names, which the shell periodically checks for new mail. Each list entry can specify the message that is printed when a new mail arrives in the mail file by separating the file name from the message with a question mark. When used in the text of the message, $_ expands to the name of the current mail file. Optarg. The value of the last option argument processed by the getups built-in. Opt-ind. The index of the last option argument processed by the getups built-in. Path. A colon-separated list of directories in which the shell looks for commands. A zero-length null directory name in the value of path indicates the current directory. A null directory name may appear as two adjacent colons or as an initial or trailing colon. PS1, the primary prompt string. The default value is \s-v $. See controlling the prompt for the complete list of escape sequences that are expanded before PS1 is displayed. PS2, the secondary prompt string. The default value is >space. PS2 is expanded in the same way as PS1 before being displayed. 5.2 Bash variables. These variables are set or used by Bash, but other shells do not normally treat them specially. A few variables used by Bash are described in different chapters. Variables for controlling the job control facilities. Underscore. $_ at shell startup set to the path name used to invoke the shell or shell script being executed as passed in the environment or argument list. Subsequently, expands to the last argument to the previous simple command executed in the foreground after expansion. Also set to the full path name used to invoke each command executed and placed in the environment exported to that command. When checking mail, this parameter holds the name of the mail file. Bash, the full path name used to execute the current instance of Bash. Bash opts, a colon-separated list of enabled shell options. Each word in the list is a valid argument for the -s option to the shopped built-in command. The options appearing in bash opts are those reported as on by shopped. If this variable is in the environment when bash starts up, each shell option in the list will be enabled before reading any startup files. This variable is read only. Bash PID expands to the process ID of the current bash process. This differs from $$ under certain circumstances, such as subshells that do not require bash to be reinitialized. Assignment to bash PID has no effect. If bash PID is unset, it loses its special properties, even if it's subsequently reset. Bash aliases, an associative array variable whose members correspond to the internal list of aliases maintained by the alias built-in. Elements added to this array appear in the alias list. However, unsetting array elements currently does not cause aliases to be removed from the alias list. If bash aliases is unset, it loses its special properties, even if it is subsequently reset. Bash argc, an array variable whose values are the number of parameters in each frame of the current bash execution call stack. The number of parameters to the current subroutine, shell function, or script executed with dot or source is at the top of the stack. When a subroutine is executed, the number of parameters passed is pushed onto bash argc. The shell sets bash argc only when in extended debugging mode. Setting extdebug after the shell has started to execute a script, or referencing this variable when extdebug is not set, may result in inconsistent values. Bash argv, an array variable containing all of the parameters in the current bash execution call stack. The final parameters of the last subroutine call is at the top of the stack. The first parameter of the initial call is at the bottom. When a subroutine is called, the parameters supplied are pushed onto bash argv. The shell sets bash argv only when in extended debugging mode. Setting extdebug after the shell is started to execute a script, or referencing this variable when extdebug is not set, may result in inconsistent values. Bash argv0. When referenced, this variable expands to the name of the shell or shell script, identical to $0. See special parameters for the description of special parameter 0. Assignment to bash argv0 causes the value assigned to also be assigned to $0. If bash argv0 is unset, it loses its special properties, even if it is subsequently reset. Bash commands, An associative array variable whose members correspond to the internal hash table of commands as maintained by the hash built in. Elements added to this array appear in the hash table. However, unsetting array elements currently does not cause command names to be removed from the hash table. If bash commands is unset, it loses its special properties even if it is subsequently reset. Bash command. The command currently being executed or about to be executed unless the shell is executing a command as the result of a trap, in which case it is the command executing at the time of the trap. If bash command is unset, it loses its special properties even if it is subsequently reset. Bash compat. The value is used to set the shell's compatibility level. See Shell Compatibility Mode for a description of the various compatibility levels and their effects. The values may be a decimal number, for example 4.2, or an integer, for example 42, corresponding to the desired compatibility level. If bash compat is unset or set to the empty string, the compatibility level is set to the default for the current version. If bash compat is set to a value that is not one of the valid compatibility levels, the shell prints an error message and sets the compatibility level to the default for the current version. The valid values correspond to the compatibility levels described below. For example, 4.2 and 42 are valid values that correspond to the compat 42 shopped option and set the compatibility level to 42. The current version is also a valid value. Bash env. If this variable is set when bash is invoked to execute a shell script, its value is expanded and used as the name of the startup file to read before executing the script. See bash startup files. Bash execution string, the command argument to the -c invocation option. Bash line number, an array variable whose members are the line numbers in source files where each corresponding member of funcname was invoked. Bash line no subscript I is the line number in the source file bash source I plus 1 where funcname I was called, or bash line number I minus 1 if referenced within another shell function. Use line no to obtain the current line number. Bash loadables path, a colon-separated list of directories in which the shell looks for dynamically loadable built-ins specified by the enable command. Bash rematch, an array variable whose members are assigned by the =tilde binary operator to the double square bracket conditional command. The element with index 0 is the portion of the string matching the entire regular expression. The element with index n is the portion of the string matching the nth parenthesized subexpression. Bash source, an array variable whose members are the source file names where the corresponding shell function names in the funcname array variable are defined. The shell function funcname I is defined in the file bash source I and is called from bash source I plus 1. Bash subshell, incremented by 1 within each subshell or subshell environment when the shell begins executing in that environment. The initial value is 0. If bash subshell is unset, it loses its special properties even if it is subsequently reset. Bash versinfo, a read-only array variable whose members hold information for this instance of bash. The values assigned to the array are as follows. Index 0, the major version number. Index 1, the minor version number. Index 2, the patch level. Index 3, the build version. Index 4, the release status. Index 5, the value of mock type. Bash version, the version number of the current instance of bash. Bash xtracefd. If set to an integer corresponding to a valid file descriptor, bash will write the trace output generated when set-x is enabled to that file descriptor. This allows tracing output to be separated from diagnostic and error messages. The file descriptor is closed when bash xtracefd is unset or assigned to a new value. Unsetting bash xtracefd or assigning it the empty string causes the trace output to be sent to standard error. Note that setting bash xtracefd to 2, standard error file descriptor, and then unsetting it will result in the standard error being closed. Child max. Set the number of exited child status values for the shell to remember. Bash will not allow this value to be decreased below a POSIX mandated minimum, and there is a maximum value, currently 8,192, that this may not exceed. The minimum value is system dependent. Columns. Used by the select command to determine the terminal width when printing selection lists. Automatically set if the check win size option is enabled, or in an interactive shell upon receipt of sigwinch. Comp cword. An index into comp words of the word containing the current cursor position. This variable is available only in shell functions invoked by the Programmable Completion facilities. Comp line, the current command line. This variable is available only in shell functions and external commands invoked by the Programmable Completion facilities. Comp point, the index of the current cursor position relative to the beginning of the current command. If the current cursor position is the end of the current command, the value of this variable is equal to £comp line. This variable is available only in shell functions and external commands invoked by the Programmable Completion facilities. Comp type, set to an integer value corresponding to the type of completion attempted that caused a completion function to be called. Tab for normal completion, question mark for listing completions after successive tabs, exclamation mark for listing alternatives on partial word completion, @ symbol to list completions if the word is not unmodified, or % for menu completion. This variable is only available in shell functions and external commands invoked by the Programmable Completion facilities. Comp key, the key or final key of a key sequence used to invoke the current completion function. Comp word breaks, the set of characters that the Readline library treats as a word separator when performing word completion. If comp word breaks is unset, it loses its special properties even if it is subsequently reset. Comp words, an array variable consisting of the individual words in the current command line. The line is split into words as Readline would split it, using comp word breaks as described above. This variable is available only in shell functions invoked by the Programmable Completion facilities. Comp reply, an array variable from which bash reads the possible completions generated by a shell function invoked by the Programmable Completion facility. Each array element contains one possible completion. Co-proc, an array variable created to hold the file descriptors for output from and input to an unnamed coprocess. Dir stack, an array variable containing the current contents of the directory stack. Directories appear in the stack in the order that they are displayed in the dirs built-in. Assigning to members of this array variable may be used to modify directories already in the stack, but the pushd and popd built-ins must be used to add and remove directories. Assignment to this variable will not change the current directory. If dir stack is unset, it loses its special properties even if it is subsequently reset. Emax. If bash finds this variable in the environment when the shell starts with value t, it assumes that the shell is running in an Emax buffer and disables line editing. env, expanded and executed similarly to bash env when an interactive shell is invoked in Posix mode. Epic real-time. Each time this parameter is referenced, it expands to the number of seconds since the Unix epoch has a floating point value with microsecond granularity. Assignment to epic real-time are ignored. If epic real-time is unset, it loses its special properties even if it is subsequently reset. Epic seconds. Each time this parameter is referenced, it expands to the number of seconds since the Unix epoch. See the documentation for the C library function time for the definitions of epoch. Assignments to epic seconds are ignored. If epic seconds is unset, it loses its special properties even if it is subsequently reset. EUID, the numeric effective user ID of the current user. This variable is read-only. Exec_ignore, a colon-separated list of shell patterns defining the list of file names to be ignored by command search using path. Files whose full path name match one of these patterns and are not considered executable files for the purpose of completion and command execution via path lookup. This does not affect the behavior of the square bracket, test, and double square bracket commands. Full path names in the command hash table are not subject to exec_ignore. Use this variable to ignore shared library files that have the executable bit set but are not executable files. The pattern matching honors the setting of the ext_glob shell option. fcedit, the editor used as a default by the -e option to the fc built-in command. fignore, a colon-separated list of suffixes to ignore when performing file name completion. A file name whose suffix matches one of the entries in fignore is excluded from the list of matched file names. A sample value is .o:\tilde. Funcname, an array variable containing the names of all shell functions currently in the execution call stack. The element with index 0 is the name of any currently executing shell function. The bottommost element, the one with the highest index, is main. This variable exists only when a shell function is executing. Assignments to funcname have no effect. If funcname is unset, it loses its special properties, even if it is subsequently reset. This variable can be used with bash line note and bash source. Each element of funcname has corresponding elements in bash line note and bash source to describe the call stack. For instance, funcname I was called from the file bash source i+1 at line number bash line note I. The caller built-in displays the current call stack using this information. Funcnest, if set to a numeric value greater than 0, defines a maximum function nesting level. Function invocations that exceed this nesting level will cause the current command to abort. Glob_ignore, a colon-separated list of patterns defining the set of file names to be ignored by Filename Expansion. If a file name matched by a Filename Expansion pattern also matches one of the patterns in glob_ignore, it is removed from the list of matches. The pattern matching honors the setting of the ext_glob shell option. Groups, an array variable containing the list of groups of which the current user is a member. Assignment to groups have no effect. If groups is unset, it loses its special properties even if it is subsequently reset. Histchars, lowercase. Up to 3 characters which control history expansion, quick substitution, and tokenization. The first character is the history expansion character. That is, the character which signifies the start of a history expansion, normally exclamation mark. The second character is the character which signifies quick substitution when seen as the first character on a line, normally caret. The optional third character is the character which indicates that the remainder of the line is a comment when found as the first character of a word, usually pound. The history comment character causes history substitution to be skipped for the remaining words on the line. It does not necessarily cause the shell parser to treat the rest of the line as a comment. Hist command, the history number or index in the history list of the current command. Assignments to the hist command are ignored. If hist command is unset, it loses its special properties even if it is subsequently reset. Hist control, a colon-separated list of values controlling how commands are saved on the history list. If the list of values includes ignore space, lines which begin with a space character are not saved in the history list. A value of ignore dupes causes lines which match the previous history entry to not be saved. A value of ignore both is shorthand for ignore space and ignore dupes. A value of erase dupes causes all previous lines matching the current line to be removed from the history list before that line is saved. Any value not in the above list is ignored. If hist control is unset or does not include a valid value, all lines read by the shell parser are saved on the history list, subject to the value of histignore. The second and subsequent lines of a multi-line compound command are not tested and are added to the history regardless of the value of hist control. Hist file. The name of the file to which the command history is saved. The default value is ~bash_history. Hist file size. The maximum number of lines contained in the history file. When this variable is assigned a value, the history file is truncated, if necessary, to contain no more than the number of lines by removing the oldest entries. The history file is also truncated to this size after writing it when a shell exits. If the value is 0, the history file is truncated to 0 size. Non-numeric values and numeric values less than 0 inhibit truncation. The shell sets the default value to the value of hist size after reading any startup files. Histignore, a colon-separated list of patterns used to decide which command line should be saved on the history list. Each pattern is anchored at the beginning of the line and must match the complete line. No implicit star is appended. Each pattern is tested against the line after the checks specified by hist control are applied. In addition to the normal shell pattern matching, ampersand matches the previous history line. Ampersand may be escaped using a backslash. The backslash is removed before attempting a match. The second and subsequent lines of a multi-line compound command are not tested and are added to the history regardless of the value of histignore. The pattern matching honors the setting of the ext-glob shell option. Histignore subsumes the function of hist control. A pattern of ampersand is identical to ignore dupes, and a pattern of square brackets space star is identical to ignore space. Combining these two patterns, separating them with a colon, provides the functionality of ignore both. Hist size, the maximum number of commands to remember on the history list. If the value is 0, commands are not saved in the history list. Numeric values less than 0 result in every command being saved on the history list. There is no limit. The shell sets the default value to 500 after reading any startup files. Hist time format. If this variable is set and not null, its value is used as a format string for stirf time to print the timestamp associated with each history entry displayed by the history built-in. If this variable is set, timestamps are written to the history file so they may be preserved across shell sessions. This uses the history comment character to distinguish timestamps from other history lines. Host file contains the name of a file in the same format as etc hosts that should be read when the shell needs to complete a hostname. The list of possible hostname completions may be changed while the shell is running. The next time hostname completion is attempted after the value is changed, bash adds the contents of the new file to the existing list. If host file is set but has no value or does not name a readable file, bash attempts to read etc hosts to obtain the list of possible hostname completions. When host file is unset, the hostname list is cleared. Host name, the name of the current host. Host type, a string describing the machine bash is running on. Ignore EOF controls the action of the shell on receipt of an EOF character as the sole input. If set, the value denotes the number of consecutive EOF characters that can be read as the first character on an input line before the shell will exit. If the variable exists but does not have a numeric value or has no value, then the default is 10. If the variable does not exist, then EOF signifies the end of input to the shell. This is only in effect for interactive shells. Input RC, the name of the readline initialization file overriding the default of ~/.inputrc. Inside Emacs, if bash finds this variable in the environment when the shell starts, it assumes that the shell is running in an Emacs shell buffer and may disable line editing depending on the value of term. Lang, used to determine the locale category for any category not specifically selected with a variable starting with LC. LC all. This variable overrides the value of lang and any other LC underscore variable specifying a locale category. LC collate. This variable determines the collation order used when sorting the results Filename Expansion and determines the behavior of range expressions, equivalence classes, and collating sequences within Filename Expansion and pattern matching. LCC type. This variable determines the interpretation of characters and the behavior of character classes within Filename Expansion and pattern matching. LC messages. This variable determines the locale used to translate double-quoted strings preceded by a $sign. LC numeric. This variable determines the locale category used for number formatting. LC time. This variable determines the locale category for data and time formatting. Line no. The line number in the script or shell function currently executing. If line no is unset, it loses its special properties, even if it is subsequently reset. Lines. Used by the select command to determine the column length for printing selection lists. Automatically set if the check win size option is enabled, or in an interactive shell upon receipt of SIGWinch. Mock type. A string that fully describes the system type on which bash is executing in the standard GNU CPU-company-system format. Mail check. How often in seconds that the shell should check for mail in the files specified in the mail path or mail variables. The default is 60 seconds. When it is time to check for mail, the shell does so before displaying the primary prompt. If this variable is unset or set to a value that is not a number greater than or equal to 0, the shell disables mail checking. Map file. An array variable created to hold the text read by the map file built in when no variable name is supplied. Old PWD. The previous working directory as set by the CD built-in. Opt error. If set to the value 1, bash displays error messages generated by the getops built-in command. OS type. A string describing the operating system bash is running on. Pipe status. An array variable containing a list of exit status values from the process in the most recently executed foreground pipeline, which may contain only a single command. Posixly correct. If this variable is in the environment when bash starts, the shell enters Posix mode before reading the startup files as if the --posix invocation option had been supplied. If it is set while the shell is running, bash enables Posix mode as if the command set-o posix had been executed. When the shell enters Posix mode, it sets this variable if it was not already set. PPID. The process ID of the shell's parent process. This variable is read-only. Prompt command. If this variable is set and is an array, the value of each set element is interpreted as a command to execute before printing the primary prompt PS1. If this is set but not an array variable, its value is used as a command to execute instead. Prompt dir trim. If set to a number greater than 0, the value is used as the number of trailing directory components to retain when expanding the \w and \uppercase W prompt string escapes. Characters removed are replaced with an ellipses. PS0. The value of this parameter is expanded like PS1 and displayed by interactive shells after reading a command and before the command is executed. PS3. The value of this variable is used as the prompt for the select command. If this variable is not set, the select command prompts with !space. PS4. The value of this parameter is expanded like PS1, and the expanded value is the prompt printed before the command line is echoed when the -x option is set. The first character of the expanded value is replicated multiple times as necessary to indicate multiple levels of indirection. The default is +space. PWD. The current working directory as set by the CD built-in. Random. Each time this parameter is referenced, it expands to a random integer between 0 and 32,767. Assigning a value to this variable seeds the random number generator. If random is unset, it loses its special properties even if it is subsequently reset. Readline argument. Any numeric argument given to a readline command that was defined using bind-x when it was invoked. Readline line. The contents of the readline line buffer for use with bind-x. Readline mark. The position of the mark in the readline line buffer for use with bind-x. The characters between the insertion point and the mark are often called the region. Readline point. The position of the insertion point in the readline line buffer for use with bind-x. Reply. The default variable for the read built-in. Seconds. This variable expands to the number of seconds since the shell was started. Assignment to this variable resets the count to the value assigned, and the expanded value becomes the value assigned plus the number of seconds since the assignment. The number of seconds at the shell invocation and the current time are always determined by querying the system clock. If seconds is unset, it loses its special properties, even if it is subsequently reset. Shell. This environment variable expands to the full path name to the shell. If it is not set when the shell starts, bash assigns it to the full path name of the current user's login shell. Shell opts. A colon-separated list of enabled shell options. Each word in the list is a valid argument for the -o option to the set built-in command. The option appearing in shell ops are those reported as on by set-o. If this variable is in the environment when bash starts up, each shell option in the list will be enabled before reading any startup files. This variable is read-only. SHLVL, incremented by 1 each time a new instance of bash is started. This is intended to be a count of how deeply your bash shells are nested. srandom. This variable expands to a 32-bit pseudo-random number each time it is referenced. The random number generator is not linear on systems that support dev-urandom or arc4random, so each returned number has no relationship to the numbers preceding it. The random number generator cannot be seeded, so assignments to this variable have no effect. If srandom is unset, say it with me chat, it loses its special properties even if it is subsequently reset. Time format. The value of this parameter is used as a format string specifying how timing information for pipelines prefixed with the time reserved word should be displayed. The % character introduces an escape sequence that is expanded to a time value or other information. The escape sequences and their meanings are as follows. The braces denote optional portions. %%, a literal %. % optional P, optional L, uppercase R, the elapsed time in seconds. Percent uppercase U, the number of seconds, the number of CPU seconds spent in user mode. Percent uppercase S, the number of CPU seconds spent in system mode. Percent uppercase P, the CPU percentage computed as percent uppercase U plus percent uppercase S divided by percent R. The optional P is a digit specifying the precision, the number of fractional digits after a decimal point. A value of 0 causes no decimal point or fraction to be output. At most, 3 places after the decimal point may be specified. Values of P greater than 3 are changed to 3. If P is not specified, the value 3 is used. The optional L specifies a longer format, including minutes of the form minutes, seconds, fractional seconds. The value of P determines whether or not the fraction is included. If this variable is not set, bash acts as if it had the value dollar single quote \n real \t %3 L uppercase R \n user \t %3 L uppercase U \n sys \t %3 L uppercase S single quote. If the value is null, no timing information is displayed. A trailing new line is added when the format string is displayed. Tmout. If set to a value greater than 0, tmout is treated as the default timeout for the read built-in. This select command terminates if input does not arrive after tmout seconds when input is coming from a terminal. In an interactive shell, the value is interpreted as the number of seconds to wait for a line of input after issuing the primary prompt. Bash terminates after waiting for that number of seconds if a complete line of input does not arrive. Tempter. If set, bash uses its value as the name of a directory in which bash creates temporary files for the shell's use. UID. The numeric real user ID of the current user. This variable is read-only. Chapter 6. Bash features. This chapter describes features unique to bash. 6.1. Invoking bash. All of the single character options used with the set built-in can be used as options when the shell is invoked. In addition, there are several multi-character options you can use. These options must appear on the command line before the single character options to be recognized. --debugger. Arrange for the debugger profile to be executed before the shell starts. Turns on extended debugging mode. --dump-po-strings. A list of all double-quoted strings preceded by $ is printed on the standard output in the GNU getText.po portable object file format, equivalent to -d except for the output format. --dump-strings, equivalent to $D. --help. Displays a usage message on standard output and exits successfully. --init filename or --rc filename execute commands from filename instead of ~/-bashrc in an interactive shell. --login equivalent to -l. --no editing. Do not use the GNU Readline library to read command lines when the shell is interactive. --no profile. Don't load the system-wide startup file, etc profile, or any of the personal initialization files ~/.bash_profile, ~/.bash_login, or ~/.profile when bash is invoked as a login shell. --no-rc. Don't read the ~/.bashrc initialization file in an interactive shell. This is on by default if the shell is invoked as sh. --Posix. Change the behavior of bash where the default operation differs from the Posix standard to match the standard. This is intended to make bash behave as a strict superset of that standard. See bash Posix mode for a description of the bash Posix mode. --restricted. Make the shell a restricted shell. --verbose. Equivalent to -v. Print shell input lines as they're read. --version. Show version information for this instance of bash on the standard output and exit successfully. There are several single character options that may be supplied at invocation which are not available with the set built-in. -c. Read and execute commands from the first non-option argument command_string, then exit. If there are arguments after the command_string, the first argument is assigned to $0 and any remaining arguments are assigned to the positional parameters. The assignment to $0 sets the name of the shell, which is used in warning and error messages. -i. Force the shell to run interactively. Interactive shells are described in interactive shells. -L. Make this shell act as if it had been directly invoked by login. When the shell is interactive, this is equivalent to starting a login shell with exec-l bash. When the shell is not interactive, the login shell startup files will be executed. Exec bash-l or exec bash-login will replace the current shell with a bash login shell. See bash startup files for a description of the special behavior of a login shell. -R. Make the shell a restricted shell. -S. If the option is present or if no arguments remain after option processing, then commands are read from the standard input. This option allows the positional parameters to be set when invoking an interactive shell or when reading input through a pipe. -D. A list of all double-quoted strings preceded by $ is printed on the standard output. These are strings that are subject to language translation when the current locale is not C or POSIX. This implies the -N option. No command will be executed. Shopped option is one of the shell options accepted by the shopped built-in. If shopped option is present, -O sets the value of that option, +O unsets it. If shopped option is not supplied, the names and values of the shell option accepted by the shopped are printed on the standard output. If the invocation option is +O, the output is displayed in a format that may be reused as input. -. A -- signals the end of options and disables further option processing. Any arguments after the -- are treated as file names and arguments. A login shell is one whose first character of argument 0 is dash, or one invoked with the -- login option. An interactive shell is one started without non-option arguments, unless -S is specified, without specifying the -C option, and whose input and output are both connected to terminals, as determined by isatty3, or one started with the -I option. If arguments remain after option processing, and neither the -C nor the -S option has been supplied, the first argument is assumed to be the name of a file containing shell commands. When bash is invoked in this fashion, $0 is set to the name of the file, and the positional parameters are set to the remaining arguments. Bash reads and executes commands from this file, then exits. Bash's exit status is the exit status of the last command executed in the script. If no commands are exited, the exit status is 0. 6.2 Bash Startup Files. This section describes how Bash executes its startup files. If any of the files exist but cannot be read, Bash reports an error. Tildes are expanded in file names as described above under tilde expansion. When Bash is invoked as an interactive login shell or as a non-interactive shell with the -- login option, it first reads and executes commands from the file etc profile, if that file exists. After reading that file, it looks for the ~/.bash profile, ~/.bash_login, and ~/.profile in that order, and reads and executes commands from the first one that exists and is readable. The -- no profile option may be used when the shell is started to inhibit this behavior. When an interactive login shell exits, or a non-interactive login shell executes the exit built-in command, Bash reads and executes commands from the file bash_logout if it exists. Invoked as an interactive non-login shell. When an interactive shell that is not a login shell is started, Bash reads and executes commands from .bashrc if that file exists. This may be inhibited by using the --no_rc option. The --rc file option will force Bash to read and execute commands from file instead of .bashrc. So typically your .bash_profile contains the line if open square bracket -f ~bashrc space close square bracket semicolon then ~bashrc semicolon phi. after or before any login specific initializations. When bash is started non-interactively to run a shell script, for example, it looks for the variable bash env in the environment, expands its value if it appears there, and uses the expanded value as the name of a file to read and execute. Bash behaves as if the following command were executed. If -n bash env, then source bash env phi. But the value of the path variable is not used to search for the file name. As noted above, if a non-interactive shell is invoked with the --login option, bash attempts to read and execute commands from the login shell startup files. If bash is invoked with the name sh, it tries to mimic the startup behavior of historical versions of sh as closely as possible, while conforming to the POSIX standard as well. When invoked as an interactive login shell or as a non-interactive shell with the --login command, it first attempts to read and execute commands from etc profile and .profile, in that order. The --no profile option may be used to inhibit this behavior. When invoked as an interactive shell with the name sh, bash looks for the variable env, expands its value if it's defined, and uses the expanded value as the name of a file to read and execute. Since a shell invoked as sh does not attempt to read and execute commands from any other startup files, the --rc file option has no effect. A non-interactive shell invoked with the name sh does not attempt to read any other startup files. When invoked as sh, bash enters Posix mode after the startup files are read. When bash is started in Posix mode, as with the --posix command line option, it follows the Posix standard for startup files. In this mode, interactive shells expand the env variable and commands are read and executed from the file whose name is the expanded value. No other startup files are read. Invoked by remote shell daemon. Bash attempts to determine when it is being run with its standard input connected to a network connection, as when executed by the historical remote shell daemon, usually rshd, or the secure shell daemon sshd. If bash determines it is being run non-interactively in this fashion, it reads and executes commands from .bashrc if that file exists and is readable. It will not do this if invoked as sh. The --no-rc option may be used to inhibit this behavior, and the --rc file option may be used to force another file to be read, but neither rshd nor sshd generally invoke the shell with those options or allow them to be specified. Invoked with unequal effective and real UID GIDs. If bash is started with the effective user group ID not equal to the real user group ID, and the -p option is not supplied, no startup files are read, shell functions are not inherited from the environment, and shell opts, bash opts, cd path, and glob ignore variables, if they appear in the environment, are ignored, and the effective user ID is set to the real user ID. If the -p option is supplied at invocation, startup behavior is the same, but the effective user ID is not reset. 6.3 Interactive Shells. 6.3.1 What is an interactive shell? An interactive shell is one started with non-option arguments, unless -s is specified, and without specifying the -c option, whose input and error output are both connected to terminals, or one started with the -i option. An interactive shell generally reads from and writes to a user's terminal. The -s invocation option may be used to set the positional parameters when an interactive shell is started. 6.3.2 Is this shell interactive? To determine within a startup script whether or not bash is running interactively, test the value of the -special parameter. It contains I when the shell is interactive. For example, case $- in anything matching I, echo this shell is interactive. Otherwise, echo this shell is not interactive. ESAC. Alternatively, startup scripts may examine the variable ps1. It is unset in non-interactive shells and set in interactive shells. Thus, if -z ps1, then echo this shell is not interactive, else echo this shell is interactive, phi. 6.3.3 Interactive Shell Behavior. When the shell is running interactively, it changes its behavior in several ways. 1. Startup files are read and executed as described in bash startup files. 2. Job control is enabled by default. When job control is in effect, bash ignores the keyboard-generated job control signals sigttin, sigttau, and sigtstop. 3. Bash expands and displays PS1 before reading the first line of a command, and expands and displays PS2 before reading the second and subsequent lines of a multi-line command. Bash expands and displays PS0 after it reads a command but before executing it. See Controlling the Prompt for a complete list of prompt string escape sequences. 4. Bash executes the values of the set elements of the prompt command array variable as commands before printing the primary prompt, PS1. 5. Readline is used to read commands from the user's terminal. 6. Bash inspects the value of the ignore EOF option to set -O instead of exiting immediately when it receives an EOF on its standard input when reading a command. 7. Command history and history expansion are enabled by default. Bash will save the command history to a file named histfile when a shell with a history enabled exits. 8. Alias expansion is performed by default. 9. In the absence of any traps, bash ignores sigterm. 10. In the absence of any traps, sigint is caught and handled. Sigint will interrupt some shell built-ins. 11. An interactive login shell sends a sighup to all jobs on exit if the hup on exit shell option has been enabled. 12. The -n invocation option is ignored, and set -n has no effect. 13. Bash will check for mail periodically, depending on the values of mail, mailpath, and mailcheck shell variables. 14. Expansion errors due to references to unbound shell variables after set-u has been enabled will not cause the shell to exit. 15. The shell will not exit on expansion errors caused by var being unset or null in var:*word expansions. 16. Redirection errors encountered by shell built-ins will not cause the shell to exit. 17. When running in Posix mode, a special built-in returning an error status will not cause the shell to exit. 18. A failed exec will not cause the shell to exit. 19. Parser syntax errors will not cause the shell to exit. 20. If the cd spell shell option is enabled, the shell will attempt simple spelling correction for directory arguments to the cd built-in. The cd spell option is only effective in interactive shells. 21. The shell will check the value of the tmout variable and exit if a command is not read within the specified number of seconds after printing PS1. 6.4. Bash Conditional Expressions. Conditional expressions are used by the double square bracket compound command and the test and single square bracket built-in commands. The test and single square bracket commands determine their behavior based on the number of arguments. See the descriptions of those commands for any other command-specific actions. Expressions may be unary or binary and are formed from the following primaries. Unary expressions are often used to examine the status of a file. There are string operators and numeric comparison operators as well. Bash handles several file names specially when they are used in expressions. If the operating system on which Bash is running provides these special files, Bash will use them. Otherwise, it will emulate them internally with this behavior. If the file argument to one of the primaries is of the form devfd_n, then file descriptor n is checked. If the file argument to one of the primaries is one of devstandardin, devstandardout, or devstandardair, file descriptor 0, 1, or 2 respectively is checked. When used with the double square brackets, the less than and greater than operators sort lexicographically using the current locale. The test command uses ASCII ordering. Unless otherwise specified, primaries that operate on files follow symbolic links and operate on the target of the link rather than the link itself. -A file, true if file exists. -B file, True if file exists and is a block special file. -C file. True if file exists and is a character special file. -D file. True if file exists and is a directory. -E file. True if file exists. -F file. True if file exists and is a regular file. -G file. True if file exists and its set group ID bit is set. -H file. True if file exists and is a symbolic link. -K file. True if file exists and its sticky bit is set. -P file. True if file exists and is a named pipe. -R file. True if file exists and is readable. -S file. True if file exists and has a size greater than 0. -TFD. True if file descriptor FD is open and refers to a terminal. -U file. True if file exists and its set user ID bit is set. -W file. True if file exists and is writable. -X file. True if file exists and is executable. -G file. True if file exists and is owned by the effective group ID. -L file. True if file exists and is a symbolic link. -N file. True if file exists and has been modified since it was last read. -O file. True if file exists and is owned by the effective user ID. -S file. True if file exists and is a socket. File1-EF file 2. True if file 1 and file 2 refer to the same device and inode numbers. File1-NT file 2. True if file 1 and is newer according to modification date than file 2, or if file 1 exists and file 2 does not. File1-OT file 2. True if file 1 is older than file 2, or if file 2 exists and file 1 does not. -O opt name. True if the shell option opt name is enabled. The list of options appears in the description of the -O option to the set built in. -V var name. True if the shell variable var name is set, has been assigned a value. -R var name. True if the shell variable var name is set and is a name reference. -Z string. True if the length of the string is 0. -N string, or just string. True if the length of the string is non-zero. String 1 == string 2 or string 1 = string 2. True if the strings are equal. When used with the double square brackets command, this performs pattern matching as described above. Equals should be used with the test command for Posix conformance. String 1 = string 2. True if the strings are not equal. String 1 less than string 2. True if string 1 sorts before string 2 lexicographically. String 1 greater than string 2. True if string 1 sorts after string 2 lexicographically. arg1 op arg2. Op is one of -eq, -ne, -lt, -le, -gt, or -ge. These arithmetic binary operators return true if arg1 is equal to, not equal to, less than or equal to, greater than or equal to arg2 respectively. arg1 and arg2 may be positive or negative integers. When used with the double square brackets command, arg1 and arg2 are evaluated as arithmetic expressions. Chapter 6.5 Shell Arithmetic. The shell allows arithmetic expressions to be evaluated as one of the shell expansions or by using the double parentheses compound command, the let built-in, or the -I option to the declare built-in. Evaluation is done in fixed width integers with no check for overflow, though division by 0 is trapped and flagged as an error. The operators and their precedence, associativity, and values are the same as in the C language. The following list of operators is grouped into levels of equal precedence operators. The levels are listed in order of decreasing precedence. ID++, ID-, variable post-increment and post-decrement, plus plus ID, minus minus ID, variable pre-increment and pre-decrement, minus plus, unary minus and plus, exclamation mark tilde, logical and bitwise negation, star star, exponentiation, star or star slash %, multiplication, division, remainder, plus minus, addition, subtraction, double less than, double greater than, left and right bitwise shifts, less than or equal, greater than or equal, less than, greater than, comparison, double equals, not equals, equality and inequality, ampersand, bitwise and, caret, bitwise exclusive or, pipe, bitwise or, double ampersand, logical and, double pipe, logical or, expression, question mark, expression, colon, expression, conditional operator, equals, times equals, slash equals, percent equals, plus equals, minus equals, double less than equals, double greater than equals, and equals, caret equals, pipe equals are all assignment. And expression 1, comma, expression 2 is comma. Shell variables are allowed as operands. Parameter expansion is performed before the expression is evaluated. Within an expression, shell variables may be referenced by name without using the parameter expansion syntax. A shell variable that is null or unset evaluates to 0 when referenced by name without using the parameter expansion syntax. The value of a variable is evaluated as an arithmetic expression when it is referenced, or when a variable which has been given the integer attribute using declare-i is assigned a value. A null value evaluates to 0. A shell variable need not have its integer attribute turned on to be used in an expression. Integer constants follow the C language definition, without suffixes or character constants. Constants with a leading 0 are interpreted as octal numbers. A leading 0x or 0x denotes hexadecimal. Otherwise, numbers take the form base n, where the optional base is a decimal number between 2 and 64 representing the arithmetic base, and n is a number in that base. If base pound is omitted, the base 10 is used. When specifying n, if a non-digit is required, the digits greater than 9 are represented by the lowercase letters, the uppercase letters, at, and underscore in that order. If base is less than or equal to 36, lowercase and uppercase letters may be used interchangeably to represent numbers between 10 and 35. Operators are evaluated in order of precedence. Sub-expressions in parentheses are evaluated first and may override the precedence rules above. 6.6 Aliases. Aliases allow a string to be substituted for a word when it is used as the first word of a simple command. The shell maintains a list of aliases that may be set and unset with the alias and unalias built-in commands. The first word of each simple command, if unquoted, is checked to see if it has aliases. If so, that word is replaced by the text of the alias. The characters slash, dollar, backtick, equal, and any of the shell meta characters or quoting characters listed above may not appear in an alias name. The replacement text may contain any valid shell input, including shell meta characters. The first word of the replacement text is tested for aliases, but a word that is identical to an alias being expanded is not expanded a second time. This means that one may alias ls to ls-uppercase f, for instance, and bash does not try to recursively expand the replacement text. If the last character of the alias value is a blank, then the next command word following the alias is also checked for alias expansion. Aliases are created and listed with the alias command and removed with the unalias command. There is no mechanism for using arguments in the replacement text, as in CSH. If arguments are needed, use a shell function. Aliases are not expanded when the shell is not interactive, unless the expand_aliases shell option is set using shopt. The rules concerning the definition and use of aliases are somewhat confusing. Bash always reads at least one complete line of input, and all lines that make up a compound command, before executing any of the commands on that line or the compound command. Aliases are expanded when a command is read, not when it is executed. Therefore, an alias definition appearing on the same line as another command does not take effect until the next line of input is read. The commands following the alias definition on that line are not affected by the new alias. This behavior is also an issue when functions are executed. Aliases are expanded when a function definition is read, not when a function is executed, because a function definition is itself a command. As a consequence, aliases defined in a function are not available until after that function is executed. To be safe, always put alias definitions on a separate line and do not alias in compound commands. For almost every purpose, shell functions are preferred over aliases. 6.7 Arrays. Bash provides one-dimensional indexed and associative array variables. Any variables may be used as an indexed array. The declare built-in will explicitly declare an array. There is no maximum limit on the size of an array, nor any requirement that members be indexed or assigned contiguously. Indexed arrays are referenced using integers, including arithmetic expressions, and are zero-based. Associative arrays use arbitrary strings. Unless otherwise noted, indexed arrays indices must be non-negative integers. An indexed array is created automatically if any variable is assigned to using the syntax name, square bracket, subscript, close square bracket, equals value. The subscript is treated as an arithmetic expression that must evaluate to a number. To explicitly declare an array, use declare-a name. The syntax declare-a name square bracket subscript is also accepted, but the subscript is ignored. Associative arrays are created using declare-uppercase a name. Attributes may be specified for an array variable using the declare and read-only built-ins. Each attribute applies to all members of an array. Arrays are assigned to using compound assignments of the form name equals parentheses value 1 space value 2, etc., where each value may be of the form square bracket subscript equals string. Indexed array assignments do not require anything but string. When assigning to indexed arrays, if the optional subscript is supplied, that index is assigned to. Otherwise, the index of the element assigned is the last index assigned to by the statement +1. Indexing starts at 0. Each value in the list undergoes all of the shell expansions described above. When assigning to an associative array, the words in a compound assignment may either be assignment statements, for which the subscript is required, or a list of words that is interpreted as a sequence of alternating keys and values. For example, name equals parentheses key 1 space value 1 space key 2 space value 2, etc. These are treated identically to name equals parentheses square bracket key 1 equals value 1 space square brackets key 2 equals value 2, etc. The first word in the list determines how the remaining words are interpreted. All assignments in a list must be of the same type. When using key-val pairs, the keys may not be missing or empty. A final missing value is treated like the empty string. This syntax is also accepted by the declare built-in. Individual array elements may be assigned to using the name square bracket subscript equals value syntax introduced above. When assigning to an indexed array, if name is subscripted by a negative number, that number is interpreted as relative to 1 greater than the maximum index of name, so negative indices count back from the end of the array, and an index of -1 references the last element. The plus equals operator will append to an array variable when assigning using the compound assignment syntax. Any element of an array may be referenced using parameter expansion name square bracket subscript. The braces are required to avoid conflicts with the shell's filename expansion operators. If the subscript is @ or star, the word expands to all members of the array name. These subscripts differ only when the word appears within double quotes. If the word is double quoted, parameter expansion name square brackets star expands to a single word with the value of each array member separated by the first character of the IFS variable, and parameter expansion name square brackets @ expands each element of name to a separate word. When there are no array members, parameter expansion name square brackets at symbol expands to nothing. If the double quoted expansion occurs within a word, the expansion of the first parameter is joined with the beginning part of the original word, and the expansion of the last parameter is joined with the last part of the original word. This is analogous to the expansion of the special parameters at and star. Parameter expansion pound name square brackets subscript expands to the length of name subscript. If subscript is at or star, the expansion is the number of elements in the array. If the subscript used to reference an element of an indexed array evaluates to a number less than 0, it is interpreted as relative to 1 greater than the maximum index of the array. So negative indices count back from the end of the array, and an index of -1 refers to the last element. Referencing an array variable without a subscript is equivalent to referencing with a subscript of 0. Any reference to a variable using a valid subscript is legal, and bash will create an array if necessary. An array variable is considered set if a subscript has been assigned a value. The null string is a valid value. It is possible to obtain the keys of an array as well as the values. Exclamation mark name square bracket at symbol in a parameter expansion and exclamation mark name square bracket star in a parameter expansion expand to the indices assigned in array variable names. The treatment when in double quotes is similar to the expansion of the special parameters at and star within double quotes. The unset built-in is used to destroy arrays. Unset name square bracket subscript destroys the array element at index subscript. Negative subscripts to indexed arrays are interpreted as described above. Unsetting the last element of an array variable does not unset the variable. Unset name, where name is an array, removes the entire array. Unset name subscript behaves differently depending on the array type when given a subscript of star or at. When name is an associative array, it removes the element with key star or at. If name is an indexed array, unset removes all of the elements but does not remove the array itself. When using a variable name with a subscript as an argument to a command, such as with unset, without using the word expansion syntax described above, the argument is subject to the shell's filename expansion. If filename expansion is not desired, the argument should be quoted. The declare, local, and read-only built-in commands each accept a -a option to specify an indexed array and a -a option to specify an associative array. If both options are supplied, -a takes precedence. The read built-in accepts a -a option to assign a list of words read from standard input to an array and can read values from the standard input into individual array elements. The set and declare built-in display array values in a way that allows them to be reused as input. 6.8. The directory stack. The directory stack is a list of recently visited directories. The pushD built-in adds directories to the stack as it changes the current directory, and the popd built-in removes specified directories from the stack and changes the current directory to the directory removed. The dirs built-in displays the contents of the directory stack. The current directory is always the top of the directory stack. The contents of the directory stack are also visible as the value of dir stack shell variable. 6.8.1 Directory stack built-ins. Dirs display the list of currently remembered directories. Directories are added to the list with the pushD command. The popd command removes directories from the list. The current directory is always the first directory in the stack. -C clears the directory stack by deleting all of the elements. -L produces a listing of using full path names. The default listing format uses a tilde to denote the home directory. -P causes dirs to print the directory stack with one entry per line. -V causes dirs to print the directory stack with one entry per line, prefixing each entry with its index in the stack. +N displays the nth directory, counting from the left of the list printed by dirs when invoked without options, starting with 0. -N displays the nth directory, counting from the right of the list printed by dirs when invoked without options, starting with 0. popd removes elements from the directory stack. Elements are numbered from 0 starting at the first directory listed by dirs. That is, popd is equivalent to popd plus 0. When no arguments are given, popd removes the top directory from the stack and changes to the new top directory. Arguments, if supplied, have the following meanings. -n suppresses the normal change of directory when removing directories from the stack so that only the stack is manipulated. +n removes the nth directory counting from the left of the list printed by dirs starting with 0 from the stack. -n removes the nth directory counting from the right of the list printed by dirs starting with 0 from the stack. If the top element of the directory stack is modified and the -n option was not supplied, popd uses the cd built-in to change to the directory at the top of the stack. If the cd fails, popd returns a non-zero value. Otherwise, popd returns an unsuccessful status if an invalid option is encountered, the directory stack is empty, or a non-existent directory stack entry is specified. If the popd command is successful, bash runs dirs to show the final contents of the directory stack and returns the status 0. Pushd adds the directory to the top of the directory stack or rotates the stack, making the new top of the stack the current working directory. With no arguments, pushd exchanges the top two elements of the directory stack. Arguments, if supplied, have the following meanings. -n suppresses the normal change of directory when rotating or adding directories to the stack so that only the stack is manipulated. +n brings the nth directory, counting from the left of the list printed by dirs starting with 0, to the top of the list by rotating the stack. -n brings the nth directory, counting from the right of the list printed by dirs starting with 0, to the top of the list by rotating the stack. dir makes dir be the top of the stack. After the stack has been modified, if the -n option was not supplied, pushd uses the cd built-in to change to the directory at the top of the stack. If the cd fails, pushd returns a non-zero value. Otherwise, if no arguments are supplied, pushd returns 0 unless the directory stack is empty. When rotating the directory stack, pushd returns 0 unless the directory stack is empty or a non-existent directory stack element is specified. If the pushd command is successful, bash runs dirs to show the final contents of the directory stack. 6.9 Controlling the prompt. Bash examines the values of the array variable prompt command just before printing each primary prompt. If any elements in prompt command are set and non-null, bash executes each line in numeric order just as if it had been typed on the command line. In addition, the following table describes the special characters which can appear in the prompt variables PS0, PS1, PS2, and PS4. \a, a bell character. \d, the date in weekday, month, date format. \D with a format. The format is passed through stirref time and the result is inserted into the prompt string. An empty format results in a locale-specific time representation. The braces are required. \E, an escape character. \H, the host name up to the first dot. \H, the host name. \J, the number of jobs currently managed by the shell. \L, the base name of the shell's terminal device name. \N, a new line. \R, a carriage return. \S, the name of the shell, the base name of $0. \T, the time in 24-hour format. \T, the time in 12-hour format. \@ symbol, the time in 12-hour AM/PM format. \A, the time in 24-hour format. \U, the username of the current user. \V, the version of bash. \V, the release of bash version plus patch level. \W, the value of the pwd shell variable with home abbreviated with a tilde, \uppercase W, the base name of pwd with home abbreviated with a tilde, \!, the history number of this command, \pound, the command number of this command, $, if the effective UID is 0, pound, otherwise $, \NNN, the character whose ASCII code is the octal value NNN, double backslash, a literal backslash, open square bracket, begin a sequence of non-printing characters. This could be used to embed a terminal control sequence into the prompt. \, closing square bracket, end a sequence of non-printing characters. The command number and the history number are usually different. The history number of a command is its position in the history list, which may include commands restored from the history file, while the command number is the position in the sequence of commands executed during the current shell session. After the string is decoded, it's expanded via parameter expansion, command substitution, arithmetic expansion, and quote removal, subject to the value of the prompt vars shell option. This can have unwanted side effects if escaped portions of the string appear within command substitution or contain characters special to word expansion. 6.10, the restricted shell. If bash is started with the name rbash, or the -- restricted or -r option is supplied at invocation, the shell becomes restricted. A restricted shell is used to set up an environment more controlled than the standard shell. A restricted shell behaves identically to bash, with the exception that the following are disallowed or not performed: changing directories with the cd built in, setting or unsetting the values of the shell, path, histfile, env, or bash env variables, specifying command names containing slashes, specifying a file name containing a slash as an argument to the dot built-in command, specifying a file name containing a slash as an argument to the history built-in command, specifying a file name containing a slash as an argument to the -p option to the hash built-in command, importing function definitions from the shell environment at startup, parsing the value of shell ops from the shell environment at startup, redirecting output using the greater than pipe, less than ampersand, ampersand greater than, and double greater than redirection operators, using the exec built-in to replace the shell with another command, adding or deleting built-in commands with the -f and -d options to the enable built-in, using the enable built-in command to enable disabled shell built-ins, specifying the -p option to the command built-in, turning off restricted mode with set +r or shopt-u restricted _ shell. These restrictions are enforced after any startup files are read. When a command that is found to be a shell script is executed, rbash turns off any restrictions in the shell spawned to execute the script. The restricted shell mode is only one component of a useful restricted environment. It should be accompanied by setting path to a value that it allows execution of only a few verified commands. Commands that allow shell escapes are particularly vulnerable. Changing the current directory to a non-writable directory other than the home after login, not allowing the restricted shell to execute shell scripts, and cleaning the environment of variables that cause some commands to modify their behavior. For example, visual or pager. Modern systems provide more secure ways to implement a restricted environment, such as jails, zones, or containers. 6.11 Bash Posix Mode. Starting bash with the --posix command line option or executing set-o posix while bash is running will cause bash to conform more closely to the POSIX standard by changing the behavior to match that specified by POSIX in areas where the bash default differs. When invoked as sh, bash enters Posix mode after reading the startup files. The following list is what's changed when Posix mode is in effect. 1. Bash ensures that POSIXly correct variable is set. 2. When a command in the hash table no longer exists, bash will research path to find the new location. This is also available with chopt-s check hash. 3. Bash will not insert a command without the execute bit set into the command hash table, even if it returns it as a last-ditch result from a path search. 4. The message printed by the job control code and built-ins when a job exits with a non-zero status is done, parentheses status. 5. The message printed by the job control code and built-ins when a job is stopped is stopped, parentheses signame, where signame is, for example, sigstop, sigtstop. 6. Alias expansion is always enabled, even in non-interactive shells. 7. Reserved words appearing in a context where reserved words are recognized do not undergo alias expansion. 8. Alias expansion is performed when initially parsing a command substitution. The default mode generally defers it, when enabled, until the command substitution is executed. This means that command substitution will not expand aliases that are defined after the command substitution is initially parsed, e.g., as part of a function definition. 9. The Posix PS1 and PS2 expansions of exclamation mark to the history number and double exclamation mark to exclamation mark are enabled, and parameter expansion is performed on the values of PS1 and PS2 regardless of the setting of the prompt vars option. 10. The Posix startup files are executed env rather than the normal bash files. 11. Tilde expansion is only performed on assignments preceding a command name rather than on all assignment statements on the line. 12. The default history file is .sh_history. This is the default value of hist file. 13. Redirection operators do not perform file name expansion on the word in the redirection unless the shell is interactive. 14. Redirection operators do not perform word splitting on the word in the redirection. 15. Function names must be valid shell names. That is, they may not contain characters other than letters, digits, and underscores, and may not start with a digit. Declaring a function with an invalid name causes a fatal syntax error in non-interactive shells. 16. Function names may not be the same as the one of the Posix special built-ins. 17. Posix special built-ins are found before shell functions during command lookup. 18. When printing shell function definitions, for example by type, bash does not print the function keyword. 19. Literal tildes that appear as the first character in elements of the path variable are not expanded as described above under tilde expansion. 20. The time reserved word may be used by itself as a command. When used in this way, it displays timing statistics for the shell and its completed children. The time format variable controls the format of the timing information. 21. When parsing and expanding a parameter expansion that appears within double quotes, single quotes are no longer special and cannot be used to quote a closing brace or other special character unless the operator is one of those defined to perform pattern removal. In this case, they do not have to appear as matched pairs. 22. The parser does not recognize time as a reserved word if the next token begins with a dash. 23. The exclamation mark character does not introduce history expansion within a double quoted string, even if the hist expand option is enabled. 24. If a Posix special built-in returns an error status, a non-interactive shell exits. The fatal errors are listed in the Posix standard and include things like passing incorrect options, redirection errors, variable assignment errors for assignments preceding the command name, and so on. 25. A non-interactive shell exits with an error status if a variable assignment error occurs when no command name follows the assignment statements. A variable assignment error occurs, for example, when trying to assign a value to a read-only variable. 26. A non-interactive shell exits with an error status if a variable assignment error occurs in an assignment statement preceding a special built-in, but not with any other simple command. For any other simple command, the shell aborts execution of that command and execution continues at the top level. The shell shall not perform any further processing of the command in which the error occurred. 27. A non-interactive shell exits with an error status if the iteration variable in a for statement or the selection variable in a select statement is a read-only variable. 28. Non-interactive shells exit if filename in .filename is not found. 29. Non-interactive shells exit if a syntax error in an arithmetic expansion results in an invalid expression. 30. Non-interactive shells exit if a parameter expansion error occurs. 31. Non-interactive shells exit if there is a syntax error in a script read with the dot or source built-ins or in a string processed by the eval built-in. 32. While variable indirection is available, it may not be applied to the pound and question mark special parameters. 33. Expanding the star special parameter in a pattern context where the expansion is double quoted does not treat the $* as if it were double quoted. 34. Assignment statements preceding Posix special built-ins persist in the shell environment after the built-in completes. 35. The command built-in does not prevent built-ins that take assignment statements as arguments from expanding them as assignment statements. When not in Posix mode, assignment built-ins lose their assignment statement expansion properties when preceded by a command. 36. The BG built-in uses the required format to describe each job placed in the background, which does not include an indication of whether the job is the current or previous job. 37. The output of kill-l prints all the signal names on a single line, separated by spaces, without the sig prefix. 38. The kill built-in does not accept signal names with a sig prefix. 39. The export and read-only built-in commands display their output in the format required by Posix. 40. The trap built-in displays signal names without the leading sig. 41. The trap built-in doesn't check the first argument for a possible signal specification and revert the signal handling to the original disposition if it is, unless that argument consists solely of digits and is a valid signal number. If users want to reset the handler for a given signal to the original disposition, they should use the dash as the first argument. 42. Trap-p displays signals whose dispositions are set to sig_DFL and those that were ignored when the shell started. 43. The dot and source built-ins do not search the current directory for the file name argument if it is not found by searching path. 44. Enabling Posix mode has the effect of setting the inherit_error exit option so subshells spawned to execute command substitutions inherit the value of the -e option from the parent shell. When the inherit_error exit option is not enabled, bash clears the -e option in such subshells. 45. Enabling Posix mode has the effect of setting the shift_verbose option so numeric options to shift that exceed the number of positional parameters will result in an error message. 46. When the alias built-in displays alias definitions, it does not display them with a leading alias unless the -p option is supplied. 47. When the set built-in is invoked without options, it does not display shell function names and definitions. 48. When the set built-in is invoked without options, it displays variable values without quotes unless they contain shell meta characters, even if the result contains non-printing characters. 49. When the CD built-in is invoked in logical mode, and the path name constructed from PWD and the directory name supplied as an argument does not refer to an existing directory, CD will fail instead of falling back to physical mode. 50. When the CD built-in cannot change a directory because the length of path name constructed from PWD and the directory name supplied as an argument exceeds path_max when all symbolic links are expanded, CD will fail instead of attempting to use only the supplied directory name. 51. The PWD built-in verifies that the value it prints is the same as the current directory, even if it is not asked to check the file system with the -P option. 52. When listing the history, the FC built-in does not include an indication of whether or not a history entry has been modified. 53. The default editor used by FC is ed. 54. The type and command built-ins will not report a non-executable file as having been found, though the shell will attempt to execute such a file if it is the only so named file in path. 55. The VI editing command will invoke the VI editor directly when the V command is run, instead of checking the visual and editor variables. 56. When the XPG_echo option is enabled, Bash does not attempt to interpret any arguments to echo as options. Each argument is displayed after escape characters are converted. 57. The ulimit built-in uses a block size of 512 bytes for the -C and -F options. 58. The arrival of sigchild when a trap is set on sigchild does not interrupt the wait built-in and cause it to return immediately. The trap command is run once for each child that exits. 59. The read built-in may be interrupted by a signal for which a trap has been set. If Bash receives a trapped signal while executing read, the trap handler executes and read returns an exit status greater than 128. 60. The printf built-in uses double via stir to OD or stir to D to convert arguments corresponding to floating point conversion specifiers instead of long double if it's available. The uppercase L modifier forces printf to use long double if it's available. 61. Bash removes an exited background process's status from the list of such statuses after the wait built-in is used to obtain it. There is other Posix behavior that Bash does not implement by default even when in Posix mode. Specifically, 1. The FC built-in checks $editor as a program to edit history entries if FC edit is unset, rather than defaulting directly to ed. FC uses ed if editor is unset. 2. As noted above, Bash requires the XPG_echo option to be enabled for the echo built-in to be fully conformant. Bash can be configured to be Posix conformant by default by specifying the --enable strict -posix default to configure when building. 6.12 Shell Compatibility Mode. Bash 4.0 introduced the concept of a shell compatibility level, specified as a set of options to the shopped built-in. There's only one current compatibility level. Each option is mutually exclusive. The compatibility level is intended to allow users to select behavior from previous versions that is incompatible with newer versions while they migrate scripts to use current features and behavior. It's intended to be a temporary solution. This section does not mention behavior that is standard for a particular version. For example, setting compat32 means that quoting the RHS of regular expression matching operator quotes special regex characters in the word, which is default in Bash 3.2 and subsequent versions. If a user enables, say, compat32, it may affect the behavior of other compatibility levels up to and including the current compatibility level. The idea is that each compatibility level controls behavior that changed in that version of Bash, but that behavior may have been present in earlier versions. For instance, the change to use locale-based comparisons with the double square brackets command came in Bash 4.1, and earlier versions use ASCII-based comparisons, so enabling compat32 will enable ASCII-based comparisons as well. That granularity may not be sufficient for all uses, and as a result, users should employ compatibility levels carefully. Read the documentation for a particular feature to find out the current behavior. Bash 4.3 introduced a new shell variable, bash compat. The value assigned to this variable, a decimal version number like 4.2, or an integer corresponding to the compat nn option like 42, determines the compatibility level. Starting with bash 4.4, bash has begun deprecating older compatibility levels. Eventually, the options will be removed in favor of bash compat. Bash 5.0 is the final version for which there will be an individual shopped option for the previous versions. Users should use bash compat on bash 5.0 and later. The following table describes the behavior changes controlled by each compatibility level setting. The compat tag is used as a shorthand for setting the compatibility level to NN using one of the following mechanisms. For versions prior to 5.0, the compatibility level may be set using the corresponding compat NN shopped option. For bash 4.3 and later versions, the bash compat variable is preferred, and it is required for bash 5.1 and later. Compat 31, quoting the RHS of the double square brackets commands regular expression matching operator equals tilde, has no special effect. Compat 32, interrupting a command list such as A semicolon B semicolon C causes the execution of the next command in the list. In bash 4.0 and later versions, the shell acts as if it has received the interrupt, so interrupting one command in a list aborts the execution of the entire list. Compat 40. The less than and greater than operators to the double square brackets command do not consider the current locale when comparing strings. They use ASCII ordering. Bash versions prior to bash 4.1 use ASCII collation and strcomp. Bash 4.1 and later use the current locale's collation sequence and strcall. Compat 41 has 2 bullet points. In Posix mode, time may be followed by options and still be recognized as a reserved word. This is Posix interpretation 267. In Posix mode, the parser requires that an even number of single quotes occur in the word portion of a double-quoted parameter expansion and treats them specially, so that characters within the single quotes are considered quoted. This is Posix interpretation 221. Compat 42. The replacement string in double-quoted pattern substitutions does not undergo quote removal, as it does in versions after bash 4.2. In Posix mode, single quotes are considered special when expanding the word portion of a double-quoted parameter expansion and can be used to quote a closing brace or other special character. This is part of Posix interpretation 221. In later versions, single quotes are not special within double-quoted word expansions. Compat 43. The shell does not print a warning message if an attempt is made to use a quoted compound assignment as an argument to declare. For example, declare -a foo equals single quotes, open parentheses, 1 space 2, close parentheses, single quote. Later versions warn that this usage is deprecated. Word expansion errors are considered non-fatal errors that cause the current command to fail, even in Posix mode. The default behavior is to make them fatal errors that cause the shell to exit. When executing a shell function, the loop state, while, until, etc. is not reset, so break or continue in that function will break or continue loops in the calling context. Bash 4.4 and later reset the loop state to prevent this. Compat 44. The shell sets up the values used by bash argv and bash argc so they can expand to the shell's positional parameters even if extended debugging mode is not enabled. A subshell inherits loops from its parent context, so break or continue will cause the subshell to exit. Bash 5.0 and later reset the loop state to prevent the exit. Variable assignments preceding built-ins like export and read-only that set attributes continue to affect variables with the same name in the calling environment even if the shell is not in Posix mode. Compat 50. This is where you have to start using bash compat. Bash 5.1 changed the way random is generated to introduce slightly more randomness. If the shell compatibility level is set to 50 or lower, it reverts to the method from Bash 5.0 and previous versions, so seeding the random number generator by assigning a value to random will produce the same sequence as in Bash 5.0. If the command hash table is empty, Bash versions prior to 5.1 printed an informational message to that effect, even when producing output that can be reused as input. Bash 5.1 suppresses that message when the -L option is supplied. Compat 51. The unset built-in will unset the array the unset built-in will unset the array A given an argument like A square brackets @ symbol. Bash 5.2 will unset an element with key @ associative arrays or remove all elements without unsetting the array. Arithmetic commands and the expressions in an arithmetic for statement can be expanded more than once. Expressions used as arguments to arithmetic operators in the double square bracket conditional command can be expanded more than once. The expressions in substring parameter brace expansion can be expanded more than once. The expressions in the $double parentheses arithmetic expansion word expansion can be expanded more than once. Arithmetic expressions used as indexed array subscripts can be expanded more than once. Test-v, when given an argument of uppercase A subscript @ symbol, where uppercase A is an existing associative array, will return true if the array has any set elements. Bash 5.2 will look for and report on a key named @. The parameter square brackets colon equals value word expansion will return value before any variable specific transformations have been performed, e.g. converting to lowercase. Bash 5.2 will return the final value assigned to the variable. Parsing command substitutions will behave as if extended glob is enabled, so that parsing a command substitution containing an ext glob pattern, say as part of a shell function, will not fail. This assumes the intent is to enable ext glob before the command is executed and the word expansions are performed. It will fail at word expansion time if ext glob hasn't been enabled by the time the command is executed. Chapter 7, Job Control. This chapter discusses what job control is, how it works, and how Bash allows you to access its facilities. 7.1, Job Control Basics. Job control refers to the ability to selectively stop or suspend the execution of processes and continue or resume their execution at a later point. A user typically employs this facility via an interactive interface supplied jointly by the operating system kernel's terminal driver and Bash. The shell associates a job with each pipeline. It keeps a table of currently executing jobs which may be listed with the jobs command. When Bash starts a job asynchronously, it prints a line that looks like this: parentheses 1 space 25647, indicating that this is job number 1 and that the process ID of the last process in the pipeline associated with this job is 25647. All of the processes in a single pipeline are members of the same job. Bash uses the job abstraction as the basis for job control. To facilitate the implementation of the user interface to job control, the operating system maintains the notion of a current terminal process group ID. Members of this process group, processes whose process group ID is equal to the current terminal process group ID, receive keyboard-generated signals such as SIGINT. These processes are said to be in the foreground. Background processes are those whose process group ID differs from the terminals. Such processes are immune to keyboard-generated signals. Only foreground processes are allowed to read from, or, if the user so specifies with STTY to stop, write to the terminal. Background processes which attempt to read from write to when stty2 stop is in effect, the terminal are sent a sigttin, sigttau signal by the kernel's terminal driver, which, unless caught, suspends the process. If the operating system on which bash is running supports job control, bash contains facilities to use it. Typing the suspend character, typically Control-Z, while a process is running, causes that process to be stopped and returns control to bash. Typing the delayed suspend character, typically Control-Y, causes the process to be stopped when it attempts to read input from the terminal, and control to be returned to bash. The user then manipulates the state of this job using the bg command to continue it in the background, the fg command to continue it in the foreground, or the kill command to kill it. A Control-Z takes effect immediately and has the additional side effect of causing pending output and type ahead to be discarded. There are a number of ways to refer to a job in the shell. The character % introduces a job specification. Job number n may be referred to as %n. The symbols %% and %+ refer to the shell's notion of the current job, which is the last job while it was in the foreground or started in the background. A single % with no accompanying job specification also refers to the current job. The previous job may be referenced using %-. If there's only a single job, %+ and %- can both be used to refer to that job. In output pertaining to jobs, for example, the output of the jobs command, the current job is always flagged with a plus, and the previous job with a minus. A job may also be referred to using a prefix of the name used to start it, or using a substring that appears in its command line. For example, %ce refers to a stop job whose command name begins with ce. Using %?ce, on the other hand, refers to any job containing the string ce in its command line. If the prefix or substring matches more than one job, bash reports an error. Simply naming a job can be used to bring it to the foreground. %1 is a synonym for fg %1, bringing job 1 from the background into the foreground. Similarly, %1 ampersand resumes job 1 in the background, equivalent to bg %1. The shell learns immediately whenever a job changes state. Normally, bash waits until it is about to print a prompt before reporting changes in a job status so as to not interrupt any other output. If the -b option to the set built-in is enabled, bash reports such changes immediately. Any trap on sigchild is executed for each child process that exits. If an attempt to exit bash is made while jobs are stopped, or running if the check jobs option is enabled, the shell prints a warning message, and if the check jobs option is enabled, lists the jobs and their statuses. The jobs command may then be used to inspect their status. If a second attempt to exit is made without an intervening command, bash does not print another warning, and any stop jobs are terminated. When the shell is waiting for a job or process using the wait built-in, and job control is enabled, wait will return when the job changes states. The -f option causes wait to wait until the job or process terminates before returning. 7.2 Job Control Built-ins. BG. Resume each suspended job spec in the background as if it had been started with ampersand. If job spec is not supplied, the current job is used. The return status is 0 unless it is run when job control is not enabled, or when run with job control enabled, any job spec was not found or specifies a job that was started without job control. FG. Resumes the job spec in the foreground and make it the current job. If job spec is not supplied, the current job is used. The return status is that of the command placed into the foreground, or non-zero if run when job control is disabled, or when run with job control enabled, job spec does not specify a valid job, or job spec specifies a job that was started without job control. Jobs. The first form lists the active jobs. The options have the following meanings. -L, list process IDs in addition to the normal information. -N, display information about jobs that have changed status since the user was last notified of their status. -P, list only the process ID of the job's process group leader. -R, display only running jobs. -S, display only stopped jobs. If job spec is given, output is restricted to information about that job. If job spec is not supplied, the status of all jobs is listed. If the -X option is supplied, jobs replaces any job spec found in command or arguments with the corresponding process group ID and executes command, passing it arguments, returning its exit status. Kill. Send a signal specified by sigspec or signum to the process named by a job specification job spec or process ID PID. Sigspec is either a case-insensitive signal name such as sigint with or without the sig prefix, or a signal number. Signum is a signal number. If sigspec and signum are not present, sigterm is used. The -L option lists the signal names. If any arguments are supplied with -L is given, the name of the signals corresponding to the arguments are listed, and the return status is 0. Exit status is a number specifying a signal number or the exit status of a process terminated by a signal. The -uppercase L option is equivalent to -lowercase l. The return status is 0 if at least one signal was successfully sent, or non-zero if an error occurs or an invalid option is encountered. Wait. Waits until a child process specified by each process ID, PID, or job specification, job spec, exits and returns the exit status of the last command waited for. If a job spec is given, all processes in the job are waited for. If no arguments are given, wait waits for all running background jobs in the last executed process substitution. If its process ID is the same as $! And the return status is 0. If the -N option is supplied, wait waits for a single job from the list of PIDs or job specs, or if no arguments are supplied, any job to complete and returns its exit status. If none of the supplied arguments is a child of the shell, or if no arguments are supplied and the shell has no unwaited for children, the exit status is 127. If the -P option is supplied, the process or job identifier of the job for which the exit status is returned is assigned to the variable var name, named by the option argument. The variable will be unset initially before any assignment. This is useful only when the -N option is supplied. Supplying the -F option when job control is enabled forces wait to wait for each PID or job spec to terminate before returning its status, instead of returning when it changes status. If neither job spec nor PID specifies an active child process of the shell, the return status is 127. If wait is interrupted by a signal, the return status will be greater than 128, as described above. Otherwise, the return status is the exit status of the last process or job waited for. Disown. Without options, removes each job spec from the table of active jobs. If the -H option is given, the job is not removed from the table, but is marked so that sighup is not sent to the job if the shell receives a sighup. The job spec is not present if the job spec is not present, and neither the -A nor the -R option is supplied, the current job is used. If no job spec is supplied, the -A option means to remove or mark all jobs. The -R option without a job spec argument restricts operation to running jobs. Suspend with an optional -F. Suspends the execution of this shell until it receives a sigconst signal. A login shell or a shell without job control enabled cannot be suspended. The -F option can be used to override this and force this suspension. The return status is 0 unless the shell is a login shell or job control is not enabled and -F is not supplied. When job control is not active, The kill and wait built-ins do not accept job spec arguments. They must be supplied process IDs. 7.3 Job control variables. Auto_resume. This variable controls how the shell interacts with the user and job control. If this variable exists, then single-word simple commands without redirections are treated as candidates for resumption of an existing job. There is no ambiguity allowed. If there's more than one job beginning with a string typed, then the most recently accessed job will be selected. The name of a stopped job in this context is the command line used to start it. If this variable is set to the value exact, the string supplied must match the name of a stopped job exactly. If set to substring, the string supplied needs to match a substring of the name of a stopped job. The substring value provides functionality analogous to the %? Job ID. See job control basics. If set to any other value, the supplied string must be a prefix of a stopped job's name. This provides functionality analogous to the %job ID. Chapter 8. Command Line Editing. This chapter describes the basic features of the GNU Command Line Editing interface. Command Line Editing is provided by the Readline library, which is used by several different programs, including Bash. Command Line Editing is enabled by default when using an interactive shell, unless the -- no editing option is supplied at shell invocation. Line editing is also used when using the -e option to the read built-in command. By default, the line editing commands are similar to those of Emacs. A VI-style line editing interface is also available. Line editing can be enabled at any time using the -o Emacs or -o VI options to the set built-in command, or disabling using the +o Emacs or +o VI options to set. 8.1 Introduction to Line Editing. The following paragraphs describe the notation used to represent keystrokes. The text CK is read as Control-K and describes the character produced when the K key is pressed while the Control key is depressed. The text M-K is read as Meta-K and describes the character produced when the Meta key, if you have one, is depressed while the K key is pressed. The Meta key is labeled Alt on many keywords. On keyboards with two keys labeled Alt, usually to either side of the spacebar, the Alt on the left side is generally set to work as a Meta key. The Alt key on the right side may also be configured to work as a Meta key, or may be configured as some other modifier, such as a compose key for typing accent characters. If you do not have a Meta or Alt key, or another key working as a Meta key, the identical keystrokes can be generated by typing escape first and then typing K. Either process is known as metafying the K key. The text MCK is read as Meta Control K and describes the character produced by metafying Control K. In addition, several keys have their own names. Specifically, delete, escape, line feed, space, return, and tab all stand for themselves when seen in this text or in an init file. If your keyboard lacks a line feed key, typing Ctrl-J will produce the desired character. The return key may be labeled return or enter on some keyboards. 8.2 Readline Interaction. Often during an interactive session, you type in a long line of text only to notice that the first word on the line is misspelled. The Readline library gives you a set of commands for manipulating the text as you type it in, allowing you to just fix your typo and not forcing you to retype the majority of the line. Using these editing commands, you move the cursor to the place that needs correction and delete or insert the text of your corrections. Then, when you are satisfied with the line, you simply press return. You do not have to be at the end of the line to press return. The entire line is accepted regardless of the location of the cursor within the line. 8.2.1 Readline Bare Essentials. In order to enter characters into the line, simply type them. The typed characters appear where the cursor was, and then the cursor moves one space to the right. If you mistype a character, you can use your erase character to back up and delete the mistyped character. Sometimes you may mistype a character and not notice the error until you've mistyped several other characters. In that case, you can type Control-B to move the cursor to the left, and then correct your mistake. Afterwards, you can move the cursor to the right with Control-F. When you add text in the middle of a line, you will notice that characters to the right of your cursor are pushed over to make room for the text that you've inserted. Likewise, when you delete text behind the cursor, characters to the right of the cursor are pulled back to fill in the blank spaces created by the removal of the text. A list of the bare essentials for editing the text of an input line follows. Control-B, move back one character. Control-F, move forward one character. Delete or backspace, delete the character to the left of the cursor. Control-D, delete the character underneath the cursor. Printing characters, insert the character into the line at the cursor. Control__ or Control-X, Control-U. Undo the last editing command. You can undo all the way back to an empty line. Depending on your configuration, the backspace key might be set to delete the character to the left of the cursor, and the delete key might be set to delete the character under the cursor, like Control-D, rather than the character to the left of the cursor. 8.2.2 Readline Movement Commands. The above table describes the most basic keystrokes that you need in order to do editing of the input line. For your convenience, many other commands have been added in addition to Control-B, Control-F, Control-D, and Delete. Here are some commands for moving more rapidly around the line. Control-A, move to the start of the line. Control-E, move to the end of the line. Meta-F, move forward a word where a word is composed of letters and digits. Meta-B, move backwards a word. Control-L, clear the screen, reprinting the current line at the top. Notice how Control-F moves forward a character, while Meta-F moves forward a word. It is a loose convention that Control keystrokes operate on characters, while Meta keystrokes operate on words. 8.2.3 Readline Killing Commands. Killing text means to delete the text from the line, but to save it away for later use, usually by yanking, reinserting it back into the line. Cut and paste are more recent jargon for kill and yank. If the description for a command says that it kills text, then you can be sure that you can get the text back in a different way or the same place later. When you use a kill command, the text is saved in a kill ring. Any number of consecutive kills save all of the killed text together, so that when you yank it back, you get it all. The kill ring is not line specific. The text that you killed on a previous typed line is available to be yanked back later, when you are typing another line. Here's a list of commands for killing text. Control-K, kill the text from the current cursor position to the end of the line. Meta-D, kill from the cursor to the end of the current word, or, if between words, to the end of the next word. Word boundaries are the same as those used by Meta-F. Meta-Delete, kill from the cursor to the start of the current word, or, if between words, to the start of the previous word. Word boundaries are the same as those used by Meta-B. Control-W, kill from the cursor to the previous white space. This is different than Meta-Delete because the word boundaries differ. Here's how to yank the text back into the line. Yanking means to copy the most recently killed text from the kill buffer. Control-Y, yank the most recently killed text back into the buffer at the cursor. Meta-Y, rotate the kill ring and yank the new top. You can only do this if the prior command is Control-Y or Meta-Y. 8.2.4 Readline arguments. You can pass numeric arguments to readline commands. Sometimes the arguments act as a repeat count. Other times it is the sign of the argument that is significant. If you pass a negative argument to a command which normally acts in a forward direction, that command will act in a backward direction. For example, to kill text back to the start of the line, you might type meta-Control-K. The general way to pass numeric arguments to a command is to type meta digits before the command. If the first digit typed is a minus sign, then the sign of the argument will be negative. Once you've typed one meta digit to get the argument started, you can type the remainder of the digits and then the command. For example, to give the Control-D command an argument of 10, you would type meta1, 0, Control-D, which will delete the next 10 characters on the input line. 8.2.5 Searching for commands in the history. Readline provides commands for searching through the command history for lines containing a specified string. There are two search modes, incremental and non-incremental. Incremental searches begin before the user has finished typing the search string. As each character of the string is typed, Readline displays the next entry from the history matching the strings typed so far. An incremental search requires only as many characters as needed to find the desired history entry. To search backwards in the history for a particular string, type Control-R. Typing Control-S searches forward through the history. The characters present in the value of the iSearch terminators variable are used to terminate an incremental search. If that variable has not been assigned a value, the escape and Control-Shift-J characters will terminate an incremental search. Control-G will abort an incremental search and restore the original line. When the search is terminated, the history entry containing the search string becomes the current line. To find other matching entries in the history list, type Control-R or Control-S as appropriate. This will search backwards or forwards in the history for the next entry matching the search string typed so far. Any other key sequence bound to a readline command will terminate the search and execute that command. For instance, a return will terminate the search and accept the line, thereby executing the command from the history list. A movement command will terminate the search, make the last line found the current line, and begin editing. Readline remembers the last incremental search string. If two Control-Rs are typed without any intervening characters defining a new search string, any remembered search string is used. Non-incremental searches read the entire search history before starting to search for matching history lines. The search string may be typed by the user or be part of the contents of the current line. 8.3 Readline Init file. Although the Readline library comes with a set of Emacs-like key bindings installed by default, it is possible to use a different set of key bindings. Any user can customize programs that use Readline by putting commands in an input.rc file, conventionally in their home directory. The name of this file is taken from the value of the shell variable input.rc. If that variable is unset, the default is .input.rc. If that file does not exist or cannot be read, the ultimate default is etc input.rc. The bind built-in command can also be used to set Readline key bindings and variables. When a program which uses the Readline library starts up, the init file is read and the key bindings are set. In addition, the Control-X Control-R command rereads this init file, thus incorporating any changes you might have made to it. 8.3.1 Readline init file syntax. There are only a few basic constructs allowed in the Readline init file. Blank lines are ignored. Lines beginning with a pound are comments. Lines beginning with a $sign indicate conditional constructs. Other lines denote variable settings and key bindings. Variable settings. You can modify the runtime behavior of Readline by altering the values of variables in readline using the set command within the init file. Syntax is simple. Set variable value. Here, for example, is how to change from the default Emacs-like key binding to use VI line editing commands. Set editing mode VI. Variable names and values, where appropriate, are recognized without regard to case. Unrecognized variable names are ignored. Boolean variables, those that can be set to on or off, are set to on if the value is null or empty, on, case sensitive, or 1. Any other value results in the variable being set to off. The bind-uppercase V command lists the current readline variables' names and values. A great deal of runtime behavior is changeable with the following variables. Active-region-start-color, a string variable that controls the text color and background when displaying the text in the active region. This string must not take up any physical character positions on the display, so it should consist only of terminal escape sequences. It is output to the terminal before displaying the text in the active region. This variable is reset to the default value whenever the terminal type changes. The default value is the string that puts the terminal in standout mode, as obtained from the terminal's term info description. A sample value might be \e open square brace 01 semicolon 33m. Active-region-end-color, a string variable that undoes the effect of active-region-start-color and restores normal terminal display appearance after displaying text in the active region. This string must not take up any physical character positions on the display, so it should consist only of terminal escape sequences. It is output to the terminal after displaying the text in the active region. This variable is reset to the default value whenever the terminal type changes. The default value is the string that restores the terminal from standout mode as obtained from the terminal's term info description. A sample value might be \e square bracket 0m. Bell-style controls what happens when readline wants to ring the terminal bell. If set to none, readline never rings the terminal bell. If set to visible, readline uses a visible bell if one is available. If set to audible, the default, readline attempts to ring the terminal's bell. Bind-tty-special-chars. If set to on, the default, readline attempts to bind the control characters treated specially by the kernel's terminal driver to their readline equivalents. Blink-matching-paren. If set to on, readline attempts to briefly move the cursor to an opening parentheses with a closing parentheses when a closing parentheses is inserted. The default is off. Colored-completion-prefix. If set to on, when listing completions, readline displays the common prefix of the set of possible completions using a different color. The color definitions are taken from the value of ls colors environment variable. If there's a color definition in ls colors for the custom suffix readline-colored-completion-prefix, readline uses this color for the common prefix instead of its default. The default is off. Colored-stats. If set to on, readline displays possible completions using different colors to indicate their file type. The color definitions are taken from the value of the ls colors environment variable. The default is off. Comment-begin. The string to insert at the beginning of the line when the insert-comment command is executed. The default value is $. Completion-display-width. The number of screen columns used to display possible matches when performing completion. The value is ignored if it is less than 0 or greater than the terminal screen width. A value of 0 will cause matches to be displayed 1 per line. The default value is -1. Completion-ignore-case. If set to on, readline performs file name matching and completion in a case-insensitive fashion. The default value is off. Completion-map-case. If set to on and completion-ignore-case is enabled, Readline treats hyphens and underscores as equivalent when performing case dash and sensitive file name matching and completion. The default value is off. Completion prefix display length. The length in characters of the common prefix of a list of possible completions that is displayed without modification. When set to a value greater than 0, common prefixes longer than this value are replaced with an ellipses when displaying possible completions. Completion query items. The number of possible completions that determines when the user is asked whether the list of possibilities should be displayed. If the number of possible completions is greater than or equal to this value, Readline will ask whether or not the user wishes to view them. Otherwise, they are simply listed. This variable must be set to an integer value greater than or equal to 0. A 0 value means Readline should never ask. Negative values are treated as 0. The default limit is 100. Convert meta. If set to on, Readline will convert characters with the 8th bit set to an ASCII key sequence by stripping the 8th bit and prefixing an escape character, converting them to a meta prefix key sequence. The default value is on, but will be set to off if the locale is one that contains 8-bit characters. This variable is dependent on the LCC type locale category. It may change if the locale is changed. Disable completion. If set to on, Readline will inhibit word completion. Completion of characters will be inserted into the line as if they had been mapped to self-insert. The default is off. Didn't we read that it was case sensitive for on? Whoops. Echo control characters. When set to on operating systems that indicate they support it, Readline echoes a character corresponding to a signal generated from the keyboard. The default is on. Editing mode. The editing mode variable controls which default set of key bindings is used. By default, Readline starts up in Emacs editing mode, where the keystrokes are most similar to Emacs. This variable can be set to either Emacs or Vi. Emacs mode string. If the show mode and prompt variable is enabled, this string is displayed immediately before the last line of the primary prompt when Emacs editing mode is active. The value is expanded like a key binding, so the standard set of meta and control prefixes and / escape sequences is available. Use the \1 and \2 escapes to begin and end sequences of non-printing characters, which can be used to embed a terminal control sequence into the mode string. The default is @ Enable active region. The point is the current cursor position, and mark refers to a saved cursor position. See commands for moving. The text between the point and mark is referred to as the region. When this variable is set to on, Readline allows certain commands to designate the region as active. When the region is active, Readline highlights the text in the region using the value of the active region start color, which defaults to the string that enables the terminal's standout mode. The active region shows the text inserted by bracketed paste and any matching text found by incremental and non-incremental history searches. The default is on. Enable bracketed paste. When set to on, Readline configures the terminal to insert each paste into the editing buffer as a single string of characters, instead of treating each character as if it had been read from the keyboard. This is called putting the terminal into bracketed paste mode. It prevents Readline from executing any editing commands bound to key sequences appearing in the pasted text. The default is on. Enable keypad. When set to on, Readline will try to enable the application keypad when it is called. Some systems need to enable the arrow keys. The default is off. Enable meta key. When set to on, Readline will try to enable any meta modifier key the terminal claims to support when it is called. On many terminals, the meta key is used to send 8-bit characters. The default is on. Expand tilde. If set to on, tilde expansion is performed when readline attempts word completion. The default is off. History preserve point. If set to on, the history code attempts to place the point, the current cursor position, at the same location on each history line retrieved with previous history or next history. The default is off. History size. Set the maximum number of history entries saved in the history list. If set to 0, any existing history entries are deleted and no new entries are saved. If set to a value less than 0, the number of history entries is not limited. By default, the number of history entries is not limited. If an attempt is made to set history size to a non-numeric value, the maximum number of history entries will be set to 500. Horizontal scroll mode. This variable can be set to either on or off. Setting it to on means that the text of the lines being edited will scroll horizontally on a single screen line when they are longer than the width of the screen, instead of wrapping onto a new screen line. This variable is automatically set to on for terminals of height 1. By default, this variable is set to off. Input meta. If set to on, readline will enable 8-bit input. It will not clear the 8th bit in the character it reads, regardless of what the terminal claims it can support. The default value is off, but readline will set it to on if the locale contains 8-bit characters. The name meta flag is a synonym for this variable. This variable is dependent on the LCC type locale category. It may change if the locale is changed. iSearch terminators. The string of characters that should terminate an incremental search without subsequently executing the character as a command. If this variable has not been given a value, the characters escape and Control-Shift-J will terminate an incremental search. Key map. Sets readline's idea of the current key map for key binding commands. Built-in key map names are Emacs, Emacs Standard, Emacs Meta, Emacs CTLX, VI, VI Move, VI Command, and VI Insert. VI is equivalent to VI Command. VI Move is also a synonym. Emacs is equivalent to Emacs Standard. Applications may add additional names. The default value is Emacs. The value of the editing mode variable also affects the default key map. KeySeek timeout. Specifies the duration readline will wait for a character when reading an ambiguous key sequence, one that can form a complete key sequence using the input read so far, or can take additional input to complete with a longer key sequence. If no input is received within the timeout, readline will use the shorter but complete key sequence. Readline uses this value to determine whether or not input is available on the current input source, rl_in stream by default. The value is specified in milliseconds, so a value of 1000 means that readline will wait 1 second for additional input. If this variable is set to a value less than or equal to 0, or to a non-numeric value, readline will wait until another key is pressed to decide which key sequence to complete. The default value is 500. Mark directories. If set to on, completed directory names have a slash appended. The default is on. Mark modified lines. This variable, when set to on, causes readline to display an asterisk at the start of the history lines which have been modified. This variable is off by default. Mark symlinked directories. If set to on, completed names which are symbolic links to directories have a slash appended, subject to the value of marked directories. The default is off. Match hidden files. This variable, when set to on, causes readline to match files whose name begin with a dot. Hidden files. When performing file name completion. If set to off, the leading dot must be supplied by the user in the file name to be completed. This variable is on by default. Menu complete display prefix. If set to on, menu completion displays the common prefix of the list of the possible completions, which may be empty, before cycling through the list. The default is off. Output meta. If set to on, Readline will display characters with the 8-bit set with the 8th bit set directly rather than as a meta prefixed escape sequence. The default is off, but Readline will set this to on if the locale contains 8-bit characters. This variable is dependent on the LCC type locale category and may change if the locale is changed. Page completions. If set to on, Readline uses an internal more like pager to display a screen full of possible completions at a time. This variable is on by default. Print completions horizontally. If set to on, Readline will display completions with matches sorted horizontally in alphabetical order rather than down the screen. The default is off. Revert all at new line. If set to on, Readline will undo all changes to history lines before returning when accept line is executed. By default, history lines may be modified and retain individual undo lists across calls to Readline. The default is off. Show all if ambiguous. This alters the default behavior of the completion functions. If set to on, words that have more than one possible completion cause the matches to be listed immediately instead of ringing the bell. The default value is off. Show all if unmodified. This alters the default behavior of the completion functions in a fashion similar to show all if ambiguous. If set to on, words which have more than one possible completion without any possible partial completion, the possible completions don't share a common prefix, cause the matches to be listed immediately instead of ringing the bell. The default value is off. Show mode in prompt. If set to on, add a string to the beginning of the prompt indicating the editing mode, Emacs, VI command, or VI insertion. The mode strings are user settable, e.g. Emacs mode string. The default value is off. Skip completed text. If set to on, this alters the default completion behavior when inserting a single match into the line. It's only active when performing a completion in the middle of a word. If enabled, Readline does not insert characters from the completion that match characters after point in the word being completed, so portions of the word following the cursor are not duplicated. For instance, if this is enabled, attempting completion when the cursor is after the E in makefile will result in makefile rather than makefile, assuming there is a single possible completion. The default value is off. VI command mode string. If the show mode in prompt variable is enabled, this string is displayed immediately before the last line of the primary prompt when VI editing mode is active and in command mode. The value is expanded like a key binding, so the standard set of meta and control prefixes and / escape sequences is available. Use the \1 and \2 escapes to begin and end sequences of non-printing characters, which can be used to embed a terminal control sequence into the mode string. The default is command. VI insert mode string. If the show mode in prompt variable is enabled, this string is displayed immediately before the last line of the primary prompt when VI editing mode is active and in insertion mode. The value is expanded like a key binding, so the standard set of meta and control prefixes and / escape sequences is available. Use the \1 and \2 escapes to begin and end sequences of non-printing characters, which can be used to embed a terminal control sequence into the mode string. The default is ins. Visible stats. If set to on, a character denoting a file's type is appended to the file name when listing possible completions. The default is off. Key bindings. The syntax for controlling key bindings in the init file is simple. First, you need to know the name of the command that you want to change. The following section contains tables of the command name, the default key binding, if any, and a short description of what that command does. Once you know the name of the command, simply place on a line in the init file the name of the key you wish to bind the command to, a colon, and then the name of the command, there can be no space between the name of the key and the colon. That will be interpreted as part of the key name. The name of the key can be expressed in different ways depending on what you find most comfortable. Once you know the name of the command, simply place on a line in the init file the name of the key you wish to bind the command to, a colon, and then the name of the command. There could be no space between the key name and the colon. That will be interpreted as part of the key name. The name of the key can be expressed in different ways depending on what you find most comfortable. In addition to command names, Readline allows keys to be bound to a string that is inserted when the key is pressed, aka a macro. The bind-p command displays Readline function names and bindings in a format that can be put directly into an initialization file. Key name, function name or macro. Key name is the name of a key spelled out in English. For example, Control-U, universal argument, meta rub out, backward kill word, Control-O, double quote, greater than space output. In the example above, Control-U is bound to the function universal argument, meta delete is bound to the function backward kill word, and Control-O is bound to run the macro expressed on the right-hand side, that is, to insert the text greater than space output into the line. A number of symbolic character names are recognized while processing this key binding syntax. Del, escape, line feed, new line, return, rub out, space, and tab. Key sequence, colon, function name or macro. Keyseq differs from key name above in that strings denoting an entire key sequence can be specified by placing the key sequence in double quotes. Some GNU Emacs style key escapes can be used, as in the following example, but the special character names are not recognized. In the above example, Control-U is again bound to the function universal argument, just as it was in the first example. Control-X, Control-R is bound to the function reread init file, and escape sequence 1 tilde is bound to insert the text function key 1. The following GNU Emacs style escape sequences are available when specifying key sequences: \c control prefix, \m meta prefix, \e an escape character, double backslash is a literal backslash, double quote for a literal double quote, single quote for a literal single quote. In addition to the GNU Emacs style escape sequences, a second set of backslash escapes is available: \a alert or bell, \b backspace, \d delete, \f form feed, \n new line, \r carriage return, \t horizontal tab, \v vertical tab, \nnn the 8-bit character whose value is the octal value nnn, 1 to 3 digits, \x hh 8-bit character whose value is the hexadecimal value hh, 1 or 2 hex digits. When entering the text of a macro, single or double quotes must be used to indicate a macro definition. Unquoted text is assumed to be a function name. In the macro body, the \/ escape sequences described above are expanded. \/ will quote any other character in the macro text, including double quote and single quote. For example, the following binding will make Control-X \/ insert a single \/ into the line. Double quote \/ Control-X double \/ double quote colon space double quote double \/ double quote. 8.3.2 Conditional init constructs. Readline implements a facility similar in the spirit to the conditional compilation features of the C preprocessor, which allows key bindings and variable settings to be performed as the result of tests. there are 4 parser directives used. $if. The $if construct allows bindings to be made based on the editing mode, the terminal being used, or the application using readline. The text of the test, after any comparison operator, extends to the end of the line unless otherwise noted. No characters are required to isolate it. Mode. The mode equals form of the $if directive is used to test whether a readline is in Emacs or VI mode. This may be used in conjunction with the set keymap command, for instance, to set bindings in the Emacs standard and Emacs CTLX keymaps only if readline is starting out in Emacs mode. Term. The term equals form may be used to include terminal-specific key bindings, perhaps to bind the key sequences output by the terminal's function keys. The word on the right side of the equals is tested against both the full name of the terminal and the portion of the terminal name before the first dash. This allows sun to match both sun and sun-command, for example. Version. The version test may be used to perform comparisons against specific readline versions. The version expands to the current readline version. The set of comparison operators includes equals and double equals, not equals, less than or equals, greater than or equals, less than, and greater than. The version numbers supplied on the right side of the operator consist of a major version number, an optional decimal point, and an optional minor version. If the minor version is omitted, it is assumed to be 0. The operator may be separated from the string version and from the version number argument by whitespace. The following example sets a variable if the readline version is being used is 7.0 or newer. $if version greater than or equal to 7.0, set show mode and prompt on, $endif. Application. The application construct is used to include application-specific settings. Each program using the readline library sets the application name, and you can test for a particular value. This could be used to bind key sequences to functions useful for a specific program. For instance, the following command adds a key sequence that quotes the current or previous word in bash. $if bash, quote the current or previous word. Variable. The variable construct provides simple equality tests for readline variables and values. The permitted comparison operators are equals, double equals, and not equals. The variable name must be separated from the comparison operator by whitespace. The operator may be separated from the value on the right-hand side by whitespace. Both string and Boolean variables may be tested. Boolean variables must be tested against the values on and off. The following example is equivalent to the mode equals Emacs test described above. If editing mode equal Emacs, set show mode and prompt on. $endif. This command, as seen in the previous example, terminates an if command. $else. Commands in this branch of the $if directive are executed if the test fails. $include. This directive takes a single file name as an argument and reads commands and bindings from that file. For example, the following directive reads from etc input rc. $include etc input rc. 8.3.3 Sample init file. Here is an example of an input rc file. This illustrates key binding, variable assignment, and conditional syntax. Comment. This file controls the behavior of line input editing for programs that use the GNU Readline library. Existing programs include FTP, Bash, and GDB. You can reread the input RC file with Ctrl-X, Ctrl-R. Lines beginning with pound are comments. First, include any system-wide bindings and variable assignments from etc input rc. $include /etc /input rc. Comment. Set various bindings for Emacs mode. Set editing mode Emacs. $if mode equals Emacs. Meta control H, backward kill word. Text after the function name is ignored. Comment. Arrow keys in keypad mode. 8.4 Bindable Readline Commands. This section describes readline commands that may be bound to key sequences. You can list your key bindings by executing bind-uppercase-p, or, for a more terse format, suitable for an input RC file, bind-lowercase-p. Command names without an accompanying key sequence are unbound by default. In the following descriptions, point refers to the current cursor position, and mark refers to a cursor position saved by the setMark command. The text between the point and the mark is referred to as the region. 8.4.1 Commands for moving. Control-A, move to the start of the current line. Control-E, move to the end of the line. Control-F, move forward a character. Control-B, move backward a character. Meta-F, move forward to the end of the next word. Words are composed of letters and digits. Meta-B, move back to the start of the current or previous word. Words are composed of letters and digits. Meta Control F, move forward to the end of the next word. Words are delimited by non-quoted shell meta characters. Meta Control B, move back to the start of the current or previous word. Words are delimited by non-quoted shell meta characters. We've got some unbound functions. Previous screen line. Attempt to move point to the same physical screen column on the previous physical screen line. This will not have the desired effect if the current readline line does not take up more than one physical line, or if the point is not greater than the length of the prompt plus the screen width. Next screen line. Attempt to move point to the same physical screen column on the next physical screen line. This will not have the desired effect if the current readline line does not take up more than one physical line, or if the length of the current readline line is not greater than the length of the prompt plus the screen width. Meta Control L, clear the screen and, if possible, the terminal scrollback buffer, then redraw the current line, leaving the current line at the top of the screen. Control L, clear the screen, then redraw the current line, leaving the current line at the top of the screen. Redraw current line. Refresh the current line. By default, this is unbound. 8.4.2 Commands for manipulating the history. Accept line, new line or return. Accept the line regardless of where the cursor is. If this line is non-empty, add it to the history list according to the setting of the hist control and hist ignore variables. If this line is a modified history line, then restore the history line to its original state. Previous history, Control P. Move back through the history list, fetching the previous command. Next history, Control N. Move forward through the history list, fetching the next command. Beginning of history, meta less than. Move to the first line in the history. End of history, meta greater than. Move to the end of the input history, i.e. the line currently being entered. Reverse search history, Control R. Search backwards, starting at the current line and moving up through the history as necessary. This is an incremental search. This command sets the region to the match text and activates the mark. Forward search history, Control S. Search forward, starting at the current line and moving down through the history as necessary. This is an incremental search. This command sets the region to the match text and activates the mark. Non-incremental reverse search history, meta P. Search backwards, starting at the current line and moving up through the history as necessary using a non-incremental search for a string supplied by the user. The search string may match anywhere in a history line. Non-incremental forward search history, meta N. Search forward, starting at the current line and moving down through the history as necessary using a non-incremental search for a string supplied by the user. The search string may match anywhere in a history line. History search forward. Search forward through the history for the string of characters between the start of the current line and the point. The search string must match at the beginning of a history line. This is a non-incremental search. By default, this command is unbound. History search backward. Search backward through the history for the string of characters between the start of the current line and the point. The search string must match the beginning of the history line. this is a non-incremental search. By default, the command is unbound. History substring search forward. Search forward through the history for the string of characters between the start of the current line and the point. The search string may match anywhere in a history line. This is a non-incremental search. By default, this command is unbound. History substring search backward. Search backward through the history for the string of characters between the start of the current line and the point. The search string may match anywhere in a history line. This is a non-incremental search. By default, this command is unbound. Yank nth arg. Meta control y. Insert the first argument to the previous command, usually the second word on the previous line at point. With an argument n, insert the nth word from the previous command. The words in the previous command begin with word 0. A negative argument inserts the nth word from the end of the previous command. Once the argument n is computed, the argument is extracted as if the !n history expansion has been specified. Yank last arg, meta dot or meta underscore. Insert last argument to the previous command, the last word of the previous history entry. With a numeric argument, behave exactly like yank nth arg. Successive calls to yank last arg move back through the history list, inserting the last word or the word specified by the argument to the first call of each line in turn. Any numeric argument supplied to these successive calls determines the directive to move through the history. A negative argument switches the direction through the history, back or forward. The history expansion facilities are used to extract the last argument, as if the $$ history expansion had been specified. Operate and get next, Control O. Accept the current line for return to the calling application as if a new line had been entered, and fetch the next line relative to the current line from the history for editing. A numeric argument, if supplied, specifies the history entry to use instead of the current line. Fetch history. Unbound command. With a numeric argument, fetch that entry from the history list and make it the current line. Without an argument, move back to the first entry in the history list. 8.4.3 Commands for changing text. End of file, usually Control D. The character indicating end of file as set, for example, by stty. If this character is read when there are no characters on the line, the point is at the beginning of the line. Readline interprets it as the end of input and returns EOF. Delete character, Control D, deletes the character at point. If this function is bound to the same character as the TTY EOF character, as Control D commonly is, see above for the effects. Backward delete char, rub out. Delete the character behind the cursor. A numeric argument means to kill the characters instead of deleting them. Forward, backward delete char. Delete the character under the cursor unless the cursor is at the end of the line, in which case the character behind the cursor is deleted. By default, this is not bound to a key. Quoted insert, Control Q or Control V. Add the next character typed to the line verbatim. This is how to insert key sequences like Control Q, for example. Self-insert, A, B, A, 1, exclamation mark, insert yourself. Bracketed paste begin. This function is intended to be bound to the bracketed paste escape sequence sent by some terminals, and such a binding is assigned by default. It allows Readline to insert the pasted text as a single unit without treating each character as if it had been read from the keyboard. The characters are inserted as if each one was bound to the self-insert instead of executing any editing commands. Bracketed paste sets the region, the characters between the point and the mark, to the inserted text. It uses the concept of an active mark. When the mark is active, Readline redisplay uses the terminal's standout mode to denote the region. Transpose characters. Control T. Drag the character before the cursor forward over the character at the cursor, moving the cursor forward as well. If the interaction point is at the end of the line, then this transposes the last two characters at the end of the line. Negative arguments have no effect. Transpose words. Meta T. Drag the word before the point, past the word after point, moving point past that word as well. If the insertion point is at the end of the line, this transposes the last two words on the line. Uppercase word. Meta U. Uppercase the current or following word. With a negative argument, uppercase the previous word, but do not move the cursor. Downcase word. Meta L. Lowercase the current or following word. With a negative argument, lowercase the previous word, but do not move the cursor. Capitalize word. Meta C. Capitalize the current or following word. With a negative argument, capitalize the previous word, but do not move the cursor. Overwrite mode. Toggle overwrite mode. With an explicit positive numeric argument, switches to overwrite mode. With an explicit non-positive numeric argument, switches to insert mode. This command affects only Emacs mode. VI mode does overwrite differently. Each call to readline starts in insert mode. In overwrite mode, the character is bound to self-insert and replace the text at point rather than pushing the text to the right. Character is bound to backward delete replace the character before the point with a space. By default, this command is unbound. 8.4.4 Killing and yanking. Kill line. Control K. Kill the text from point to the end of the line. With a negative numeric argument, kill backward from the cursor to the beginning of the current line. Backward kill line. Control X rub out. Kill backward from the cursor to the beginning of the current line. With a negative numeric argument, kill forward from the cursor to the end of the current line. Unix line discard. Control U. Kill backward from the cursor to the beginning of the current line. Kill whole line. Kill all characters on the current line no matter where point is. By default, this is unbound. Kill word. Meta D. Kill from point to the end of the current word, or if between words, to the end of the next word. Word boundaries are the same as forward word. Backward kill word. Meta delete. Kill the word behind point. Word boundaries are the same as backward word. Shell kill word. Meta control D. Kill from point to the end of the current word, or if between words, to the end of the next word. Word boundaries are the same as shell forward word. Shell backward kill word. Kill the word behind point. Word boundaries are the same as shell backward word. Unbound. Shell transpose words. Meta control T. Drag the whole word before point past the word after point, moving point past the word as well. If the insertion point is at the end of the line, this transposes the last two words on the line. Word boundaries are the same as shell forward word and shell backward word. Unix word rub out. Control W. Kill the word behind point using whitespace as a word boundary. The killed text is saved on the kill ring. Unix file rub out. Kill the word behind point using whitespace and the slash character as word boundaries. The killed text is saved on the kill ring. Delete horizontal space. Delete all spaces and tabs around point. By default, this is unbound. Kill region. Kill the text in the current region. By default, this command is unbound. Copy region as kill. Copy the text in the region to the kill buffer so it can be yanked right away. By default, this command is unbound. Copy backward word. Copy the word before point to the kill buffer. The word boundaries are the same as backward word. By default, this command is unbound. Copy forward word. Copy the word following point to the kill buffer. The word boundaries are the same as forward word. By default, this command is unbound. Yank. Control Y. Yank the top of the kill ring into the buffer at point. Yank pop, meta Y. Rotate the kill ring and yank the new top. You can only do this if the prior command is yank or yank pop. 8.4.5, specifying numeric arguments. Digit argument, meta 0, meta 1, etc. Add this digit to the argument already accumulating or start a new argument. Meta dash starts a new negative argument. Universal argument. This is another way to specify an argument. If this command is followed by one or more digits, optionally with a leading minus sign, those digits define the arguments. If the command is followed by digits, executing universal argument again ends the numeric argument, but is otherwise ignored. As a special case, if this command is immediately followed by a character that is neither a digit nor a minus sign, the argument counts for the next command is multiplied by 4. The argument counts is initially 1, so executing this function the first time makes the argument count 4, the second time makes the argument count 16, and so on. By default, this isn't bound to a key. 8.4.6, letting readline type for you. Complete, tab. Attempt to perform completion on the text before point. The actual completion performed is application specific. Bash attempts completion treating the text as a variable if the text begins with $, username if the text begins with tilde, host name if the text begins with @ or command, including aliases and functions in turn. If none of these produce a match, file name completion is attempted. Possible completions, meta question mark. List the possible completions of the text before point. When displaying completions, readline sets the number of columns used for the display to the value of the completion display width, the value of the environment variable columns, or the screen width in that order. Insert completions, meta star. Insert all completions of the text before point that would have been generated by possible completions. Menu complete. Similar to complete, but replaces the word to be completed with a single match from the list of possible completions. Repeated execution of menu complete steps through the list of possible completions, inserting each match in turn. At the end of the list of completions, the bell is rung, subject to the setting of bell style, and the original text is restored. An argument of n moves n positions forward in the list of matches. A negative argument may be used to move backward through the list. This command is intended to be bound to tab, but is unbound by default. Menu complete backward. Identical to menu complete, but moves backwards through the list of possible completions, as if menu complete had been given a negative argument. Delete chars or list. Deletes the character under the cursor, if not at the beginning or end of the line, like delete char. If at the end of the line, behaves identically to possible completions. This command is unbound by default. Complete file name. Meta /. Attempt file name completion on the text before point. Possible file name completions. Control-X /. List the possible completions of the text before point, treating it as a file name. Complete username. Meta tilde. Attempt completion on the text before point, treating it as a username. Possible username completions. Control-X tilde. List the possible completions of the text before point, treating it as a username. Complete variable. Meta $. Attempt completion on the text before point, treating it as a shell variable. Possible variable completions. Control-X $. List the possible completions of the text before point, treating it as a shell variable. Complete host name. Meta @. Attempt completion on the text before point, treating it as a host name. Possible host names completion. Control-X @. List the possible completions of the text before point, treating it as a host name. Complete command. Meta !. Attempt completion of the text before point, treating it as a command name. Command completion attempts to match the text against aliases, reserved words, shell functions, shell built-ins, and finally, executable file names in that order. Possible command completions. Control X exclamation mark. List the possible completions of the text before point, treating it as a command name. Dynamic complete history. Meta tab. Attempt completion on the text before point, comparing the text against lines from the history list for possible completion matches. Deabbrev expand. Attempt menu completion on the text before point, comparing the text against lines from the history list for possible completion matches. Complete info braces. Meta open curly. Perform file name completion and insert the list of possible completions enclosed within braces so the list is available to the shell. 8.4.7 Keyboard macros. Start keyboard macro. Control X open paren. Begin saving the characters typed into the current keyboard macro. End keyboard macro. Control X close paren. Stop saving the characters typed into the current keyboard macro and save the definition. Call last keyboard macro. Control X E. Re-execute the last keyboard macro defined by making the characters in the macro appear as if typed at the keyboard. Print last keyboard macro. Print the last keyboard macro defined in a format suitable for the input RC file. 8.4.8 Some miscellaneous commands. Reread init file. Control X, Control R. Read in the contents of the input RC file and incorporate any bindings or variable assignments found there. Abort. Control G. Abort the current editing command and ring the terminal's bell, subject to the settings of bell style. Do lowercase version. Meta A, meta B, meta X. If the metafied character X is uppercase, run the command that is bound to the corresponding metafied lowercase character. The behavior is undefined if X is already lowercase. Prefix meta, escape. Metafy the next character typed. This is for keyboards without a meta key. Typing escape F is equivalent to typing meta F. Undo. Control underscore or Control X, Control U. Incremental undo, separately remembered for each line. Revert line, meta R. Undo all changes made to this line. This is like executing the undo command enough times to get back to the beginning. Tilde expand, meta ampersand. Perform tilde expansion on the current word. Set mark, Control @ symbol. Set the mark to the point. If a numeric argument is supplied, the mark is set to that position. Exchange point and mark. Control X, Control X. Swap the point with the mark. The current cursor position is set to the saved position, and the old position is saved as the mark. Character search. Control close square bracket. A character is read and point is moved to the next occurrence of that character. A negative argument searches for previous occurrences. Character search backwards. Meta control close square bracket. A character is read and point is moved from the previous occurrence of that character. A negative argument searches for subsequent occurrences. Skip CSI sequence. Read enough characters to consume a multi-key sequence such as those defined for keys like home and end. Such sequences begin with a control sequence indicator, usually escape open square bracket. If this sequence is bound to \E open square bracket, keys producing such sequences will have no effect unless explicitly bound to a readline command, instead of inserting straight characters into the editing buffer. This is unbound by default, but usually bound to escape open square bracket. Insert comment, meta pound. Without a numeric argument, the value of the comment begin variable is inserted at the beginning of the current line. If a numeric argument is supplied, this comment acts as a toggle. If the characters at the beginning of the line do not match the value of comment begin, the value is inserted. Otherwise, the characters in comment begin are deleted from the beginning of the line. In either case, the line is accepted if a new line had been typed. The default value of comment begin causes this command to make the current line a shell comment. If a numeric argument causes the comment character to be removed, the line will be executed by the shell. Dump functions. Print all of the functions and their key bindings to the readline output stream. If a numeric argument is supplied, the output is formatted in such a way that it can be made part of an input RC file. This command is unbound by default. Dump variables. Print all of the settable variables and their values to the readline output stream. If a numeric argument is supplied, the output is formatted in such a way that it can be made part of an input RC file. This command is unbound by default. Dump macros. Print all of the readline key sequences bound to macros and the strings they output. If a numeric argument is supplied, the output is formatted in such a way that it can be made part of an input RC file. This command is unbound by default. Spell correct word. Control-X-S. Perform spelling correction on the current word, treating it as a dictionary or file name in the same way as the cd spell shell option. Word boundaries are the same as those used by the shell forward word. Glob complete word. Meta G. The word before point is treated as a pattern for pathname expansion, with an asterisk implicitly appended. This pattern is used to generate a list of matching files for possible completions. Glob expand word. Control-X star. The word before point is treated as a pattern for pathname expansion, and the list of matching file names is inserted, replacing the word. If a numeric argument is supplied, a star is appended before pathname expansion. Glob list expansions. Control-X-G. The list of expansions that would have been generated by glob expand word is displayed, and the line is redrawn. If a numeric argument is supplied, a star is appended before pathname expansion. Display shell version. Control-X, Control-V. Display version information about the current instance of bash. Shell expand line. Meta Control-E. Expand the line as the shell does. This performs alias and history expansions as well as all of the shell word expansions. History expand line. Meta caret. Perform history expansions on the current line. Magic space. Perform history expansion on the current line and insert a space. Alias expand line. Perform alias expansion on the current line. History and alias expand line. Perform history and alias expansion on the current line. Insert last argument. Meta dot or meta underscore. A synonym for yank last arg. Edit and execute command. Control-X, Control-E. Invoke an editor on the current command line and execute the results as shell commands. Bash attempts to invoke Visual Editor and Emacs as the editor, in that order. 8.5. Readline VI mode. While the Readline library does not have a full set of VI editing functions, it does contain enough to allow simple editing of the line. The Readline VI mode behaves as specified in the Posix standard. In order to switch interactively between Emacs and VI editing modes, use the set-o Emacs and set-o VI commands. The Readline default is Emacs mode. When you enter a line in VI mode, you are already placed in insertion mode as if you had typed an I. Pressing escape switches you into command mode, where you can edit the text of the line with the standard VI movement keys. Move to previous history lines with K and subsequent lines with J, and so forth. 8.6. Programmable Completion. When word completion is attempted for an argument to a command for which a completion specification, a comp spec, has been defined using the complete built-in, the programmable completion facilities are invoked. First, the command name is identified. If a comp spec has been defined for that command, the comp spec is used to generate the list of possible completions for the word. If the command word is the empty string, completion attempted at the beginning of an empty line, any comp spec defined with the -E option to complete is used. If the command word is a full path name, a comp spec for the full path name is searched for first. If no comp spec is found for the full path name, an attempt is made to find a comp spec for the portion following the final slash. If those searches do not result in a comp spec, any comp spec defined with the -D option to complete is used as the default. If there is no default comp spec, bash attempts alias expansion on the command word as a final resort, and attempts to find a comp spec for the command word from any successful expansion. Once a comp spec has been found, it is used to generate the list of matching words. If a comp spec is not found, the default bash completion described above is performed. First, the actions specified by the comp spec are found. Only matches which are prefixed by the word being completed are returned. When the -F or -D option is used for file name or directory name completion, the shell variable's fignore is used to filter the matches. Any completions specified by a filename expansion pattern to the -G option are generated next. The words generated by the pattern need not match the words being completed. The globignore shell variable is not used to filter the matches, but the fignore variable is used. Next, the string specified as the argument to the -W option is considered. The string is first split using the characters in the IFS special variable as delimiters. Shell quoting is honored within the string in order to provide a mechanism for the words to contain shell meta characters or characters in the value of IFS. Each word is then expanded using brace expansion, tilde expansion, parameter and variable expansion, command substitution, and arithmetic expansion, as described above. The results are split using the rules described above. See word splitting. The results of the expansion are prefix matched against the word being completed, and the matching words become the possible completions. After these matches have been generated, any shell functions or commands specified with the -F and -C option is invoked. When the command or function is invoked, the comp line, comp point, comp key, and comp type variables are assigned values as described above. If a shell function is being invoked, the comp words and comp C word variables are also set. When the function or command is invoked, the first argument $1 is the name of the command whose arguments are being completed. The second argument $2 is the word being completed, and the third argument $3 is the word preceding the word being completed on the current command line. No filtering of the generated completions against the word being completed is performed. The function or command has complete freedom in generating the matches. Any function specified with -F is invoked first. The function may use any of the shell facilities, including the compgen and compopt built-ins described below, to generate the matches. It must put the possible completions in the comp reply array variable, one per array element. Next, any command specified with the -C option is invoked in an environment equivalent to the command substitution. It should print a list of completions, one per line, to the standard output. / may be used to escape a new line if necessary. After all of the possible completions are generated, any filter specified with -X is applied to the list. The filter is a pattern used for the path name expansion. A ampersand in the pattern is replaced with the text of the word being completed. A literal ampersand may be escaped with a /. The / is removed before attempting a match. Any completion that matches the pattern will be removed from the list. A leading exclamation mark negates the pattern. In this case, any completion not matching the pattern will be removed. If the no case match shell option is enabled, the match is performed without regard to the case of alphabetic characters. Finally, any prefix and suffix specified with the -P and -S options are added to each member of the completion list, and the result is returned to the readline completion code as the list of possible completions. If the previously applied actions do not generate any matches and the -O dirnames option was supplied to complete when the comp spec was defined, directory name completion is attempted. If the -O plus dirs option was supplied to complete when the comp spec was defined, directory name completion is attempted and any matches are added to the results of the other actions. By default, if a comp spec is found, whatever it generates is returned to the completion code as the full set of possible completions. Default bash completions are not attempted, and the readline default file name completion is disabled. If the -O bash default option was supplied to complete when the comp spec was defined, the default bash completions are attempted if the comp spec generates no matches. If the -O default option was supplied to the complete when the comp spec was defined, Readline's default completion will be performed if the comp spec and if attempted, the default bash completions generate no matches. When a comp spec indicates that directory name completion is desired, the programmable completion functions force Readline to append a slash to completed names which are symbolic links to directories, subject to the value of the mark directories readline variable, regardless of the setting of the mark symlink to directories readline variable. There is some support for dynamically modifying completions. This is most useful when used in combination with the default completion specified with -d. It's possible for shell functions executed as completion handlers to indicate that completion should be retried by returning an exit status of 124. If a shell function returns 124 and changes the comp spec associated with the command on which completion is being attempted, supplied as the first argument when the function is executed, programmable completion restarts from the beginning with an attempt to find a new comp spec for that command. This allows a set of completions to be built dynamically as completion is attempted, rather than being loaded all at once. For instance, assuming that there is a library of comp specs, each kept in a file corresponding to the name of the command, the following default completion function would load completions dynamically. _completion loader, parentheses, new line, curly brace, new line, dot, etc bash completion.d / $1.sh, redirected to dev null with standard error redirected to standard out, and return 124, and then we call complete -d -f _completion _loader -o bash -o bash default -o default should set up the dynamic completion. 8.7 Programmable completion built-ins. 3 built-in commands are available to manipulate the programmable completion facilities. 1 to specify how the arguments to a particular command are to be completed, and 2 to modify the completion as it is happening. Compgen. Compgen takes an optional option and an optional word. It generates possible completion matches for word according to the options, which may be any option accepted by the complete built-in, with the exception of -p and -r, and write the matches to the standard output. When using -f or -c options, the various shell variables set by the programmable completion facilities, while available, will not have useful values. The matches will be generated in the same way as if the programmable completion code had generated them directly from a completion specification with the same flags. If word is specified, only those completions matching word will be displayed. The return value is true unless an invalid option is supplied or no matches were generated. Complete takes the flags A, B, C, D, E, F, G, J, K, S, U, V, and optionally a -o comp option, and also optionally capital DEI flags, and also -a action optionally, and also optionally a -g glob pattern, and also some other things. Specify how arguments to each name should be completed. If the -p option is supplied, or if no options are supplied, existing completion specifications are printed in a way that would allow them to be reused as input. The -r option removes a completion specification for each name, or if no names are supplied, all completion specifications. The -D option indicates that the other supplied options and actions should apply to the default command completion. That is, completion attempted on a command for which no completion has previously been defined. The -E option indicates that other supplied options and actions should apply to the empty command completion. That is, completion attempted on a blank line. The -I option indicates that other supplied options and actions should apply to completion on the initial non-assignment word on the line, or after a command delimiter such as semicolon or pipe, which is usually command name completion. If multiple options are supplied, the -D option takes precedence over -E, and both take precedence over -I. If any of dash uppercase D, dash uppercase E, or dash uppercase I are supplied, any other name arguments are ignored. These completions only apply to the case specified by the option. The process of applying these completion specifications when word completion is attempted is described above. Other options, if specified, have the following meanings. The arguments to the -G, -W, and -X command or options, and if necessary, the -P and -S options should be quoted to protect them from expansion before the complete built-in is invoked. The -O comp option controls several aspects of the comp spec's behavior beyond the simple generation of completions. Comp option may be one of bash default, perform the rest of the default bash completions if the comp spec generates no matches. Default, use readline's default file name completion if the comp spec generates no matches. Dir names, perform directory name completion if the comp spec generates no matches. File names, tell Readline that the comp spec generates file names so it can perform any file name specific processing, like adding a slash to directory names, quoting special characters, or suppressing trailing spaces. This option is intended to be used with shell functions specified with -F. No quote. Tell Readline not to quote the completed words if they are file names. Quoting file names is the default. No sort. Tell Readline not to sort the list of possible completions alphabetically. No space. Tell Readline not to append a space, the default, to words completed at the end of the line. Plus dirs. After any match defined by the comp spec are generated, directory name completion is attempted and any matches are added to the result of the other actions. -A action. The action may be one of the following to generate a list of possible completions. Alias. Alias names may also be specified as -A. Array var, array variable names. Binding, readline key binding names. Built-in, names of shell built-in commands may also be specified as -B. Command, command names may also be specified as -C. Directory, directory names may also be specified as -D. Disabled, names of disabled shell built-ins. Enabled, names of enabled shell built-ins. Export, names of exported shell variables may also be specified as -E. File, which is file names, may also be specified as -F. Function, names of shell functions. Group, group names may also be specified as -G. Help topic, help topics as accepted by the help built-in. Host name, host names as taken from the file specified by the host file shell variable. Job, job names if job control is active, may also be specified as -J. Keyword, shell reserved words may also be specified as -K. Running, names of running jobs if job control is active. Service, service names may also be specified as -S. Setopt, valid arguments for the -O option to the set built-in. Shopped, shell option names as accepted by the shopped built-in. Signal, signal names. Stopped, names of stopped jobs if job control is active. User, usernames may also be specified as -U. Variable, names of all shell variables may also be specified as -V. -C, command. Command is executed in a subshell environment, and its output is used as the possible completions. Arguments are passed as with the -F option. -F function. The shell function is executed in the current shell environment. When it is executed, $1 is the name of the command whose argument is being completed. $2 is the word being completed, and $3 is the word preceding the word being completed, as described above. When it finishes, the possible completions are retrieved from the value of the comp reply array variable. -G, globpat. The filename expansion pattern globpat is expanded to generate the possible completions. -P prefix. Prefix is added at the beginning of each possible completion after all other options have been applied. -S suffix. suffix is appended to each possible completion after all other options have been applied. Dash uppercase W word list. The word list is split using the characters in the IFS special variable as delimiters, and each resultant word is expanded. The possible completions are the members of the resultant list, which match the word being completed. And dash uppercase X filter pat. Filter pat is a pattern as used for filename expansion. It is applied to the list of possible completions generated by the preceding options and the arguments, and each completion matching filter pat is removed from the list. A leading exclamation mark in filter pat negates the pattern. In this case, any completion not matching filter pat is removed. The return value is true, unless an invalid option is supplied. An option other than -p or -r is supplied without a name argument. An option is made to remove a completion specification for a name for which no specification exists, or an error occurs adding a completion specification. Comp opt. Comp opt with an optional -o option, optional uppercase DEI flags, optional +o option, and an optional name. Modify completion options for each name according to the options or for the currently executing completion if no names are supplied. If no options are given, display the completion options for each name or the current completion. The possible values of option are those valid for the complete built-in described above. The -uppercase D option indicates that other supplied options should apply to the default command completion. That is, completion attempted on a command for which no completion has previously been defined. The -uppercase E option indicates that other supplied options should apply to empty command completion. That is, completion attempted on a blank line. The -uppercase I option indicates that other supplied options should apply to completion on the initial non-assignment word on the line, or after a command delimiter such as semicolon or pipe, which is usually command name completion. If multiple options are supplied, the -D option takes precedence over -E, and both take precedence over -I. The return value is true unless an invalid option is supplied. An attempt is made to modify the options for a name for which no completion specification exists, or an output error occurs. 8.8. A programmable completion example. The most common way to obtain additional completion functionality beyond the default actions complete and compgen provide is to use a shell function and bind it to a particular command using complete -uppercase F. The following function provides completions for the CD built-in. It is a reasonably good example of what shell functions must do when used for completion. This function uses the word passed as $2 to determine the directory name to complete. You can also use the comp words array variable. The current word is indexed by the comp cword variable. The function relies on the complete and compgen built-ins to do much of the work, adding only the things that the bash cd does beyond accepting basic directory names. Tilde expansion, searching directories in CD path, which is described above, and basic support for the cdable variables shell option. _comp_cd modifies the value of IFS so that it contains only a new line to accommodate file names containing spaces and tabs. Compgen prints the possible completions it generates one per line. Possible completions go into the comp reply array variable, one completion per array element. The programmable completion system retrieves the completions from there when the function returns. We install the completion function using the -uppercase F option to complete. Complete -o, file names -o, no space -o, bash default -uppercase F _comp_cd space cd. Since we'd like bash and readline to take care of some of the other details for us, we use several other options to tell bash and readline what to do. The -o file names option tells readline that the possible completions should be treated as file names and quoted appropriately. That option will also cause readline to append a slash to file names it can determine are directories, which is why we might want to extend compcd to append a slash if we're using directories found via CD path. Readline can't tell those completions are directories. The -o no space option tells readline to not append a space character to the directory name in case we want to append to it. The -o-default option brings in the rest of the bash default completions, possible completions that bash adds to the default readline set. These include things like command naming completion, variable completion for words beginning with $ or $ open curly, completions containing path name expansion patterns, and so on. Once installed using complete, _comp_cd will be called every time we attempt word completion for a cd command. Many more examples, an extensive collection of completions for most of the common GNU, Unix, and Linux commands are available as part of the bash completion project. This is installed by default on many GNU Linux distributions. Originally written by Ian MacDonald, the project now lives at GitHub. There are ports for other systems such as Solaris and Mac OS X. An older version of the bash completion package is distributed with bash in the examples complete subdirectory. Chapter 9, Using History Interactively. This chapter describes how to use the GNU History Library interactively from a user's standpoint. It should be considered a user's guide. For information on using the GNU History Library in other programs, see the GNU Readline Library Manual. 9.1 Bash History Facilities. When the -o history option to the set built-in command is enabled, the shell provides access to the command history, the list of commands previously typed. The value of hist size shell variable is used as the number of commands to save in the history list. The text of the last hist size commands, default 500, is saved. The shell stores each command in the history list prior to parameter and variable expansion, but after history expansion is performed, subject to the values of the shell variables histignore and histcontrol. When the shell starts up, the history is initialized from the file named by the hist file variable, default.bash history. The file named by the value of hist file is truncated, if necessary, to contain no more than the number of lines specified by the value of the hist file size variable. When a shell with a history enabled exits, the last hist size lines are copied from the history list to the file named hist file. If the hist append shell option is set, the lines are appended to the history file, otherwise the history file is overwritten. If hist file is unset, or if the history file is unwritable, the history is not saved. After saving the history file is truncated to contain no more than hist file size lines. If hist file size is unset or set to null, a non-numeric value, or a numeric value less than 0, the history file is not truncated. If the hist time format is set, the timestamp information associated with each history entry is written to the history file, marked with the history comment character. When the history file is read, lines beginning with the history comment character followed immediately by a digit are interpreted as timestamps for the following history entry. The built-in command fc may be used to list or edit and re-execute a portion of the history list. The history built-in may be used to display or modify the history list and manipulate the history file. When using command line editing, search commands are available in each editing mode that provide access to the history list. The shell allows control over which commands are saved on the history list. The histcontrol and histignore variables may be set to cause the shell to save only a subset of the commands entered. The command hist shell option, if enabled, causes the shell to attempt to save each line of a multi-line command in the same history entry, adding semicolons where necessary to preserve syntactic correctness. The lit hist shell option causes the shell to save the command with embedded new lines instead of semicolons. The shopped built-in is used to set these options. 9.2 Bash History Built-ins. Bash provides two built-in commands which manipulate the history list and history file. fc. The first form of fc selects a range of commands from first to last from the history list and displays or edits and re-executes them. Both first and last may be specified as a string to locate the most recent command beginning with that string, or as a number, an index into the history list, where a negative number is used as an offset from the current command number. When listing, a first or last of 0 is equivalent to -1 and -0 is equivalent to the current command, usually the fc command. Otherwise, 0 is equivalent to -1 and -0 is invalid. If last is not specified, it is set to first. If first is not specified, it is set to the previous command for editing and -16 for listing. If the -L flag is given, the commands are listed on standard output. The -N flag suppresses the command numbers when listing. The -R flag reverses the order of the listing. Otherwise, the editor given by ename is invoked on a file containing those commands. If ename is not given, the value of the following variable expansion is used: fcedit : editor : vi. This says to use the value of the fc variable if set, or use the value of the editor variable if that is set, or vi if neither is set. When editing is complete, the edited commands are echoed and executed. In the second form, the command is re-executed after each instance of pat in the selected command is replaced by rep. Command is interpreted the same as first above. A useful alias to use with the fc command is r equals fc-s, so that typing rcc runs the last command beginning with cc, and typing r re-executes the last command. History. With no options, history displays the history list with line numbers. Lines prefixed with a star have been modified. An argument of n lists only the last n lines. If the shell variable hist time format is set and not null, it is used as a format string for strf time to display the timestamp associated with each displayed history entry. No intervening blank is printed between the formatted timestamp and the history line. Options, if supplied, have the following meanings. -C, clear the history list. This may be combined with other options to replace the history list completely. -D, offset. Delete the history entry at position offset. If offset is positive, it should be specified as it appears when the history is displayed. If offset is negative, it should be interpreted as relative to 1 greater than the last history position. So negative indices count back from the end of the history, and an index of -1 refers to the current history -D command. -D start -end. Delete the range of history entries between positions start and end inclusive. Positive and negative values for start and end are interpreted as described above. -A, append the new history lines to the history file. These are history lines entered since the beginning of the current bash session, but not already appended to the history file. -N, append the history lines not already read from the history file to the current history list. These are lines appended to the history file since the beginning of the current bash session. -R, read the history file and append its contents to the history list. -W, write out the current history list to the history file. -P, perform history substitution on the args and display the result on the standard output without storing the results in the history list. -S, the args are added to the end of the history list as a single entry. If a file name argument is supplied when any of the -W, -R, -A, or -N options are used, bash uses file name as the history file. If not, then the value of the hist file variable is used. The return value is 0 unless an invalid option is encountered, an error occurs while reading or writing the history file, an invalid offset or range is supplied as an argument to -D, or the history expansion supplied as an argument to -P fails. 9.3 History Expansion. The history library provides a history expansion feature that is similar to the history expansion provided by CSH. This section describes the syntax used to manipulate the history information. History expansions introduce words from the history list into the input stream, making it easy to repeat commands, insert the arguments to a previous command into the current input line, or fix errors in previous commands quickly. History expansion is performed immediately after a complete line is read, before the shell breaks it into words, and is performed on each line individually. Bash attempts to inform the history expansion functions about quoting still in effect from previous lines. History expansion takes place in two parts. The first is to determine which line from the history list should be used during substitution. The second is to select portions of that line for inclusion into the current one. The line selected from the history is called the event, and the portions of that line that are acted upon are called words. Various modifiers are available to manipulate the selected words. The line is broken into words in the same fashion that Bash does, so that several words surrounded by quotes are considered one word. History expansions are introduced by the appearance of the history expansion character, which is exclamation mark by default. History expansion implements shell-like quoting conventions. A backslash can be used to remove the special handling for the next character. Single quotes enclose verbatim sequences of characters and can be used to inhibit history expansion. And characters enclosed within double quotes may be subject to history expansion, since backslash can escape the history expansion character, but single quotes may not, since they are not treated specially within double quotes. When using the shell, only backslash and single quote may be used to escape the history expansion character, but the history expansion character is also treated as quoted if it immediately precedes the closing double quotes in a double quoted string. Several shell options set table with the shopped built-in may be used to tailor the behavior of history expansion. If the hist_verify shell option is enabled and a read line is being used, history substitutions are not immediately passed to the shell parser. Instead, the expanded line is reloaded into the Readline Editing buffer for further modification. If readline is being used and the hist_reedit shell option is enabled, a failed history expansion will be reloaded into the Readline Editing buffer for correction. The -p option to the history built-in command may be used to see what a history expansion will do before using it. The -s option to the history built-in may be used to add commands to the end of the history list without actually executing them, so that they are available for subsequent recall. This is most useful in conjunction with readline. The shell allows control of the various characters used by the history expansion mechanism with the histchars variable, as explained above. The shell uses the history comment character to mark history timestamps when writing the history file. 9.3.1 Event Designators. An event designator is a reference to a command line entry in the history list. Unless the reference is absolute, events are relative to the current position in the history list. Exclamation mark. Start a history substitution, except when followed by a space, tab, the end of the line, equals, or open paren, when the extglob shell option is enabled using the shopped built-in. Exclamation mark n. Refer to command line n. Exclamation mark -n. Refer to the command n lines back. Exclamation mark, refer to the previous command. This is a synonym for exclamation mark -1. Exclamation mark string. Refer to the most recent command preceding the current position in the history list starting with string. Exclamation mark string, optionally question mark. Refer to the most recent command preceding the current position in the history list containing string. The trailing question mark may be omitted if the string is followed immediately by a new line. If string is missing, the string from the most recent search is used. It is an error if there is no previous search string. *string1 *string2 quick substitution. Repeat the last command replacing string1 with string2, equivalent to exclamation mark colon s *string1 *string2 exclamation mark pound, the entire command line typed so far. 9.3.2 Word Designators. Word designators are used to select desired words from the event. A colon separates the event specification from the word designator. It may be omitted if the word designator begins with a $, star, dash, or %. Words are numbered from the beginning of the line, with the first word being denoted by 0. Words are inserted into the current line separated by single spaces. For example, exclamation mark designates the preceding command. When you type this, the preceding command is repeated in toto. Exclamation mark, colon, dollar designates the last argument of the preceding command. This may be shortened to exclamation mark dollar. Exclamation mark fi colon 2 designates the second part of the most recent command starting with the letters fi. Here are some word designators. 0, the 0th word. For many applications, this is the command word. N, the nth word. Caret, the first argument, that is word 1. $, the last argument. Percent, the first word matched by the most recent string search if the search string begins with a character that is part of the word. X-Y, a range of words. -y abbreviates 0-y. Star, all of the words except the 0th. This is a synonym for $1. It is not an error to use star if there is just one word in the event. The empty string is returned in that case. X star abbreviates X dash $. X dash abbreviates X dash $, like X star, but omits the last word. If X is missing, it defaults to 0. If a word designator is supplied without an event specification, the previous command is used as the event. 9.3.3 Modifiers. After the optional word designator, you can add a sequence of one or more of the following modifiers, each preceded by a colon. These modify or edit the word or words selected from the history event. H. Remove a trailing path name component, leaving only the head. T. Remove all leading path name components, leaving the tail. R. Remove a trailing suffix of the form dot suffix, leaving the base name. E. Remove all but the trailing suffix. P. Print the new command but do not execute it. Q. Quote the substituted words, escaping further substitutions. X. Quote the substituted words as with Q, but break into words at spaces, tabs, and new lines. The Q and X modifiers are mutually exclusive. The last one supplied is used. S/old/new/. Substitute new for the first occurrence of old in the event line. Any character may be used as the delimiter in place of slash. The delimiter may be quoted in old and new with a single backslash. If ampersand appears in new and is replaced by old, a single backslash will quote the ampersand. If old is null, it is set to the last old substituted, or if no previous history substitutions took place, the last string in a exclamation mark, string, search. If new is null, each matching old is deleted. The final delimiter is optional if it is the last character on the input line. Ampersand. Repeat the previous substitution. G or A. Cause changes to be applied over the entire event line, used in conjunction with S, as in gs/old/new/ or with ampersand. Uppercase G. Apply the following S or ampersand modifier once to each word in the event. 10. Installing Bash. This chapter provides basic instructions for installing Bash on the various supported platforms. The distribution supports the GNU operating systems, nearly every version of Unix, and several non-Unix systems such as BOS and Interix. Other independent ports exist for MS-DOS, OS/2, and Windows platforms. 10.1 Basic Installation. These are installation instructions for Bash. The simplest way to compile Bash is Step 1. cd to the directory containing the source code and type /configure to configure Bash for your system. If you're using CSH on an old version of System 5, you might need to type sh./configure instead to prevent CSH from trying to execute configure itself. Running configure takes some time. While running, it prints messages telling which features it is checking for. 2. Type make to compile bash and build the bash bug reporting script. 3. Optionally, type make tests to run the bash test suite. 4. Type make install to install bash and bash bug. This will also install the manual pages and info file, message translation files, some supplemental documentation, a number of example loadable built-in commands, and a set of header files for developing loadable built-ins. You may need additional privileges to install bash to your desired destination, so sudo make install might be required. More information about controlling the locations where bash and other files are installed is below. The configure shell script attempts to guess correct values for various system-dependent variables used during compilation. It uses those values to create a make file in each directory of the package. The top directory, the built-ins, doc, PO, and support directories, each directory under lib, and several others. It also creates a config.h file containing system-dependent definitions. Finally, it creates a shell script named config.status that you can run in the future to recreate the current configuration. A file config.cache that saves the results of its tests to speed up reconfiguring, and a file config.log containing compiler output, useful mainly for debugging configure. If at some point config.cache contains results you don't want to keep, you may remove or edit it. To find out more about the options and arguments that the configure script understands, type /configure --help at the bash prompt in your bash source directory. If you want to build bash in a directory separate from the source directory, to build for multiple architectures, for example, just use the full path to the configure script. The following command will build bash in a directory under user local build from the source code in user local source bash 4.4. Make dir user local build bash 4.4, cd user local build bash 4.4, bash user local source bash 4.4 configure, make. See compiling for multiple architectures for more information about building in a directory separate from the source. If you need to do unusual things to compile bash, please try to figure out how configure could check whether or not to do them and mail diffs or instructions to bash maintainers at gnu.org so they can be considered for the next release. The file configure.ac is used to create configure by a program called autoconf. You only need configure.ac if you want to change it or regenerate configure using a newer version of autoconf. If you do this, make sure you're using autoconf version 2.69 or newer. You can remove the program binaries and object files from the source code directory by typing make clean. To also remove the files that configure created, so you can compile bash for a different kind of computer, type make dist clean. 10.2 Compiler and options. Some systems require unusual options for compilation or linking that the configure script does not know about. You can give configure initial values for variables by setting them in the environment. Using a born-compatible shell, you can do that on the command line like this. cc equals c89, cflags equals -02, libs equals -l posix, /configure. On systems that have the env program, you can do it like this. env cpp flags equals -i user local include, ld flags equals -s, /configure. The configuration process uses GCC to build bash if it's available. 10.3 Compiling for multiple architectures. You can compile bash for more than one kind of computer at the same time by placing the object files for each architecture in their own directory. To do this, you must use a version of make that supports the vpath variable, such as GNU make. cd to the directory where you want the object files and executables to go, and run the configure script from the source directory. You may need to supply the --source dir equals path argument to tell configure where the source files are. Configure automatically checks for the source code in the directory that configure is in, and also in .. If you have to use a make that does not support the vpath variable, you can compile bash for one architecture at a time in the source code directory. After you have installed bash for the first architecture, use make dist clean before reconfiguring another architecture. Alternatively, if your system supports symbolic links, you can use the support/make clone scripts to create a build tree which has symbolic links back to each file in the source directory. Here's an example that creates a build directory in the current directory from a source directory user GNU source bash 2.0. Bash user GNU source bash 2.0 support make clone -s /user/GNU/source/bash 2.0 dot. The make clone script requires bash, so you must have already built bash for at least one architecture before you can create build directories for other architectures. 10.4 Installation names. By default, make install will install into user local bin, user local man, etc. That is, the installation prefix defaults to user local. You can specify an installation prefix other than user local by giving configure the option -- prefix equals path, or by specifying a variable for the prefix make variable when running make install, e.g. make install prefix equals path. The prefix variable provides a default for exec prefix and other variables when installing bash. You can specify separate installation prefixes for architecture-specific files and architecture-independent files. If you give configure the option -- exec prefix equals path, make install will use path as the prefix for installing programs and libraries. Documentation and other data files will still use the regular prefix. If you would like to change the installation locations for a single run, you can specify these variables as arguments to make. Make install exec prefix equals / will install bash and bashbug into /bin instead of the default user local bin. If you want to see the files bash will install and where it will install them without changing anything on your system, specify the variable destdir as an argument to make. Its value should be the absolute directory path you'd like to use as the root of your sample installation tree. For example, make dir fs1 bash install. Make install destdir equals fs1 bash install. We'll install bash into fs1 bash install user local bin bash, the documentation into the directories within fs1 bash install user local share, and the example loadable built-ins into fs1 bash install user local lib bash, and so on. You can use the usual exec prefix and prefix variables to alter the directory paths beneath the value of destdir. The GNU Makefile standards provide a more complete description of these variables and their effects. 10.5 Specifying the system type. There may be some features configure cannot figure out automatically, but needs to determine by the type of host bash will run on. Usually configure that out, but if it prints a message saying it cannot guess the host type, give it the -- host equals type option. Type can either be a short name for the system type, such as sun4, or a canonical name with 3 fields, CPU-company-system. For example, i386-unknown-freebsd 4.2. See the file support/config.sub for the possible values of each field. 10.6 Sharing defaults. If you want to set default values for configure scripts to share, you can create a site shell script called config.site that gives default values for variables like cc, cache file, and prefix. Configure looks for prefix /share/config.site if it exists, then prefix /etc/config.site if it exists. Or you can set the config site environment variable to the location of the site script. A warning though, the bash configure looks for a site script, but not all configure scripts do. 10.7 Operation controls. Configure recognizes the following options to control how it operates. -- cache file equals file. Use and save the results of the tests in file instead of /config.cache. Set file to dev null to disable caching for debugging configure. -- help. Print a summary of the options to configure and exit. -- quiet, -- silent, or -q. Do not print messages saying which checks are being made. -- source dir equals dir. Look for the bash source code in directory dir. Usually configure can determine that directory automatically. -- version. Print the version of autoconf used to generate the configure script and exit. Configure also accepts some other not widely used boilerplate options. Configure -- help prints the complete list. 10.8 Optional features. The bash configure has a number of -- enable feature options where a feature indicates an optional part of bash. There are also several -- with package options where package is something like bash malloc or purify. To turn off the default use of a package, use -- without package. To configure bash without a feature that is enabled by default, use -- disable feature. Here is a complete list of the -- enable and -- with options that the bash configure recognizes. With AFS, define if you are using the Andrew file system from Transarch. With bash malloc, use the bash version of malloc in the directory libmalloc. This is not the same malloc that appears in GNU libc, but an older version originally derived from the 4.2 BSD malloc. This malloc is very fast, but wastes some space in each allocation. This option is enabled by default. The notes file contains a list of systems for which this should be turned off, and configure disables this option automatically for a number of systems. With curses, use the curses library instead of the term cap library. This should be supplied if your system has an inadequate or incomplete term cap database. With GNU malloc, a synonym for with bash malloc. With installed readline, define this to make bash link with a locally installed version of readline rather than the version in lib readline. This works only with readline 5.0 and later versions. If prefix is yes or not supplied, configure uses the value of the make variables includedir and libdir, which are subdirectories of prefix by default, to find the installed versions of readline if it is not installed in the standard system include and library directories. If prefix is no, bash links with the version in lib/readline. If prefix is set to any other value, configure treats it as a directory path name and looks for the installed version of readline in subdirectories of that directory, including files in prefix/include and the library in prefix/lib. With lib international prefix, define this to make bash link with a locally installed version of the lib international library instead of the version in lib/international. With lib iconv prefix, define this to make bash look for lib iconv in prefix instead of the standard system locations. There is no version included with bash. Enable minimal config. This produces a shell with minimal features close to the historical Bourne shell. There are several -- enable options that alter how bash is compiled, linked, and installed, rather than changing runtime features. Enable large file. Enable support for large files if the operating system requires special compiler options to build programs which can access large files. This is enabled by default, if the operating system provides large file support. Enable profiling. This builds a bash binary that produces profiling information to be processed by gprof each time it is executed. Enable separate help files. Use external files for the documentation displayed by the help built-in instead of storing the text internally. Enable static link. This causes bash to be linked statically if GCC is being used. This could be used to build a version to use as root shell. The minimal config option can be used to disable all of the following options, but it is processed first, so individual options may be enabled using enable feature. all of the following options except for alt array implementation, disabled built-ins, dir expand default, strict Posix default, and xpg echo default are enabled by default, unless the operating system does not provide the necessary support. Enable alias. Allows alias expansion and includes the alias and unalias built-ins. Enable alt array implementation. This builds bash using an alternate implementation of arrays that provide faster access at the expense of using more memory, sometimes many times more, depending on how sparse an array is. Enable arith for command. Includes support for the alternate form of the for command that behaves like the C language for statement. Enable array variables. Includes support for one-dimensional array shell variables. Enable bang history. Includes support for CSH-like history substitution. Enable brace expansion. Enables CSH-like brace expansion. See brace expansion for a complete description. Enable case mod attributes. Includes support for case modifying attributes in the declare built-in and assignment statements. Variables with the uppercase attribute, for example, will have their values converted to uppercase upon assignment. Enable case mod expansion. Includes support for case modifying word expansions. Enable commands timing. Includes support for recognizing time as a reserved word and for displaying timing statistics for the pipeline following time. This allows pipelines as well as shell built-ins and functions to be timed. Enable cond command. Includes support for the double square bracket conditional command. Enable cond regular expression. Includes support for matching Posix regular expressions using the equals tilde binary operator in the double square brackets conditional command. Enable co-processes. Includes support for co-processes and the co-proc reserved word. Enable debugger. Includes support for the bash debugger, distributed separately. Enable dev fd stat broken. If calling stat on dev fdn returns different results than calling fstat on file descriptor n, supply this option to enable a workaround. This has implications for conditional commands that test file attributes. Enable dir expand default. Cause the dir expand shell option to be enabled by default when the shell starts. It is normally disabled by default. Enable directory stack. Includes support for a C shell-like directory stack and the pushd, popd, and dirs built-ins. Enable disabled built-ins. Allow built-in commands to be invoked via built-in xxx even after xxx has been disabled using enable-n xxx. See bash built-in commands for details of the built-in and enable built-in commands. Enable dparen arithmetic. Includes support for the double paren arithmetic command. Enable extended glob. Includes support for the extended pattern matching features described above under pattern matching. Enable extended glob default. Set the default value of the ext glob shell to option described above under the shopped built-in to be enabled. Enable function import. Includes support for importing functions for importing function definitions exported by another instance of the shell from the environment. This option is enabled by default. Enable glob ASCII range default. Set the default value of the glob ASCII ranges shell option described under the shopped built-in to be enabled. This controls the behavior of character ranges when used in pattern matching bracket expressions. Enable help built-in. Includes the help built-in, which displays help on shell built-ins and variables. Enable history. Include command history and the fc and history built-in commands. Enable job control. This enables the job control feature if the operating system supports them. Enable multi-byte. This enables support for multi-byte characters if the operating system provides the necessary support. Enable net redirections. This enables the special handling of file names of the form dev TCP host port and dev UDP host port when used in redirections. Enable process substitution. This enables process substitution if the operating system provides the necessary support. Enable prompt string decoding. Turn on the interpretation of a number of / escaped characters in the PS0, PS1, PS2, and PS4 prompt strings. See controlling the prompt for a complete list of prompt string escape sequences. Enable prog comp. Enable the programmable completion facilities. If readline is not enabled, this option has no effect. Enable readline. Include support for command line editing and history with the bash version of the readline library. Enable restricted. Include support for a restricted shell. If this is enabled, bash, when called as rbash, enters a restricted mode. See the restricted shell for a description of restricted mode. Enable select. Include the select compound command, which allows the generation of simple menus. Enable single help strings. Store the text displayed by the help built-in as a single string for each help topic. This aids in translating the text to different languages. You may need to disable this if your compiler cannot handle very long string literals. Enable strict POSIX default. Make bash POSIX conformant by default. Enable translatable strings. Enable support for $string translatable strings. Enable USG echo default, a synonym for enable XPG echo default. Enable XPG echo default. Make the echo built-in expand / escaped characters by default without requiring the -e option. This sets the default value of the XPG echo shell option to on, which makes the bash echo behave more like the version specified in the single Unix specification, version 3. See bash built-in commands for a description of the escape sequences that echo recognizes. The file config-top.h contains C preprocessor #define statements for options which are not settable from configure. Some of these are not meant to be changed. Beware of the consequences if you do. Read the comments associated with each definition for more information about its effect. We made it. If you like Linux stuff, you may like this. Yeah, I'm good. I don't really feel like doing any more reading right now, but I might do that later. I'll definitely put that on my read later list. I kind of feel like I'm done reading for ever. Next stream we're doing the POSIX standard.